Alright, let us now look at this contract section. This is the URL and I'm here in this part of the documentation. So regarding this contract, this creation of contracts, we have as such seen the basics, that the recipient is set to null and the payload is taken to be the EVM bytecode. We have seen and understood that. Regarding further details, when a contract is created, its constructor. Now here I am telling about the constructor. A function declared with the constructor keyword, as we have seen, is executed once. A constructor is optional. Only one constructor is allowed, which means overloading is not supported. Now there is this concept of function overloading, which we will see in detail later, but if I were to give you a glimpse of it, basically let me show it with the help of an example with the diagram. Overloading is basically, suppose I have one function and I have its definition based on some set of input parameters, let's just say an integer. Then I have the same function defined again having its some other definition, but this is for say some another parameter. So when we have multiple function definitions of the same name which differ because of their input parameters, that is what you can think of as function overloading. We will see that in detail later also. So here constructor overloading is not supported. You can only define it once at most. After the constructor has executed, the final code of the contract is stored on the blockchain. This code includes all public and external functions and all functions that are reachable from there through function calls. The deployed code does not include the constructor code. The constructor code is not included in the final deployed code or internal functions only called from the constructor. Now regarding internal functions, I think by the name it is clear that internal functions can only be called internally, that is the same contract can call them internally, which executes via a jump statement, not by the external message calls. So if I have an internal function only being called by the constructor, not anywhere else, so even in that case its code is not included in the final deployed code. And certainly the functions which are supported to be called externally by some other contracts, namely public and external functions, we will see their definitions formally, are included, and all the other functions too which can be reached via them. Moving on, regarding this part, the creation, how one contract creates another contract, we have seen it, but I just want to give one a catch here. Here if you notice, there is this contract owned token and then there is one more contract token creator. So there are two contracts here defined. One is this token creator and one is this own token. Now it is not possible for me to have something like here inside this own token I create a new instance of token creator using that new keyword, and inside token creator itself I am creating this owned tokens instance using this new keyword. That is not allowed. I cannot have this recursive cyclic creation dependency. If we reread it, if a contract wants to create another contract, the source code and the binary of the created contract has to be known to the creator. This means that cyclic creation dependencies are not possible. So what I basically mean, if I have here contract A, inside this contract A, if I do something like this, I'm not putting the L value here, but if I had this, when I'm creating instance of the contract, say B, and then I have a contract B in which I am doing somewhere this new A. So this thing is not allowed. Here A needs the code of B before creating it, but B itself is asking the code of A. I mean it's creating this A. So this is not allowed. But in A, I can of course typecast an address to whatever contract type I want. I can typecast some address to B. This is fine. But I cannot create a new instance of B provided if B is also creating a new instance of A. So I hope this is clear. And in this example, the example is not relevant for us, but I'm just wanted to show that this creator, I mean this, they have this typecasting of an address to a token creator, but they are not creating this a new instance of this token creator contract. They are just typecasting it, and the token creator is indeed creating the new contract instance own token. So that is fine. We can typecast, but we cannot here the new keyword should not be there for the token creator if token creator is also using the new keyword for this own token contract. So I hope this part is clear. Next we have this visibility and getters. The getters part we have already done, so let's now focus on the visibility part. Regarding state variables visibility, three types of visibility can be defined. For the public state variables differ from internal ones only in that the compiler automatically generates getter functions for them, as we have seen the getter functions in detail, which allows other contracts to read their values. When used within the same contract, the external access, that is via using this symbol, invokes the getter function, while internal access, when we use it without this keyword, gets the variable value directly from storage. As we know, state variables are in storage. Setter functions are not generated, so other contracts cannot directly modify their values. So yeah. And then we have internal visibility. Internal state variables can only be accessed from within the contract they are defined in and in derived contracts. I will shortly speak about this part also, derived contracts. They cannot be accessed externally, via some other contracts. This, I mean, or externally, I mean, this contract can also not access it externally besides other contracts too. This is the default visibility level for state variables. So in case you do not define any visibility, either public, internal or private, then by default it will be internal. Now private is just same as internal, but a slightly more restriction that it is not, cannot be accessed in derived contracts. So public state variables are like internal ones, but they are not visible in derived contracts. Before I speak about this derived contracts, I would like to cover this warning. Making something private or internal only prevents other contracts from reading or modifying the information, but it will still be visible to the whole world outside of the blockchain as it is stored in the state. So one can still read it even if you have it private or internal. Now let me clarify these derived contracts part. Here I have a contract named owned. Inside it they have this state variable owner. The visibility, this owner is of type address payable, and the visibility of this owner is not specified, so I know its visibility to be internal, and thus this owner variable can be accessed within this contract and in the derived contracts. Now using this is keyword, this destructible contract is deriving from owned contract, and thus we call this destructible contract to be the derived contract. So since it is a derived contract, and therefore the internal state variables will be visible here also, and therefore this contract can access this owner variable. The other part we need not bother about, but I just wanted to tell you a bit about this inheritance. Using this is keyword, what we inherited, this owner state variable, because it has the visibility internal. I mean, internal allowed it to be also accessible in the derived contract. If it was public, even then we can access it in the derived contract. But if it would have been private, then it was not possible. So I hope this derived contract part is clear for the in the context of state variables. Next, we have function visibility. Solidity knows two kinds of function calls: external ones that do create an actual EVM message call, and internal ones that do not. Furthermore, internal functions can be made inaccessible to the derived contracts. Therefore, this gives rise to four types of visibility for functions. One is the external visibility. External functions are part of the contract interface, which means they can be called from other contracts and via transaction. An external function f cannot be called internally. That is, f, if we would have simply used this f within our contract, we will not be able to call it because it is solely external. But this .f work because here we are doing the external call. If instead of external we would have declared it as public, then both external access as well as internal access is possible. Public functions are part of the contract interface just like the external ones, and can be either called internally or via message call. Next, we have internal functions. Internal functions can only be accessed from within the current contract or contracts deriving from it. I mean, just like our state variables. They cannot be accessed externally since they are not exposed to the outside through contracts ABI. They can take parameters of internal types like mappings or storage references. So this part, as we have also seen an example, is very important. If you want to use mapping or some other reference type where their data location is storage, the visibility has to be either internal or private. The difference between internal and private is simply that private is just like internal with slightly more restriction that they are not accessible in the derived contracts. So private functions are like internal ones, but they are not visible in the derived contracts. So I hope with this the visibility part is clear. And just like how we had in case of state variables, making something private or internal only prevents other contracts from reading or modifying the information, but it will still be visible to the whole world outside of the blockchain because uh, it is part of the state. And where do you specify this visibility? The visibility specifier is given after the type for state variables and between parameter list and return parameter list in the case of functions. So here we had this state variable data. So between its type and its variable name, we have the visibility specifier, and in case of function, after the parameters between parameter list and the return parameter list, here there was no return, so we mentioned here this one had the returns part and the parameters part, so between them we have mentioned our visibility. By now I think it is pretty much clear about the visibility of functions. In case you want further clarity, you can read this example. I am not going over this example because as such I feel that I have explained it thoroughly, and we have seen multiple examples previously too. Next, let us look at function modifiers. So a general description: modifiers can be used to change the behavior of functions in a declarative way. For example, you can use modifier to automatically check a condition prior to executing the function. So let us understand this with the help of an example. They have given this example and I see it as a nice example which they have provided. So we have this contract named owned. this is having this state variable owner, which is getting initialized inside the constructor via this message.sender. Message.sender is the global variable which contains the address of the caller, which from which this message was invoked. So understand, the internal function calls will not change your message sender. I'll also show you an example now to make this clear. I have this contract here. This eCall will be called up by some another contract, or basically it will be called externally. So I will have this concept of message sender, and now I'm calling this function get sender. Now when I'm inside this function, you might think that the message.sender will be this contract, the address of this contract, because that is what is calling this function, but actually it is not the case. Message.sender is the one which call this function externally. Basically we are talking about our message call, the external message calls here. Then in the end I have a simple assertion to check whether these two addresses are same or not. So let me deploy this contract. Now I have deployed this contract. I'm copying its address because I have my another contract called message sender. Basically it is just going to call that eCall function here. So to deploy this call message sender, I'll pass in the address of my other contract because I'm initializing this my variable. We have seen how to call other contracts function, so I'm just doing the same thing here. But I need the other contract's address for that. So I am going to deploy this now, and now I'm going to call this function check message sender, which is just simply going to call that eCall function, and it has run successfully. So indeed our assertion is true. Moving back to our example, so we have this modifier known as only owner. Whenever, okay, let me first show the other contract. I have this contract named destructible, which is deriving from this owned contract, this owned contract here. And now this contract is having this function destroy with the modifier only owner. As you can see, I have put a modifier, they have put a modifier here, only owner, and then the function's definition. Now what this only owner is doing, the code which is inside these curly braces, this line, this code contains only one line, will be pasted here this underscore symbol. So against this underscore symbol, this code will be put, and so above this underscore we have this condition, which is simply checking whether the message dot sender is owner or not, a simple require statement. So here you saw an example of modifier. Next they have this contract named priced. Here they have this modifier cost, which is also taking the arguments. So modifiers can receive arguments. Here this is the price named unsigned integer. So we have an if block, and inside that if block is where we will be pasting the code. So they have this contract here register, which is deriving in this example from two contracts. One is this priced, one is this destructible. So this register contract has this register addresses mapping and unsigned integer pricing, and which is getting initialized using this constructor. Then this register is simply registering the address, marking it as true. They have a slight note that it is important to also provide the payable keyword here, otherwise the function will automatically reject all ethers sent to it. We have seen the use of payable before, so that is why they have this payable here. Then a change price function is there, which can be executed only by the owner of the contract. So we have this owner thing, and when this contract is inheriting from this destructible, because destructible was inheriting from owned, this owner was initialized. So I hope that even though we are in this contract, register contract, but when this register contract was deployed, the owner variable was set because it is inheriting from destructible, and destructible is inheriting from owned, and in the owned the owner was set. This might not be fully clear, and we will see the detailed explanation later when we will be covering inheritance in detail. But I just wanted to let you know that that is how the owner was set. So when we are using this only owner, this price can be updated by the owner of this contract when the only owner is allowed to call this function change price. And if we look at this only owner modifier, it is checking that message dot sender has to be the owner of the contract. So yeah, the other modifier which I forgot to tell here, this one, this cost price, and what this is doing is simply checking whether the message dot value is greater than equal to the sent price or not. So you can register only if you pay more than the price which was set inside the constructor, or in case you might have changed that also. Next, they have this mutex contract, and if you look at it, there is this state variable logged which is initially false because default value is false. Then this modifier no reentrancy, which requires this variable to be false, because if it is false then the negation is true. So yeah, then they will make this equals to true, and this, and here will be the function's definition, and then they are again assigning it false. Now to this function f, they have this no reentrancy modifier. Inside this inside this function f, inside they are doing a low level call to like message dot sender. Inside the contract at this address they are calling something, and they are just checking whether the call successfully went through or not, and just returning something here. What is to be noted is that because of this modifier no reentrancy, inside this contract one cannot call this function f again. When I'm calling a function of this contract, that function might again call this function f, right? But that won't be possible because of this no reentrancy modifier, as when entering in this for the first time the logged was made true. Now in case the function f is called again from this contract, from this contract's function, then as the logged is still true, this thing will become false, and therefore we will raise an exception reentrant call. Lastly, they are mentioning an important thing, that even though we have this return statement, the return 7 statement assigns 7 to the return value, but still execute this statement log.false. So do not assume that once we have this return we are out. No, this modifier, other lines of it is also executed. This statement log.false, logged is assigned the value false, is still executed in the modifier. We will see in detail about this part following in the following articles. Also, you might think that this example here, they are not calling any function of this contract, but actually when we put this empty data, then either there is something known as the receive function and fallback function. So one of them is called here, but I don't want you to get confused with that. We will cover receive function and fallback function shortly, but basically it can be a call to any function of this contracts. The reentrancy part is not limited to this receive or fallback function. So I just wanted to add that clarification here. Moving on, if you want to access a modifier m defined in a contract C, you can use c.m to reference it without virtual lookup. It is only possible to use modifiers defined in the current contract or its base contracts. So if we look at this one, this mutex one, Here we are using the modifier defined in the same contract, and if we look at this register contract, here we are using this modifier only owner, which is defined in one of the base contracts, this one, owned. Now regarding this virtual lookup part, they haven't talked explicitly about virtual lookup, and in my opinion this is something internal to the Solidity compiler. Here, instead of writing only owner, I think if we write only owner here, we are triggering the virtual lookup where it will go to the base contracts and see where the modifier exists. We can explicitly write here this owned dot only owner, like I have here. Here I wrote owned dot only owner. If I write without it, compiling successfully. If I write with it, then also it is compiling successfully. Now if I make a slight change, this only owner modifier, I have created this contract. Basically this contract is same is the copy paste of this contract owned. I have just pasted that same contract, just added a letter D in front, so it has the same modifier only owner. Now if I do this, instead of owned, don't dot only owner, and save it, I get an error, and that's precisely because what they have said. It is only possible to use modifiers defined in the current contract or its base contracts. Here this don't contract is not the base, but owned contract is. Next, they have modifiers can also be defined in libraries, but their use is limited to functions of the same library. So just keep this in mind. Once we will cover libraries, I think then it will trigger to you what it means. Next, we have multiple modifiers are applied to a function by specifying them in a white space separated list and are evaluated in the order presented. I hope that this in itself is not clear to you, and I am personally not satisfied with their description. So let me show you an example. I have this example here where in this contract named multi modifier, I am having three state variables which are public, x, y and z, and I have this modifier a which makes y4 inserted this function's code, then z equals to 2, y equals to 0. Next, I have this modifier b which increments y by 1, increments z by 3, have this underscore, and then z equals to 0. Lastly, I have this function increment x which is having these two modifiers, modifier a, modifier b, and the code is very simple, increment x by y and increment x again by z. So can you tell and think and tell me what is the value of x after I have executed this increment x function? If you got it right, then I will be impressed. So let me run this. I'm going to ignore all that. I'm going to run this. So I'm calling this increment x function. Now let us see what is the value of x. It is 8. Value of y 0. Value of z 2. So I wonder whether you got it correct or not. So let us try to understand what actually happened. We have this modifier a and then this modifier b. What actually happens that this part here, this underscore, gets replaced by the code of modifier b. Okay, and then this underscore, since there is no further modifier, this underscore is getting replaced by this code. So the actual code translates to, if I were to write, I will first write this part. I have written it finally here, but let me rewrite it here to make the things more clear. So I told you we will first have this part. This part will be replaced by the modifiers b code. So I'm going to copy that and paste that here, right? And this is going to be replaced by the functions code. this. So having this now replaced by this, can you now understand why we got x to be 8, y made 4, then y incremented, so y is 5, z is 3, so x plus 5, x plus equals to 5 makes x 5, then plus equals to 3 will make it 8. Now z is made 0, but then again made 2, and y is made 0. So if I query y, I am getting 0, and if I query z, I am getting 2. So I hope now it is clear regarding this part. Next, modifiers cannot implicitly access or change the arguments and return values of functions they modify. Their values can only be passed to them explicitly at the point of invocation. Just like this cost thing, we had this cost modifier here, yeah. Here we are passing the argument, so that is how you can pass an argument at the point of invocation. They cannot directly access your function's arguments and the return values. And moving on, we have explicit returns from a modifier or function body only leave the current modifier or function body. Return variables are assigned and control flow continues after the underscore in the preceding modifier. Understand the basic concept here. Like when we had our this contract, here this part was getting replaced by this modifiers code. Now if I were to return from here, then we will go back to our previous modifier mod a, and we'll continue execution from that after this underscore part. So that is what they are saying. Just like how in this we had this return 7, when we did this return 7, then we exited from this function part, but we were continuing inside the modifier part. And here if we were to return from this mod b, then we will continue after the mod a part, which was here. So let me also run it and show. But before I run, notice these warnings. It is saying me unreachable code, and even this function is now have become unreachable because the modifier which it is using returns. So let us deploy this. Here let me call this function increment x. Now after this, since we returned here itself, my y should be 4, then z2, then y0. So ultimately x is 0, z is 2, and y is 0. So x is 0, z is 2, and y is 0. So yeah, I hope with this I have clarified this explicit return part. Next we have an explicit return from a modifier with return does not affect the values returned by the function. The modifier can, however, choose not to execute the function body at all, and in that case the return variables are set to their default values, just as if the function had an empty body. So with all the examples that we have done, I think this should be clear by now. The underscore symbol can appear in modifier multiple times. Each occurrence is replaced with the function body. Now here in our previous example, if I add one more underscore here, can you think and tell what will be the output? So let us first decipher it. Before we run the code, let us see what is the output which we will expect. So as this is taking modifier A, modifier B, we'll first take the modifier A's code. I'm going to paste it here, and anywhere where that we see this underscore symbol, we have to replace by modifier B's code. So let us take that and paste it. Now wherever we see this underscore, we have to replace by the functions code. So let's take that and paste it. Now let us go through this code to determine what will be the value, right? Alright, so y is 5, z is 3, so x is incrementing by 5, yeah, x is 8, yeah, z is 0, z is 2, y is 0, y is 1, z, since it is was 2 latest value what I can see, so now it is 5. Then 8 plus equals, I mean they are adding x to be 8 plus y, and y's latest value is 1, so that is equals to 9. Then x is equals to 9 plus z, which is 5, so that is equals to 14, and now z is 0. So in the end, the values which we have, x is 14, y is 1, z is 0, so 0, 14 and 1, yeah. So let me now attempt to run it and see whether we are right or not. I'm going to call this function increment x. Now let me query all these value. Yes, x is 14, y is 1 and z is 0, so we did this correctly. Let us now also do modifier overriding, which is in the same page but comes a little below. Function modifiers can override each other. Basically, like we have this contract base which is having this modifier, and now I am deriving from this base contract this inherited contract. Basically, we also say that this is inheriting from the base contract. Now if I want to modify the modifier in the base contract, then I can use this override keyword to override it, provided the base modifier was overridable. To make it eligible to be overrided by the derived class, we must specify virtual keyword. So function modifiers can override each other. This works in the same way as function overriding, except that there is no overloading for modifiers. The virtual keyword must be used on the overridden modifier, and the override keyword must be used in the overriding modifier. So this part I explained. I hope it is clear to you. And regarding this same way as function overriding, if you will see, you will agree that yes, it is same. But there is no concept of overloading for modifiers. I briefly touched upon this overloading concept for functions, but that does not exist for the modifiers. In case of multiple inheritance, all direct base contracts must be specified explicitly. Like in this example, they have one base contract, base 1, another base 2. Now it is this inherited contract is inheriting from both this base 1, base 2. Now if we want to modify this foo modifier, then I have to specify that I'm both these base contracts, the direct base contracts we have to specify. I mean, this base 2 could be inheriting from some other, so we need not bother about that. But the explicit ones which we use, we must specify their names. In case we don't specify, say I had just written base 1, the compiler will give me the error. So now if we go back to this function modifiers, this line we have covered. Modifiers are inheritable properties of contracts and may be overridden by derived contracts, but only if they are marked as virtual, and we saw this modifier overriding section. One last thing which they are mentioning, arbitrary expressions are allowed for modifier arguments, and in this context, all symbols visible from the functions are visible in the modifier. Symbols introduced in the modifier are not visible in the function, as they might change by overriding. So this part we already know that symbols introduced in functions are not visible in the modifier. Similarly, symbols introduced in the modifier are not visible in the function, and the justification what they are providing is that since modifier might get overridden. So that clarifies this part. And regarding this part, what I understand from it is that whenever you are declaring a modifier, like here they declared this modifier, you can give in any arbitrary expression, basically any number of arguments, whatever their type. So that is allowed. So in case you want to use something, you expect to use something from your function, you can give it as an argument. So that is what I understand from this part. And with this, the modifiers part is now complete. Let us now read about this section, constant and immutable state variables. State variables can be declared either as constant, not either but also as constant or immutable. In both cases, the variables cannot be modified after the contract has been constructed. For constant variables, the value has to be fixed at compile time, while for immutable, it can still be assigned at construction time. Basically, there are some, when you write a program, there is some variables whose value will not change throughout the lifespan of the contract. So it is better to optimize your program and declare those variables as constant or immutable. And what this helps in is the compiler does not reserve a storage slot for these variables, and every occurrence is replaced by the respective value. Also, it is possible to define constant variables at file levels. Outside your contracts, you can specify constant variables. Another reason what they are giving, compared to regular state variables, the gas cost, as we know that storage access is very costly in EVM, the gas costs for constant and immutable variables are much lower. For a constant variable, the expression assigned to it is copied to all the places where it is accessed and also re-evaluated each time. This allows for local optimizations. Immutable variables are evaluated once at construction time. Basically, some variables you know before you are deploying your contract that they have this value and which will not change throughout the lifespan of the contract. But then there are some variables whom you know that at the time I am creating the contract, this will be the value which I will find, and after that they will not change throughout their lifespan. Basically, in the constructor you will initialize them. So for those variables you use this immutable keyword. Now where were we? Immutable variables are evaluated once at construction time and their value is copied to all the places in the code where they are accessed. For these values, 32 bytes are reserved even if they would fit in fewer bytes. Due to this, constant values can sometimes be cheaper than immutable values because of this bytes thing which they have mentioned. Now a question might come, then what if the value which we are storing is more than 32 bytes? So they have mentioned that not all types for constants and immutables are implemented at this point. The only supported types are string, which two only for constants, and value types, where value types is valid for both constant and immutable keyword. And you see that all these value types which we have studied very well fits under the one word. Strings is something which might not fit under one word and which might be long. Continuing, just one thing I would like to mention, that from the style guide you can see that these constant variables are having such notation, this capital, all letter capitals notation. You can see that in the style guide. Also, they have this immutable variable, and you can see that it is initialized in the constructor. This decimals is initialized similarly for this max balance, and here also we have the owner which is initialized using this message dot sender. The message dot sender is not known until the contract is being created, so that is why it is immutable, not constant. Let us also read the further description which they have. For constant variables, the value has to be constant at compile time and it has to be assigned where the variable is declared, any expression that accesses storage, blockchain data, example this block.timestamp, some addresses balance or block number, or execution data like message value, gas left, or makes calls to external contracts is disallowed. Expressions that might have side effect on memory allocations are allowed, but those that might have side effect on other memory objects are not. The built-in functions catcheck, SHA, and all these are allowed, even though with the exception of catcheck, they do call external contracts. The reason behind allowing side effects on the memory allocator is that it should be possible to construct complex objects like, for example, lookup tables. This feature is not yet fully usable. I have read it to you for like your awareness. We are not going into detail here about this memory allocation to show you an example where this side effect might have memory allocation and such things, but I wanted you to be at least aware in case you encounter something related to it. Moving on, about immutable. Variables declared as immutable are a bit less restricted than those declared as constant. Immutable variables can be assigned an arbitrary value in the constructor too of the contract or at the point of their declaration. They can be assigned only once and can from that point on be read even during construction time. The contract creation code generated by the compiler will modify the contract's runtime code before it is returned by replacing all references to immutables by the values assigned to them. I hope this is clear. This is important if you are comparing the runtime code generated by the compiler with the one actually stored in the blockchain. Basically, the runtime code generated by the compiler will get modified, like the all the references to that immutable will get replaced by their actual value. That is why we call it the runtime code. So I hope this part is clear. Lastly, they have this important note: immutables that are assigned at their declaration are only considered initialized once the constructor of the contract is executing. This means you cannot initialize immutables in line with a value that depends on another immutable. You can do this, however, inside the constructor of the contract. This is a safeguard against different interpretations about the order of state variable initialization and constructor execution, especially with regard to inheritance. Yeah, this is quite technical. We need not bother, but I hope you understood this part. Now let us discuss some more detail about functions. Functions can be defined inside and outside of contracts. Functions, so they can be defined at file level. Functions outside of a contract are also called as free functions. They always have implicitly internal visibility. Their code is included in all contracts that call them, similar to internal library functions. This library function part will become clear when we will see them, but otherwise I hope that it is clear. Now they have just given an example. We need not bother about it as such. This in itself is very clear. I mean, they are just like the function declared inside the contract because their code is included in all the contracts that call them. So the functions defined outside a contract are still always executed in the context of a contract. They still have access to the variable this, can call other contracts, send them ether, and destroy the contracts that call them, among other things. The main difference to functions defined inside a contract is that free functions do not have direct access to storage variables and functions not in their scope. Can you think that what all functions are in their scope? Basically all those which were declared along with them, basically outside the contract. Maybe you imported some other file, so those functions also, like that. I hope it is clear. Also, one more thing, you cannot specify the visibility of these free functions. They have to be internal. Now a bit about return variables. The above part we have already covered regarding function parameters. So function return variables are declared with the same syntax after the returns keyword, basically the same syntax as the function arguments. For example, suppose you want to return two results, the sum and the product of two integers passed as function parameters, then you use something like this, as they have seen. And what I want you to notice from that, usually when we are writing this returns statement, we don't name the variable, but here they have named them, and now they can simply assign it like this: sum this value and product this value. They need not use the return keyword in the end. The names of return variables can be omitted. Returns variable can be used as any other local variable, and they are initialized with their default value and having that value until they are reassigned. So here the sum's default value is the unsigned integer's default value, which is 0. Similarly, for product, it is initially having the value as 0. In case we didn't do anything here, what this function will return will be a tuple having these two values as 0, 0. So I hope this part is clear. You can either explicitly assign two return variables and then leave the function as above, or you can provide return values, either a single or multiple ones, directly with the return statement. As you know, function can contain this return keyword at multiple places. Suppose in a if block you have a return statement, then if that condition is not true, then after that if block you can have a return statement. So like that, here they have named this sum and product, but they are not using it, and in the end they are returning like this, a tuple having these two values, the sum as a plus b and product as a star b. Here one thing I would like to add: in case we did not have a return statement, nor do I had a name here. For example, if I had just written returns opening parenthesis uint comma uint and closing parenthesis, that I did not name my return values and I did not even put a return keyword here, then what this function will return will simply return a tuple having the return value will be a tuple where the two values will be 0 comma 0, which is the default value for unsigned integer. So that is what I wanted to add regarding this part. All other things we have seen regarding this ABI coder v2, we have seen that when a function has multiple return types, the statement this can be used to return multiple values, as we have seen multiple times. The number of components must be the same as the number of return variables, and their types have to match, potentially after an implicit conversion. Just like in assignment we might have an implicit conversion, same here. Next, let us finally cover about the state mutability, about those all view pure which you might be seeing. So what are view functions? Functions can be declared as view, in which case they promise not to modify the state. There is a slight catch. If the compiler's EVM target is Byzantium or newer, which is by default, the opcode static call is used when view functions are called. We have already seen about static call, how it enforces that the state should remain unmodified. So that is why static call is used, which enforces the state to stay unmodified as part of the EVM execution. However, for library view functions, delegate call is used because there is no combined, we don't have any combined opcode for both these delegate call and static call, and therefore delegate call is used. This means library view functions do not have runtime checks that prevent state modifications, but they are also saying that this should not impact security negatively because library code is usually known at compile time and the static checker performs compiled time checks. So I hope this is clear. Now, just for your knowledge, the following statements are considered to modify the state, like writing to the state variables, emitting events, we will see what are events shortly, creating other contracts, using self-destruct, sending ether via calls, calling any functions not marked as view or pure, using low-level calls, using inline assembly that contains certain opcodes. So I hope it is clear that what all operations are considered to modify the state. Here they have a simple example declared. The function is declared as view, and it is just like viewing the a variable, b variable. It did some arithmetic with them with the block time, seeing the timestamp of the current block. So it didn't do any modification to the state, and we have explicitly rules to see what all operations are considered to modify the state. So it did not do any of those. They are mentioning that getter methods are automatically marked as view. Next, we have pure functions. Functions can be declared pure, in which case they promise not to read from or modify the state. In particular, it should be possible to evaluate a pure function at compile time given only its inputs and message.data, but without any knowledge of the current blockchain state. This means that reading from immutable variables can be a non-pure operation. So they have clarified it themselves. If the compiler's EVM target is Byzantium or newer, which is by default, the opcode static call is used, which does not guarantee that the state is not read, but at least that it is not modified. So what are these operations that are considered to be reading from the state? As we have seen that pure is more restrictive than view, because pure view is like don't modify the state, pure is like don't even read the state. I mean, you cannot even modify besides, and don't even read too. So these are reading from state variables, accessing address this dot balance or address dot balance, accessing any of the members of block, transaction, message, with the exception of message.sig and message.data. So keep this in mind. These two can be read. Calling, and besides this block tx message, in case you have any confusion, you can read this section, units and globally available variables. Calling any function not marked pure, using inline assembly that contains certain opcodes. So here they have given an example, very simple example, where the function takes in the input parameters and do an operations with them. So nothing else is touched besides what this function has been given. Pure functions are able to use revert and require functions to revert potential state changes when an error occurs. I mean, some function might be calling this pure function, and that callee might have done some state modifications. So we can still use this revert and require in our pure functions. So that's not an issue, and that's not something redundant or inappropriate. I mean, I can see very much use case for it. And they are clarifying that reverting a state change is not considered a state modification, as only changes to the state made previously in the code that did not have the view or pure restriction are reverted, and that code has the option to catch the revert and not pass it on. This behavior is also in line with the static call opcode. Although this part is not entirely true, that code has the option to catch the revert and not pass it on, because it can be an internal call to the pure function. Like if you have difficulty visualizing it, I have this simple example where I have this state variable, and this function is modifying that state variable here, and it is calling this pure function, and as you can see, this function is indeed pure, and this function is doing nothing, just reverting it. And since this was an internal function call, I cannot even do this try catch here. So I wonder what they meant. Now if I call this calls pure function, you can see it reverted, and state where is still 0, did not get modified. But anyways, I think it is clear enough. And this warning is just once again telling that, maybe we should read it. It is not possible to prevent functions from reading the state at the level of the EVM. It is only possible to prevent them from writing to the state. That is, only view can be enforced at the EVM level, pure cannot. And for the pure, even for the pure, we are using the same static call opcode. So basically the compiler will help, but not the deployed bytecode here. Next, we have these special functions, the receive ether function and the fallback function, which we will see. A contract can have at most one receive function declared using receive external payable, and then we have this curly braces without the function keyword. You don't put function before receive. This function cannot have arguments, cannot return anything, and must have external visibility and payable state mutability. It can be virtual, can override, and can have other modifiers. The receive function is executed on a call to the contract with empty call data. This is the function that is executed on plain ether transfer, example via send or dot transfer, which we use. If no such function exists, but a payable fallback function exists, the fallback function will be called on a plain ether transfer. If neither a receive ether nor a payable fallback function is present, the contract cannot receive ether through regular transaction and throws an exception. In the worst case, the receive function can only rely on 2300 gas being available, for example when send or transfer is used. The send and the transfer method of the address forwards by default 2300 gas, which is not adjustable. So in the worst case, because receive function can be accessed, will be called when the send and transfer is used. So in that case, you should be careful, because the receive function, the definition which you will put of this function, you should be careful that it should not cross this 2300 gas. So it leaves a little room to perform other operations except basic logging. The following operation will consume more gas than the 2300 gas statement. For example, writing to storage, creating a contract, calling an external function which consumes a large amount of gas, sending ether. So make sure your receive function is concise with regard to gas. And I find this warning quite interesting. A contract without a receive ether function can still receive ether as a recipient of a coin-based transaction, also known as minor block reward, or as a destination of a self-destruct. Now this self-destruct I haven't covered yet, so let me cover that now. In our introduction to smart contracts, we have this section just above precompiled contracts, this deactivate and self-destruct. So let us read it now. The only way to remove code from the blockchain is when a contract at that address performs the self-destruct operation. The remaining ether stored at that address is sent to the designated target, and then the storage and the code is removed from the state. So that target address receives the ether, even if it may not have the receive function or the payable fallback function. Removing the contract in theory sounds like a good idea, but it is potentially dangerous, as if someone sends ether to removed contracts, that ether is removed forever. So that ether is forever lost. Even if a contract is removed by self-destruct, it is still part of the history of the blockchain, simple stuff, and probably retained by most Ethereum nodes. So using self-destruct is not the same as deleting data from a hard disk. Even if a contract's code does not contain a call to self-destruct, it can still perform that operation using delegate call or call code. Now we haven't discussed libraries yet, but I think you can still make sense of this if we read about it here. this delegate call code stuff and libraries, there exists a special variant of a message call named delegate call, which is identical to a message call apart from the fact that the code at the target address is executed in the context that is at the address of the calling contract, and even the message.sender and message.value do not change their values. This means that a contract can dynamically load from a different address at runtime, but the storage, current address, and the balance still refer to the calling contract. Only the code is taken from the called address. This makes it possible to implement the library feature of the Solidity, which is a reusable library code that can be applied to a contract storage example in order to implement a complex data structure. Now, libraries we will see in detail later, but I hope you have understood about this delegate call, like how we can still do it using delegate call, because we can refer to a library here. Also, I don't see them talking about call code here, but basically delegate call is like the call code version 2. I mean, it was introduced to fix few issues with the call code. Uh, Something like message.sender etc. was not preserved in call code, so delegate call was introduced as a fix to that. Also, this delegate call seems like a better word too, because you are delegating, your storage etc. to some other code. If you want to deactivate your contracts, you should instead disable them by changing some internal state which causes all functions to revert. This makes it possible to use the contract as it returns ether immediately instead of having them lost. So I hope this part is clear and you have understood about this part. The other part is, slightly more deep, so we need not bother, but it's good to be aware of it. A contract cannot react to such ether transfers and thus also cannot reject them. This is a design choice of the EVM and Solidity cannot work around it. It also means, now this is very important, it also means that address this dot balance can be higher than the sum of some manual accounting implemented in a contract that is having a counter updated in the received ether function. So I hope this is clear to you. They also have a simple example where just they are doing some basic logging inside their receive function. So this contracts keeps all ether sent to it with no way to get it back. So it's a sink. The name is apt for what it does. They have this receive function which is having this external visibility and payable modifier, as what was told to us that payable state mutability must be there along with external. Other things can also be added, like it can be virtual so that the derived contracts can override it, and there can be modifiers too. So this is just emitting this event. We will see about events later, but yeah, just a basic example for the receive part. Next, we have this fallback function. A contract can have at most one fallback function declared using either fallback parenthesis external and optional payable keyword, or fallback bytes called at input external optional payable keyword returns bytes memory output. Both you write without function keyword. This function must have external visibility. A fallback function can be virtual, can override, and can have modifiers. The fallback function is executed on a call to the contract if none of the other functions match the given function signature, or if no data was supplied at all, provided there is no receive ether function either, because the receive ether function is triggered in case no data is provided. The fallback function always receives data, but in order to also receive ether, it must be marked as payable. If the version with parameter is used, input will contain the full data sent to the contract which is equal to the message.data, and can return data in output. The returned data will not be ABI encoded, instead, it will be returned even without any padding, without modifications, not even padding. In the worst case, just like our receive function, if a payable fallback function is also used in place of a receive function, it can only rely on 2300 gas being available, because that is how much the send and transfer forwards, which is also not adjustable. Like any function, the fallback function can execute complex operations as long as there is enough gas passed on to it. Next, they have this example which I think we should go over. So let us go over this example. We have this contract named text. Inside it, we have a state variable of type unsigned integer. In there, we have this fallback function of external visibility. It's not payable, so you cannot send ether to it. And what it does, it modifies the state, makes x equals to 1. So let us, this contract caller, this has this function call test to test this contract, right? So it takes a variable of this contract type. So what it does, it calls on this test contract some function which does not exist. And as we know, in case no signature matches, the fallback function will be executed. So in that case, this, when we did, what it returned, even though this function did not exist, still we got true, because fallback function was executed, and this has resulted in making this x variable 1. It was initially 0. This assigned it 1, so it became 1. And this address, first we made it payable so that we can send ether to it. We have seen that only payable addresses have these two methods, send and transfer. So they typecasted it, and then they are sending it to ether. They have now used this keyword ether. In Solidity, if I show you, we have this unit of ether, and it is mentioned here. Even time units is here. So 1 day, 1 week, you can also use these here. So this, however, will fail because our fallback function does not have payable mutability. So yeah, so this will return false here. Next, we have this test payable contract, two state variables x and y, one fallback function, this external, which is also payable this time. You make x equals to 1 and y is the received ether value, the y variable will hold. I mean, yeah, message out value is always, the unsigned integer 256 bits long. And then we have this receive function, which is having x equals to 2, which modifies x equals to 2, and y is again that thing. So let's see what happens when they call this. So for the first call, they are doing non-existing function. So in this case, the fallback function will get executed, and fallback function received 0 ether. So y is 0 and x is 1. So that is what they have written. X became 1 and y is 0. Next, they are again calling the fallback function because this signature does not exist. But this time they have also given the value, which is 1, v, right? So x will become 1 and y will become 1. Both these calls went through. So success is true. Now we have the empty data. In case we have the empty data, then the receive function will go, because the receive function is provided inside here, and the value they sent was 2 ether. So x will become 2 and y will have this value. So I think with this the fallback part is clear. Next, let us discuss function overloading. A contract can have multiple functions of the same name but with different parameter types. This process is called overloading, and also applies to inherited functions. The following example shows overloading of the function f in the scope of contract A. So they are having these two definitions of the functions. One is taking one parameter and the other is taking two parameters. So, and yeah, so you can see we have overloaded the function. So depending upon whether we calling this function with an unsigned integer, then this definition will get executed. But if I'm calling this function f with say two parameters, one is unsigned integer and the other one is bool, then this definition will get executed. But there is a slight catch here, mainly for the external functions. Overloaded functions are also present in the external interface. It is an error if two externally visible functions differ by their solidity types but not by their external types. For example, as we saw for the ABI, this like this example, we have contract A having two functions f. Both are taking in terms of ABI the address parameter. This also takes address and this also takes address. So, and since they have external visibility present in them, they can be called externally too, therefore this will not compile. However, if instead of public they were internal, then this code would have compiled. Both f functions overloads above end up accepting the address type for the ABI, although they are considered different inside Solidity. Next, we have this section, overload resolution and argument matching. Overloaded functions are selected by matching the function declarations in the current scope to the arguments supplied in the function call, exactly what I have told. Functions are selected as overload candidates if all arguments can be implicitly converted to the expected types. If there is not exactly one candidate, then resolution fails, and they have beautifully shown it with this example here. This contract A is having these two functions which goes by the same name f, the difference being one is taking unsigned integer of 8 bits and the other one is of 256 bits. So calling f50 would create a type error since 50 can be implicitly converted both to uint8 and uint256 types. So there is not exactly one candidate here. On the other hand, if we were to call f with this number 256, then that will resolve to this definition uint 256 because 256 value is above the uint8. Overload as 256 cannot be implicitly converted to uint8. So this part is done. Also, return parameters are not taken into account for overload resolution. So this part is done now. Let us now understand about events. Now here it is better that we understand it via Hardhat. So to begin using Hardhat, we would need Node. There could be other ways, but I will be going via Node, and you can download Node using this URL. Follow the installer for your operating system. So I hope that you have Node installed. A good way to verify that is to type npm-v. If you are able to see some version, that means you have your node installed. So let us create a folder. You can name it whatever you want. I'll just name it YouTube for now. And now I'm going to go to that directory. This mkdir I wrote, which means to make a directory, and cd to change your directory to a specific folder. These are basic Unix commands. So if you don't want to follow them, you can just simply create a folder by whatever method you are comfortable with. Now let us initialize this directory for our Hardhat environment. So type npx hardhat, and that's it. Once you have done, it will ask you these options, whether do you want to create a basic sample project, advanced sample project using TypeScript, etc. For now, let us create a basic sample project, and I want this directory to be the project root, so I'm gonna hit enter. Do you want to add gitignore? Up to you. I'm hitting enter here too. do you want to install this sample project's dependencies with npm? And these are the dependencies which they are mentioning: Hardhat waffle, Ethereum waffle, chai, ethers, and they have two ethers here. One is their wrapper on ethers. We will see all that. So let us click enter 2 and wait for it to get installed. I do not plan to go in much detail about Hardhat while we are learning about events, but we will go in detail when we will be doing damn vulnerable DeFi problems. Alright, it has successfully done its installation part. They are telling me there are some vulnerabilities and I should type this command to fix it. So let's also do that. npm audit fix. Alright, they have some dependency trees, so no fix available. Let us ignore that for now and let us see what is in our directory. So if I do ls, I can see it has created these files. So let me open this folder inside my editor, Visual Studio Code. To do that, I typed this command. This code is for the telling about Visual Studio Code, and dot simply means that open this directory. It is up to you which editor you want to use to edit these files. I'll be using Visual Studio Code, and we have all these files here. For now I'm going to let this contract be here. So let me create my contract, name events.sol. Let us first see an example of events, try to understand it, and then we will also read the description which the documentation has provided. So I have written this simple contract which you can see here. The very first line is our license identifier, and since I am working with Solidity version 0.8.14, I am using that version here. Although Hardhat doesn't have full support of this version, but still that is what we are going to use here. My contract name is event, and then I have this event named number updated. So we declare it using this keyword event, then the name of the event. We follow that same cap word style, that is this uh, cap word style we follow. So, and then here I have declared 4 entries inside this event. One is named old number, an unsigned integer. Next is new number, an unsigned integer. Third is an address with named iUpdater, and fourth is also the address of name updater. The only difference here being in between this one and this one is that this one is indexed. What is this indexed keyword does? I will explain. And the very reason I am having the entry twice is to showcase that difference. Then I have my state variable named number, which will get updated in this update function. It will take the new number and it is going to emit this event. So how we emit an event? We follow this keyword emit, then the name of the event, and then the entries. So here this number, new number, message.sender holds the address of the sender, the one who invoked this function. And these two entries are put message.sender, and here I am updating this number. So I assume that this contract is very small and easy to understand. Now we will understand in detail about these events by running them as a script, as I will show you now. So we have this scripts folder. Let us create a new script here. Let me name it about events.js. So let's go with this name. Now I'm going to use this code which they have. So yeah, I copy pasted the code which they have here in their sample script. We are in now JavaScript, and let me just remove all this part which they have here, basically these 3 lines. Yeah, Now if we look at the events.js code that we have, we don't need all these comments and this line here. It would create confusion. So let me also remove these comments here. So this is the JavaScript code that we have. Regarding this part here, this wizardry is here for us to better use this async function. We recommend this pattern to be able to use async await everywhere and properly handle errors. Since this is not a JavaScript course, let me not go in deep about this section here, but we will explain the above part thoroughly. The very first thing which we must do is that we should import ethers. What is ethers? We will see shortly. So we can do something like this to require, and here usually you will see people put like this, that we require ethers. But since Hardhat has added few more spices basically to make the thing, like in ethers you need to provide other things also, and Hardhat has already provided those things for us. And to have the better compatibility in the Hardhat environment, what we should do is this. Instead of that, with this we have a wrapper on the ethers library. What is the use of ethers? We will shortly see. So inside this function, which is an async function, you don't know what is an async function, so let me show you by writing this await keyword. So what I am doing here, basically in JavaScript, not in natively JavaScript, this async await, what this helps us, if I have this line here and I have my second line here, then if there was not the await keyword here, this will run in the background and I will move to the second line here. So what all second line, third line and so on, the process will go on, and once this is finished, this first line, we will get the result. But in our case, we don't want to let it run in the background. The very second line, I mean the subsequent lines, depend upon the completion of this first line. So that is why I am using await keyword here. I am waiting. This await keyword is specifying that I am waiting. So don't move to the second line before the completion of this line where I am putting this await keyword. And if you notice, this function get signers is returning a promise. This promise signifies that if I would have not put await here, then this would have run in background. Since I want my promise to get fulfilled, completed, that is why I'm using this await keyword. So this is just for you to know that when you should use, I mean you can use await. When you see promise and you want to wait for the result, you can use await here. So that is why we are using await. But await support, this keyword await support only exists inside the async functions. So that is why we have this async function. This whole code is JavaScript code. The file name is .js. We are not going in detail about JavaScript. This is not the point of the course, but I am going to explain you the semantics. So this very first line, it is returning me the signers. Basically, you have seen this EOA, externally owned accounts, etc. So you have your private key and all. So basically those signers, I mean when you send a transaction, you sign it and send, right? So it is the signers that we are getting. Here I could have written few more people, person C, person D, so on, you could have done. But as of now, I'm just interested in the two persons here. One is deployer and one is Saurabh, which is my name, because I will be calling that function, this function here, update, by two individuals. So that is why I have two signers here. So let me also deploy, let me also log their address so we can see what is their address. So address of deployer is, and we can put deployer dot address here, and then and address of sourabh is, and I can put here sourabh.address. So we can, if in JavaScript we want to print something, we use this console.log to log something on the console in our case terminal. The arguments which I am passing in this function will be displayed in the terminal. So let me show that in our terminal. Now if I run this command npx hardhat run, navigate to your scripts folder, and then the name of your file, which is events.js in our case. So let me run this, and I am getting an error because I have not specified the version of the compiler in my hardhat configuration. So let me do that. Here inside hardhat, navigate to this file hardhat in that, this is where you can specify the compiler version. So now I have specified the compiler. Now let me run it again, this command. Let's see whether it now runs successfully or not. It is taking some time compiling. Yeah, so now I got the address of the deployer, and I also got address of Saurabh. So these are the addresses of these two signers. Now let me deploy my event contract in the network. So the way I do it, I first write this line here, and what this does, so to understand what does this contract factory does, the command that we have here, get contract factory, I suppose that it is better that we read through the documentation of the ethers.js. So I'm in this section of ethers.js. This is the website docs.ethers.io, and in where you can find the documentation of ethers.js. So to deploy a contract, additional information is needed that is not available on a contract object itself, mainly the bytecode, more specifically the init code. We have seen what does init code means of a contract is required. The contract factory sends a special type of transaction, an init code transaction, that is the to field is null and the data field is the init code. We have seen the very basics. This is the very basics, where the init code will be evaluated and the result becomes the new code to be deployed as a new contract. Here is this function that we are using in our Hardhat, creates a new instance of a contract factory for the contract described by the interface and the bytecode init code. In case of Hardhat, we need not specify such detail. We just need to name the R contract, and the Hardhat will take care of the rest. So that this part here is doing that. The reason I am having a wait here is because I want to wait until the completion of this part. Now when I go, we have this part here, this deploy uses the signer to deploy the contract with arguments which passed into the constructor. As we have seen, the contract has the constructor, and the arguments of that constructor you pass here when you are deploying your contract, and returns a contract which is attached to the address where this contract will be deployed once the transaction is mined. So this initiates the deployment, but we have to wait for the deployment to get completed. So if we look at our code here, once I have done this get contract factory part, I am then deploying it, and I am waiting for this process of deployment, in the sense the process where it initiates the deployment. That is what I am waiting for here. And what this part here is doing, await event dot deployed, is basically waiting once this transaction is mined successfully. This will broadcast to the network that this is deploying, etc. But once that transaction is successfully mined, that is what I am awaiting in this line 12 here. So these are the basics of blockchain. I suppose that it is clear to you. So first we get a contract factory using this contract factory method, and then we deploy our contract. Also, contract factory has these methods. You can read about them if you want to. And then we deploy our contract, and then we wait for our contract to get successfully deployed. Here we initiate the deployment process. Basically, just like how you send somebody some ethers, for example, you will do the send ether in your MetaMask, etc. But it doesn't reach immediately, right? You have to wait for it to get reached. Similarly is for deploy. Just like how you send ether, your transaction gets broadcasted, etc. But once it is successfully completed, that is what this deployed is helping us do. So let us review what we have in our JavaScript file. The very first line here, now you saw the use case of ethers, and this is something not native in the JavaScript, and that is why I need to import it from outside, and this first line is helping me do that. We are not going in deep here about this require and this curly braces inside which I am destructuring the ethers object, so on. But I hope that you are able to understand at least what is. Similarly here, this square brackets, they are signifying an array, just like how we have array in Solidity. So yeah, I'm getting this get signers. This get signers is something not built in the ethers. It is the function provided by the Hardhat. So yeah, this is what we are using. And then I am logging this, and I'm deployed my contract here, which I thoroughly explained. So let us move forward. Also, regarding this part, main dot then dot catch, basically our function name is main. So this then is signifying that if it has run successfully, okay, exit successfully. But in case there was some error, we are reporting that error, just like how we have console.log to log something. Similarly, there is console.error specifically to report errors, and then we are exiting with this error code. Error code 1 is basically to signify that we are exiting with some error. Error code 0 means that we are exiting with no error. And this is where we are actually calling our function main. So that is how I am calling my function main here. Next, I have added some lines here. We will slowly understand these lines. So let us look at this. What I am doing, I am calling this update function. So on my this contract, I am calling this update function. And who is calling this update function? By default, unless we specify, the very first signer returned by getSigners, which is in our case is named deployer, that will be calling this update function. So this update function is called by this deployer. So I'm updating that number variable to 88. This number variable, initially it is 0, and I'm updating it to 88. Then I'm waiting for this transaction to get successfully completed, and then once this transaction is successfully completed, it is going to return me something known as receipt. Let us not go into detail about what is receipt, but I'm going to display in our terminal the event section of that receipt. So let us see what do we find in this events thing. So let me run that here. So let me run our script again, and let us see this. So just like what was expected, I am first logging in the terminal, that the first event where I am updating the number to 88, and the following is that event. So let me look at that. This is what it has shown me. This whole part is that event thing shown to me. So it has all these things: transaction index, block number, transaction hash, address. Whose address is this? You might wonder. This is the contract's address. We have seen how contract address gets generated. So here, if I log in the terminal, the address of the contract, we can see it here, event.address. So let me run that also. Yeah, and you can see address of the contract is this 5FB, and that address is also what is mentioned here. This part is of interest to us when we are learning about events. We see these two parts: topics, an array, which is an array, and then this data. Here we see all this is mentioned here. If you look carefully in this events thing that we had, let us go through it one by one. Let us first go through the name of our event, which is number updated, and we have its fields here, right? And if I look here, there is, I would see something here, this event signature. It is of this form. We have this event signature of form, the name of the event, and then the types, the various types, irrespective whether they were indexed or not, what were their names. We don't have it here in this, we just have the name of the types. And what is this first field inside our topics array? It is basically the Kachak hash of this signature. Like in this URL, which will allow me to compute the Kachak hash online. If I paste in this event signature, I am getting this hexadecimal number, which starts with 1, 6, B4 and so on. And if I look at here, it is the exact same hexadecimal number, 1, 6, B4, etc. So now we know that the very first entry inside our topics array is for the event signature. Our contract can have the same contract deployed at this address, can have multiple events, right? And the first entry in our topic is basically telling what event this is belonging to. So that is what it is telling. Now what is this second entry here? Notice that if I show you in my contract, this number, old number, when the contract in the very initial state, as we know, this will have value 0, the default value. So the old number, when this update function is being called for the first time, this number is having the value 0. So this old number is 0, new number is 88, address is my message.sender. In our case, it is the address of the deployer. Same here. So if I look at here, this indexed parameters is what is getting stored in the topics. I have two indexed parameters here. One entry of the topic is corresponding to the event signature. Now the second entry will correspond to this old number, and the third entry will correspond to this iUpdater. So if I look here, you can see this is how 0 is represented in hexadecimal number system. So that is why the second entry is for that, and the third entry corresponds to the address of the deployer. And if I show you, the address of the deployer is this, starting from F39, and here also you can see it is F39. So that is what this part is having. Now for the parameters which were not indexed, they are getting stored in this data field. They are ABI encoded and stored here. Now this number 88 that we saw, 88 in decimal notation it is 88, in hexadecimal it becomes 58, because 5 into 16 is 80, and 80 plus this 8 is 88. So that is why we have 58 here, basically, which is 88 only in decimal, normal decimal, and 58 in hexadecimal. And here again I'm having my address here, which was not indexed. I had two addresses, if you remember. One was indexed and one was not. So this one is, and this one is present in that data field. So now we saw the two field, one is this topics and one is this data field. Now let us also read what Solidity documentation has to say. Solidity events give an abstraction on top of the EVM's logging functionality. There is something known as logging inside EVM itself. So we are basically using that only via events, as will become clear later. Applications can subscribe and listen to these events through the RPC interface of an Ethereum client. This is something technical. Let us not bother about it here. Events are inheritable member of contracts, just like we saw variables can be inherited. So events are inheritable. When you call them, they cause the arguments to be stored in the transactions log. This is important part. When we are calling this event, all the parameters that we passed, where are they getting stored? They are getting stored in the transactions log, which is a special data structure in the blockchain. These logs are associated with the address of the contract, are incorporated into the blockchain, and stay there as long as a block is accessible forever as of now. But this might change in Serenity. Serenity is the name given to the Ethereum 2.0, the later version of Ethereum. The log and its event data is not accessible from within contracts, not even from the contract that created them. So we cannot access them. It is possible to request a Merkle proof for logs. So if an external entity supplies a contract with such a proof, it can check that the log actually exists inside the blockchain. You have to supply block headers because the contract can only see the last 256 block hash. So we can just check whether something exists or not, but we cannot query it or retrieve it. I hope this distinction is clear. Basically, if you look at the events, they serve the purpose to connect our contract with the front end. Suppose the website, suppose if you have used Uniswap, a decentralized exchange, then when you do a transaction, it will show that transaction is pending, and then once the transaction is completed, it will notify you that yes, transaction is completed. So events help in that. Events are emitted when a transaction is completed and so on, and the front end catches them and do accordingly. Just like how we read an event, right? In our JavaScript code, I showed you we were getting the events and so on. It is also possible to do something like listening to the event. So as and when an event is happening, some event, you can respond to it. So that is also possible. We will see that later when we will be doing damn vulnerable DeFi problems. So in case you want to query an item inside your smart contract, in case in your smart contract you want to query something present inside your logs, that is something which is not possible. That is what is being talked here. The log and its event data is not accessible from within contracts. The events get emitted and your front end can react to them. That is what is possible, but you cannot access them inside your smart contracts. You can add the attribute indexed to up to 3 parameters, which adds them to a special data structure known as topics instead of the data part of the log. A topic can only hold a single word, that is 32 bytes. So if you use a reference type for an indexed argument, the catcheck 256 hash of the value is stored as a topic instead. If we look here, our topic had 3 entries, and at most the topic can have 4 entries. The first one is taken up by the event signature, and therefore only 3 entries is what I can use. There is something known as anonymous events, in which case the first entry is not taken, and then you actually have the access to complete 4 topic entries. But what is the use of these topics, right? Why do we have this distinction, this topic thing and this data thing? That will become clear later. But let us first continue reading the documentation. All part without the indexed attribute are ABI encoded in the data part of the log. Topics allow you to search for events. For example, when filtering a sequence of blocks for certain events, you can also filter events by the address of the contract that emitted the event, and so on. They have an example here. We need not see their example, but basically, in all the, suppose my contract is having this update function, as you saw. Suppose it is called 1000 times, 1000 times people called it, updating with various different values. Now suppose I want to get each time the event was emitted and this topics thing and data thing was done. Suppose I want to filter those events where my initial number was say 0 or initial number was say x. In that case is where these topics will help me. I can just simply say filter all those events where my first number was 0, as we will see in our example. Like here inside our contract, now I'm going to uncomment the different lines which I initially commented. Alright. Okay. This line we saw, here I was calling this update function and I was updating the value from 0 to 88. Next I update the value from 88 to 0, then from 0 to 7, and then from 7 to again 88. And now what I'm doing in this line, I mean this line, if you look at this line here, I am first calling this connect method. And what this connect method does is basically, as I told you, whenever I'm calling this update function, by default it is connected to the deployer, right? But now I want to call this update function by sourabh signer. So what I'm doing, I'm first connecting to this contract my signer sourabh, and now I'm calling this update function. So next I'm updating 88 to 3. Here you can verify the function. If I want to show you who is actually calling the function, like here, as if we look at the events, we have the address of the, and inside the topics we had this message sender, and I can see that it is the address of the deployer, right? Next I will be calling this by sourabh, and then this field should be the address of sourabh. Let me delete this line. This comment I wrote and I have explained you regarding this comment. Similarly for this comment, I'm just explaining this semantics, that once we send the transaction, and this wait thing will give me the receipt of the completed transaction. So that is what it is. Now I want to query the events where the original number was 0, and that is what this method query filter of the ethers.js library helps me achieve. So I am querying the filter where I am passing here the filter, and the filter I am specifying that the first number is 0. Basically, in this method, this event.filters.number updated, you pass in the parameters, right? Here, if we look at these two lines, focus on these two lines. My objective was to query, if we look at these two lines, because then I will be able to explain better. This is printing in the terminal that I'm querying events where the function was invoked by sourabh, and then I will log all those events which were invoked by sourabh. And what were the events invoked by sourabh? Actually only one. We invoked only one event. And how do we do this? Inside this query filter, I am passing in the filter, and what is this filter doing? It is saying first number I don't care. First number, if you look at, This was the first number, old number. I don't care what is the old number in the emitted logs. I don't care what was the new number, but I care who was the I updater, and it should be Saurabh. And also I don't care about the updater part. So that is what I'm doing. First entry, I do not care who was it. Second entry, again I don't care. This I care, that I want this third entry to be this. And you cannot, I mean, here I could not give any number because this was not indexed. Only for the indexed parameters I can give value. For the unindexed parameters you must use null. That is why I had this null in the second field. It was, I had no choice for that. The third parameter I'm having addressed. This fourth parameter I need not mention. I mean, even if I remove it, it will work fine. By default, it goes by the first entry, then the second entry, then the third entry, and then the others are by default null. So even if I put null or without, it won't matter in for the later entries. And if I run this, and querying events where function was invoked by Saurabh, and as I told you that we had only one event, and for the and there here is the address of the Saurabh. If I show you, indeed the address of the Saurabh was this, starting from 7099, this hexadecimal number, and that is what is being also passed in our topics. And the initial number was 88 in case when the Saurabh called. Like if you look here, from 88 we were updating to 3. From 88 we were updating to 3. So my old number was 88, and that is what is part of the topics. So if I look at in my terminal, yes, this old number was indeed 88. I mean 88 in hexadecimal is 58. So yes, this part was getting logged successfully. Also, if we go through the ethers.js documentation, like I showed you how we put the null entry and so on. So they have this example here. You can go through this example. They have explained you, like if you just give one entry, then the topic 0, we will match all those logs with the first entry is a. If I give something like a comma null, then also it is same. If I give null comma b, then the second entry, again it is 0 index, so the index is 1. I am matching b, and so on for these three. For this 2 means the first entry should be a and the second entry should be b. So the 0th index a and the first index b. That is what all these are getting matched to. And then for this case, here it is interesting. The very first entry, again we are putting an array. For the first entry we are putting an array a comma b. So that means the first index of the topic, the first entry of the topic should either match to a or b. So topic 0 should be a or topic 0 should be b. Here again it is the same thing, and here the first entry should be either a or b and the second entry should be either c or d. So that is what it is if you look at their documentation. Next, we used this method contract.queryFilter, and what it does, it returns events that match the event. And how do we pass that? Here contract.filters.eventName, it returns a filter for the event name, optionally filtering by additional constraints, just like how we did. Only indexed event parameters may be filtered. If a parameter is null or not provided, then any value in that field matches. So I hope with this, now if you look further what I did, I initially queried where the original number was 0, and that is how I did. Querying event where the original number was 88, that is how I did. And querying events which were invoked by Saurabh, and that is how I did that. So what all events were there where the original number was 0? This event because 0 to 88. Then this event because 0 to 7. So these two should be logged, and if I check what was logged, querying events where the original number was 0, as I told you, 2 events were there where the in one case we were updating from 0 to 7, 0 to 88 and then 0 to 7. So 0 to 88 is this one getting logged, and then 0 to 7 this one also getting logged. Now querying events where the original number was 88, what were they? If you look at, I did from 88 to 0 and then from 88 to 3, so 0 comma 3, these two should be there. And in the data part, yes, 0 is indeed there, and for the 3 part, this is its log and 3 is also there. So I hope with this you have got good enough clarity about events. If we continue reading the Solidity documentation, the hash of the signature of the event is one of the topics, actually the very first topic, except if you declare the event with the anonymous specifier. This means that it is not possible to filter for specific anonymous events by name. You can only filter by the contract address, as we saw that in the emitted logs, the address field is there of the contract. The advantage of anonymous events is that they are cheaper to deploy and call. It also allows you to declare 4 indexed arguments rather than 3, which is self-evident. Regarding this, if you want to filter contracts by address, you simply just need to pass in the address in the query filter part. Next, they have this note. Since the transaction log only stores the event data and not the type, you have to know the type of the event, including which parameter is indexed and if the event is anonymous, in order to correctly interpret the data, obviously. In particular, it is possible to fake the signature of another event using an anonymous event. The first topic can be you can put in any signature in the first topic because you have access to all the 4 topics in case of anonymous event. So let us see the example of anonymous also. I just need to specify this keyword anonymous if I want to make the event anonymous. So let us run this. Since the file is changed, it will also compile the file. Need to recompile it, right? That is why it is taking some time here. Compiled successfully, and let us look at the first event, the very first event which we logged, and now that event signature part is gone. The very first topic, I don't have that event signature, so I hope that part is done. Anonymous events is something which is very rarely used. I haven't seen it personally getting used anywhere. Only the normal events are what is being used in Solidity usually. Also, these are the opcodes log 0, log 1, log 2, log 3 till log 4. They are also mentioned in the Ethereum yellow paper. Each time you are adding a topic, 375, it is the gas cost is incremented by 375. If I add one more topic here, increasing by 375, I get 1500, and so on. I'm not going into detail here about the gas cost of the log operation, but you can read it here. You can also read some description of these opcodes if you may. This is the Ethereum yellow paper, and they have some description about these logging operations. Also, if I show you, they have mentioned about gas cost of the log data log topic here, that 8 is the gas paid for each byte in a log operations data, and 375 gas paid for each topic of a log operation. And they have done this calculation also here, which you can see here. All right, moving on now, we have this errors and revert statement, which we have done thoroughly. One thing to add, errors cannot be overloaded or overridden but are inherited, just like how different variables get inherited. The same error can be defined in multiple places as long as the scopes are distinct. We have also discussed about scope in detail. So I hope this is clear and nothing more to be done here. Alright, let us now discuss about inheritance. Before I read what is mentioned in the Solidity documentation, let us first go through this example. Here I am in this page of Wikipedia, which tells about C3 linearization. So let us first understand about C3 linearization with the help of the example which they have provided. We are given this example, class O, just like we declare a contract named O, similarly they have done class O. So this is that class O here. Then class A extends O, just like how we do contract A is O. So basically this class A is inheriting from O, and the way they have written is like this. So this is how it is shown in diagram, where we put a directed arrow from A towards O. Then class B extends O. Here it is. Class C, class D, class E, all three are extending from O. So this is the class C pictorially here, D and E here. Then we have class K1 extends CBA. So this is K1. This is inheriting directly from C, B, A, and in turn indirectly inheriting from O also. So we will, yeah. So class K3 extends AD, and this is what they have shown with their directed arrows. Then class K2 BDE, so K2 is here, B, D and E. Then class Z extends K1, K3, K2. So Z is inheriting directly from K1, K3, K2 and indirectly from some other classes also. In fact, through all these which were declared. Now, the thing is, this is multiple inheritance. This was single inheritance where the A was deriving only from one parent. But this is the example of multiple inheritance where it is this class K1 is deriving from three, directly it is inheriting from three of the classes C, B, A. Now the issue is, for instance, see this class Z extending from K1, K3, K2. It is inheriting from all three and in turn inheriting from others also. But in what order do I put in the code of all these K1, K3, this A, B, D, O? In what order? Basically, when I'm doing this, what is supposingly happening under the hood, that all the classes from which this Z is deriving from, either directly or indirectly, their code is put inside it. When we, just like when we were doing in our contracts, like here I have this contract O and A is inheriting from O. So the variables, suppose state variables u int x was declared, then A can access that variable x. And now in case of multiple, so we can in some way say that the whole definition of contract which was mentioned here is placed inside this contract. In some way we can say that. Now if A was inheriting from multiple classes, in what order do we put their definitions inside A? Suppose A was inheriting from B, comma C. Then first do I put B's definition and then C's, or first C then B? Suppose C was overriding a modifier of B, then it makes sense to put C after B. And suppose both of them were overriding a modifier in their base class. Suppose B was inheriting from O, C was inheriting from O, O had some modifier and both B and C were modifying them, basically overriding them. Then when I do A is B comma C, whose overridden definition do I follow, B's or C's? So that is this order in which we should finally have a resolved inheritance is what is C3 linearization is helping us. Let us see with the help of example. They they have shown here how to compute the linearization of each of them. Starting from O, all these classes, they have shown how to compute the linearization. So let us look at it. Linearization of O. What is linearization will become more clear with the help of this example. Linearization of O is trivially the singleton list O because O has no parents. So in case a class is having no parents, its linearization list is it itself, a list containing it itself. Next, suppose we have A. Now for A, we can see that it has a parent O. So in case of that, the linearization of A is A plus, we have this plus here, merge of its parents linearizations with the list of parents. So this is the rule, the C3 linearization rule, which we have to keep in mind. Whatever class I am computing linearization of, first I put that class, then plus merge of its parents linearization in case we had only one parents of LO with the list of parents. Suppose we had this K1. In case of K1, you can see K1 had three parents, three direct parents A, B, C. And what we write in that case, the linearization of K1 is K1 plus merge of the linearization of K1 parents in the order which we gave, CBA. So linearization of C, first parent, second parent, third parent, then then the parent list. So CBA. Let us reread it. First, find the linearization of K1 parents. Here it is, which is LC, LB, LA, and merge them with the parent list, CBA. So this is the rule which we have to keep in mind. The linearization of some class is that class plus the merge of its parents linearization with the list of parents. So let us continue with linearization of A. We wrote A plus merge the parents linearization in case one parent O with the list of that parent O. So what we come up with this thing, merge this O comma O. How do we technically merge? We haven't explained about this merge yet, but this will become clear with the following examples. In this case, since these both entries are same, we basically get O itself. Technically, we will see later how we do it. So which simply prepends A to its single parents linearization. So we just appended this O, right? Next, since A, B, D, E and C are similar, all of them had the same thing. I mean similar way you get their linearization. Now let us look at the linearization of K1. With this we will have clear understanding about linearization. So we wrote this K1 plus merge of LC, LB, LA, its parents, and then the list of the parents. So what we get is this K1 plus merge linearization C is this C comma O, that is what we have written. Then B comma O for the linearization of B, then A, and then this list. Now how do we merge it? How do we merge it? Let us see what they have done. First, for every list, we define something known as head. Head is the first element of the list. So for this list, the head is C. For this list, head is B. For this list, head is A, and for this list, head is again C. And then we define the tail. Tail is the remaining list once we remove the head. So in this case, the tail will be a singleton list containing O. In this case, tail will be again singleton list containing O. Similarly here, in this case, the tail will be a list of two elements B comma A. So with this, I have told you about head and tail. Now what we start when we want to merge this, we go in this direction from left to right and we look at the first head, the first head which we can see, which is not present in the tail of any other list. Here, if we look at this head C, this is not present in this tail, not in this, and also not in this tail. It is present as head in this last list, but is not present in the tail. So C is the good candidate. Class C is a good candidate for the first merge step because it only appears as the head of the first and the last list. So I'll take C out and append it to my this list. This is the rule which we are following. Then what we have left is this O, since C is taken out, then BO, AO, and C is taken out from here. Let us look at this head O. It is present in this tail and this tail. So this is not a good candidate. Let us look at this head B. It is not present in this tail, either of tails, this tail, not in this tail either. So B is a good candidate. Class O is not a good candidate for the next merge step because it also appears in the tails of list 2 and 3, but class B is a good candidate. So we have taken B outside, and then we have taken B since taken away from the list it was contained in, and we have O, AO, and A. So let us look at O, again present as the tail in this list, so no. Let us look at this head A. This is present as a head only in this last list. So yeah, this is a good candidate. Taken out here, and then O is left. We took the O out, is a good candidate. So yeah, so this is the what we got as the linearization order of K1. So if I show you this diagrammatically, K1 CBAO, K1 C B, what was it? AO. This is the linearization order. What is the use of this linearization order? Some gist I gave you. We will see the solidity example, and then why we have this linearization order will become crystal clear. But let us just have this slight reading of the merge part. The merge of parents linearization and the parent list is done by selecting the first head of the list which does not appear in the tail, all elements of a list except the first. So they have given you the definition of tail of any of the lists. Note that a good head may appear as the first item in multiple lists at the same time, but it is forbidden to appear anywhere else. The selected element is removed from all the lists where it appears as a head and appended to the output list. The process of selecting and removing a good head to extend the output list is repeated until all remaining lists are exhausted. If at some point no good head can be selected because the heads of all remaining lists appear in any one of the tails, then the merge is impossible to compute due to inconsistent orderings of dependencies in the inheritance hierarchy, and no linearization of the original class exists. So I hope this in itself is clear. So let us read what the documentation has to say about inheritance. With that, why do we have this linearization order will also become clear. Like what is the main purpose of it? Solidity supports multiple inheritance including polymorphism. Multiple inheritance, I hope it's clear. What is polymorphism? They have explained here. Polymorphism means that a function call, internal and external, always executes the function of the same name and parameters type in the most derived contract in the inheritance hierarchy. In our case, this is the inheritance. Let me take some different color. Inheritance hierarchy of K1. So this is the inheritance hierarchy of K1. So what they mentioned here, yeah, so suppose we had a function with name, let me again change the color. Suppose function foo was defined in B and function foo was also defined in C. So K1, when it is executing the function foo, it will execute the foo definition of C, not B. So this is the use of the inheritance hierarchy. Regarding this function overriding, there might be some doubt about that, which will become clear more as we progress. So yeah, polymorphism means that a function called internal and external always executes the function of the same name and parameters type in the most derived contract in the inheritance hierarchy. This has to be explicitly enabled on each function in the hierarchy using the virtual and override keywords. See function overriding for more details, which we will see, so that part will become clear. It is still possible, to call functions further up in the inheritance hierarchy internally by explicitly specifying the contract using this contract name dot function name or using super dot function name. This super dot function name I tell, and both these I will tell now. If you want to call the function one level higher up in the flattened inheritance hierarchy, so this super dot function name you use if you want to call one level higher up in the flattened inheritance hierarchy. So this is the inheritance hierarchy, you can say in some way, and this is the flattened one for K1. That is also important, that for whom we are talking about K1. So in case of K1, if I do super dot foo, if I write inside the contract K1, then it is going to call the function foo of C. And inside C, if I write super dot foo, then it is going to call the foo function of B, right? And if B does it, it is going to call for A. And there is a catch here. C is calling, when I do super dot foo inside C, we are calling the foo function of B because we are looking at the inheritance hierarchy of K1. This is very important to keep in mind. For instance, in the very same contract, we can have some other inheritance hierarchy where super.foo inside the contract C will not, supposingly may not call B's foo, but some other contract's foo. It depends upon the inheritance hierarchy we are looking at, of whose we are looking at. In case of K1, if we are looking for that example, then it is going to call B's foo function. It will become clear with more example, which we will see shortly. And in case K1 wants to call B's foo function, then it can simply do B dot foo. Like that, it can call foo function of B. So I hope this makes it somewhat clear. Now, when a contract inherits from other contracts, only a single contract is created on the blockchain, and the code from all the base contracts is compiled into the created contract. So this is like what I meant when I was saying, we can assume that the code is actually placed in the derived class. So that is what I meant. This means that all internal calls to function of base contracts also just use internal function calls. This super will use jump and not a message call. So I hope this part is clear. Moving on. State variable shadowing is considered as an error. This is important. A derived contract can only declare a state variable X if there is no visible state variable with the same name in any of its bases. So I hope this part is clear. Now let us look at this example here. This will also clear many things up. We have a contract named owned, which has this state variable owner, and then in the constructor, whoever is deploying this contract, that address is being put in this owner variable. So that is what this contract is doing. Then we have this destructible contract, which is inheriting from this owned contract. This has the function destroy. This is marked as virtual, and what this keyword virtual helps, that if some class is deriving from destructible class, then that class can override this function destroy. This overriding of a function of a parent is possible only if that function was marked as virtual. So that is why they have used virtual here. So this function, what it does, that if the message dot sender is owner, the one who is calling this function, then yes, the self destruct they are doing. Then we have this base 1 contract, which is deriving from this destructible contract. And then, so here they are overriding this function destroy. Here they are overriding this function destroy. That is why they have this override keyword. And again, they have marked it as virtual so that any class deriving from base 1 can override this function destroy. Then we have this base 2 contract, which is again doing almost the same thing as base 1. Yeah, exactly same thing as base 1. And then we have this final contract, which is inheriting from these two contracts, and it is having this destroy function overriding. Now they regarding this override part, that why they have explicitly written this base 1 base 2, I will explain later. For now, focus on the idea which I want to give about is inheritance. And then base 2 dot destroy, I mean what they are doing is something which I will cover later, but let us first find out its inheritance hierarchy. Let us find out the flattened inheritance hierarchy for this final contract. So let me also write it. What I'm going to do, I'm going to label this contract owned as O for the brevity sake, destructible as D, base 1 as B1, base 2 as B2, and final as F. So if I write it, so let's do this. We have this O, and then this, I think, yeah, D, then here it was B1, then B2, and then we had F. Let me also verify here. B1, B2, DD, D is O. Yeah. Now what they wrote, this is important, that F is, in what order did they wrote it? B1, B2. B1, comma, B2. Now this is slight difference in solidity. In case of the C3 linearization example which we were seeing, the order we took was the order in which it was given. For like K1, when we were computing the linearization of K1, the parents list and whatever the linearization which we were taking in this order, first C, then B, then A. But the way Solidity does things, that you have to traverse it in the reverse direction. So first A, then B, then C. In our case, since they wrote F is B1, B2, so we have to go, I mean, in this direction. So the first will come B2, then B1. So what we will write, that linearization of F is equals to this F itself plus this merge function. Inside this merge, we have this linearization of B2, linearization of B1. So, in this direction we are traversing. So first B2, then B1, and then the list of parents B2, B1. This is what we have. Since that app is quite jittery, I have moved here. So where were we? We were computing the linearization of F. So we wrote F itself along with merge of its parents in this order. So first B2, linearization of B2, then linearization of B1, and then the list of the parents in order B2, B1. So since it depends upon the linearization of B2, B1, so let us compute them. So L of B2 is equals to B2 itself along with the merge of its parent, which is D alone. So this is equal. So let us also then compute linearization of D. So L of D is equals to, this is, we can tell anyways, but still let's see the formulatic way. Merge this L of O is O. We can see that. Now we have written for its parent, and this is simply D, comma O, because L of O is O, so O merges O itself, that is taken out and appended to this. Therefore, now if we write L of B2 here, that is equals to B2 plus merge L of D, which is this D comma O, and then D. Now if we start looking from here, if we look at this head, this head D, since it is not present in the tail of any other list, here also it is present as the head, not in the tail, so that can be taken out, and what we get is this B2. D is taken out. What is left is O. This O is left, and that is what is left, so that also comes out. Similarly, for B1 we have this B1 D comma O, since they both are similar, B1 B2. So now we have it. Now if we compute here plus merge L of B2, which is B2 DO, L of B1, which is B1 DO, then this B2 B1. Now if I look at this head B2, it is not present in this tail, neither it is present in this tail, so it's valid candidate and will be taken out. Sorry. D comma O, B1 D comma O, B1, since B2 is taken out. Now if we look at this head D, it is present in this tail, so this is not a valid candidate. If we look at this head B1, since it is nowhere, here also it is not present in tail, here also it is not present in tail, it is present as head, so B1 is what which will be taken out. So if we write here F B2 B1 plus merge this D comma O, D comma O, yes. So it is self-evident. What we will then get is this B1 D comma O. This is what we will get. So the order which we got was F B2 B1 D O, right? So this is the example which we were looking at. If we look at this example, which is almost same in the sense the inheritance hierarchy is the same. If somebody calls the destroy function of this F final, right? So we come here, we look at the definition is saying super dot destroy. So F B2 B1 D0, F the parent in the inheritance hierarchy, parent of F is B2. So this super dot destroy will call the destroy function of B2 here. So we are here and then we are calling this definition which is saying again super dot destroy. So F B2 B1. Since parent of B2 in this inheritance hierarchy when we are looking at is B1. So B1's destroy function is what is being called. You might think that since base 2 is inheriting from destructible, the super dot destroy will call the destructible destroy function. No, we have to look at the context in which we are saying. We are talking about the inheritance hierarchy of this F final. So when it is being called here, since I told you, like we saw it also here, the whole of the code is actually compiled into that contract. We saw that here. Yeah, when a contract inherits from other contracts, only a single contract is created on the blockchain, and the code from all the base contracts is compiled into that one. So that is what happened. We have to look in the context, and this clarifies it beautifully. Super dot destroy here in that context is calling base 1's destroy, and now F B2 B1 D, and since B1's parent will be in that case D, so super dot destroy will call this D's destroy function, and that is where this destroy function chain is getting over, and this example explains it. What the previous example was doing, instead of using super, it was explicitly providing the class name. So here base2 destroy is getting called, and the base2 function, base2 contract, sorry, the destroy function there is calling destructibles destroy, not super, destructible. So directly we are going here in this destructible destroys function. So I hope with that this part is also clear, contract name and this super part. So if we read it, what they call, that note that above we call destructible destroy. In this above example, they have taken that context. Somewhere they are calling that function name dot the contract name dot destroy. Where exactly are they doing that? Let me see. Destructible, yeah, here they are doing destructible dot destroy. We need not look at that. I mean, they have just taken just to saying that to forward the destruction request. The example was to forward the destruction request, but they are explicitly naming the contract whose destroy function is called. So the way that is done is problematic, as seen in the following example, where they explicitly called the contract name dot destroy. So what they are saying, if you want to call the parent, then use super dot destroy. Don't use the explicit name of the some contract which you might think as the parent, but it need not be. It depends on the context in which we are looking at. So that is what this signifies. A call to final.destroy will call base2.destroy in that above example, because we specified explicitly in the final override, but this function will bypass base1.destroy. The way around this is to use super. As I have explained thoroughly, if base2 calls a function of super, it does not simply call this function on one of its base contracts. Rather, it calls this function on the next base contract in the final inheritance graph, which I have told you. So it will call base1.destroy. Note that the final inheritance sequence is starting from the most derived contract, final base2, base1, destructible owned, which we have seen. The actual function that is called when using super is not known in the context of the class where it is used, although its type is known. So here you might think in its context the super will be destructible. No, unless we do the very final thing, we won't know what the super is actually. Next, let us look at function overriding. Base functions can be overridden by inheriting contracts to change their behavior if they are marked as virtual. The overriding function must then use the override keyword in the function header. We have seen that. The overriding function may only change the visibility of the overridden function from external to public. This is their rule. Usually, external is more restrictive. External is more restrictive than public. So you might think public to external, but the rule is saying that from external to public is allowed. The mutability may be changed to a more strict one following the order. Non-payable can be overridden by view and pure. View whereas can be overridden by pure. Payable is an exception and cannot be changed to any other mutability. They have this very simple example where this middle is inheriting from base, which has defined this function foo, and this inherited is inheriting from this middle and therefore also inheriting from this base one, where it is overriding this function foo. I'm changing the visibility from view to a more restrictive one, pure. Not the visibility, the mutability, I mean to say. So this example is for that. Now let us first understand this part, which is very important. It is, let us start reading from here. It is not required to override a function directly or indirectly inherited from multiple bases if there is a base contract that is part of all override paths for the signature. Basically, like here we are explicitly writing this base. When we did that example, right, this example which we did, we were explicitly, the code was explicitly overriding and specifying that base 1, base 2. So when do we have to specify name? What name do we have to specify? And when we can avoid it? So let us understand when we can avoid it. When we need not write the names alone, override keyword is enough. Because I feel that once we understand when not to write, then it will also become clear. The explanation will become clear about when to write also. So looking at when not to write, It is not required to override a function directly or indirectly inherited from multiple bases if there is a base contract that is part of all override paths for the signature and either one or two holds, and they are mutually exclusive. One, that base implements the function and no paths from the current contract to the base mentions a function with that signature, or that base does not implement the function and there is at most one mention of the function in all paths from the current contract to that base. So to explain this, I have cooked up an example from which through which we will understand what this all this means. So this is the example which I have. I have this contract O1 defining this function foo, then O2 defining this function foo, and then A is inheriting from O1 and O2, and I have this foo function here. B is inheriting from A and some other function. C is inheriting from A and D is inheriting from C comma B, I mean CB, and it is redefining this foo bar. So let us first look at the inheritance graph, the overall graph. We had this O1 O2 defining foo. So we had this O1 O2 which defined that foo function, and then we had A which is inheriting from both of these, and it is also defining that same function foo. So we have this A which is inheriting from these two, and then B is inheriting from A. Wait, what is it exactly? Yeah, B is inheriting from A. So let me write it like this. Let me erase it. Yeah, let me write it like this. A and B is inheriting from A, and what do we have next? C is inheriting from A also. So instead of writing like this, let me write it like this. Two arrows. One is for C and another arrow is for B, right? Then D is inheriting from both of these. Now suppose D wants to override this function foo, which it is doing, right? D wants to override this function foo. If we look at, we will also have a linearization order, right? If we were to look at it, but without bothering about linearization order, C is not redefining foo. Similarly, B is not redefining foo. D wants to redefine foo, and in this path from D to A, only A is redefining foo. So if we read it again, that base implements the function, in our case A, and no paths from the current contract being D, to the base A mentions a function with that signature. So that base implements the function A, and no path, if we look at this path, nowhere else the foo is getting mentioned, right? C is not mentioning, neither is B. So this one is holding. So it is not required to override a function directly or indirectly inherited from multiple bases if there is a base contract that is part of all overrides path of the signature. Here this A, if we look at this path, in both the paths, if we look, A is that base in which we hit. We must go through A. So that is the base contract that is part of all override paths for the signature, and that base A is implementing foo also, and no path from the current contract D, that is to that base, mentions a function with that signature. So this is holding here. And if we look at this, when I am writing foo, I need not give anything here, C, B, whatever. I need not mention. I can just simply write override keyword. Now if we want to look about this second point, that base does not implement the function, and there is at most one mention of the function in all paths from the current contract to that base. So here also we can take the base as A because this first part is holding. I mean, if we look at this bar example, this function bar which the B is implementing, so we can take A as base, it's fine. So if there is a base contract A, that is part of all override parts for that signature, in our case this bar. And second, that base does not implement the function. Here A is not implementing that function bar, and there is at most one mention of the function in all paths from the current contract to that base. Here only this path where this B is having, only B is having that function defined bar. So even in that case also we need not specify what we are overriding, we just can specify this override keyword. So this example I wrote to illustrate that. Now to understand when to specify, let us understand this. If a contract inherits the same function from multiple unrelated bases, it has to explicitly override it. So they have this example, base 1 defining this function foo, base 2 defining this function foo, then inherited is inheriting from base 1, base 2. Now this function foo derives from multiple bases defining foo, so we must explicitly override it. Here base 1 and base 2 are in no way related. I mean, they are not inheriting from some common base, anything like that. So we have to explicitly override both of them. So override base 1, base 2. That is what we must do in case the bases are unrelated. And if the bases are related, just take the most derived one. Just take the most derived one in your graph. So suppose for this base 1, base 2 there was a parent. If I look at this, suppose for this base 1, base 2 I had a parent base. So I'm getting a diamond type of structure. I have this base in the top, then you can put base 1 in the as a left child of base and base 2 as the right child of base, and then inherited is the inheriting from this base 1, base 2. So if you draw that graph the way I drew, then you will see, you will get a diamond. So in that diamond, although these base 1, base 2 are related, but if we look at the most derived one, like if we look here, for multiple inheritance, the most derived base contracts that define the same function, in our case base 1, base 2, must be specified explicitly after the override keyword. In other words, you have to specify all base contracts that define the same function and have not yet been overridden by another base contract on some path through the inheritance graph. Here, base 1 overrided the base foo, similarly base 2 overrid. So in that graph, now the most derived will become base 1 for this base 1 base part. Similarly for base 2 base part, base 2 becomes more derived, and this inherited, we now look at these two most derived bases. So the most derived base contracts in that case will be B1, B2. I mean base 1, base 2. So I hope with this part is clear. Yeah. So let us move forward. Few more details. Functions with private visibility cannot be virtual. That is obvious. I mean, that is what private signifies, that you cannot inherit it. Functions without implementation have to be marked virtual outside of interfaces. In interfaces, all functions are automatically considered virtual. This is something which we will see. And this point is relevant for the abstract contracts, which we will see too. This thing we will see when we will do the interfaces. Public state variables can override external functions if the parameter and return types of the function matches the getter function of the variable. So they have explained this here with the example. So here we had this contract A defining a function f which was external, and the return type and everything is matching with regard to this public variables getter function. So it was possible to override it. So public state variables can override external functions if the parameter and the return types of the function matches the getter function of the variable. And of course we must override because we are redefining a function with the same name f. So how can we do that? Only by overriding the previous one. So we must do that. While public state variables can override external functions, they themselves cannot be overridden. So this is the rule. Now few more bits about constructors. Before the constructor code is executed, state variables are initialized to their specific value if you initialize them inline, or their default value if you do not. The deployment of the code costs additional gas linear to the length of the code. This is also something to keep in mind. If there is no constructor, the contract will assume the default constructor which is equivalent to this. And they have given an example also here. You can look into it. And regarding this part, what is this? We will see shortly, immediately now. Before I cover this, let me cover this arguments for base constructors. The constructor of all the base contracts will be called following the linearization rule, which we have already seen, the C3. If the base constructors have arguments, derived contracts need to specify all of them, and this can be done in two ways. Here we have this example to illustrate those two ways. This base contract is there which is having this constructor initializing this x state variable. Now the first method, when this derived one is deriving from this base contract, to give the constructor argument, either you can directly give here when you are inheriting, so either directly specify in the inheritance list, or this is the other way. Other ways you don't specify here anything but through a modifier, so or through a modifier of the derived constructor. So when you are writing the constructor of your derived contract, you here give the modifier and you give the constructor argument of this base contract. And notice the power here in this second form is that this argument can depend upon the argument of this deriving contract. So from this why they have initialized this constructor of the base. This is useful if you are doing some constant value like that. Here 7 is constant, and this is useful if you depend upon this constructor's arguments. This is something which we will see shortly. So the first way to do it is more convenient if the constructor arguments is a constant and defines the behavior of the contract or describes it. The second way has to be used if the constructor arguments of the base depend on those derived contract. Now in case you don't give the arguments of the base contract, like here this is not giving the constructor arguments for the base, then you must declare it as an abstract. So what they are saying, if a derived contract does not specify the arguments to all of its base contracts constructors, it must be declared as an abstract contract. In that case, when another contract derives from it, that other contract's inheritance list or constructor must provide the necessary parameters for all base classes that haven't had their parameters specified. Otherwise, that other contract must be declared abstract as well. For example, in the above code snippet, see derived 3 and derived from derived, basically these two. Since we did not specify the constructor arguments, we must declare it as an abstract. Now for some contract deriving from this derived 3, like here, you can give the constructor arguments like this. So, and now you need not put abstract here. So this is what that part was telling. Now if I move backwards, I left this part because I thought that it would be better that we cover this part first. So now if you read it, you can use internal parameters in a constructor, for example storage pointers. Now what is storage pointer? Like we did reference types, right? In reference types we saw that we can modify the original value by some reference. If I by this alias I was able to modify the original value. So my alias was pointing towards that original value, and therefore we also call it a pointer. Now in case the reference was of storage type, so yeah, we had a storage pointer. So in this case, the contract has to be marked abstract because these parameters cannot be assigned valid values from outside but only through the constructor or derived contract. So let us understand this with the help of an example. I wrote this example. I have this contract base which is having this state variable x. Now to initialize this state variable x, I am taking in a storage reference. I take the storage reference and I put x to be the first element inside that array. If I don't declare it as an abstract, let me also comment this part out. Okay. Yeah, now if I save, I'm getting an error and it is saying this parameter has a type that can only be used internally. You can make the contract abstract to avoid this problem. So yeah, we made this abstract to avoid this problem. Now how do we use it? When I'm deriving from this abstract contract, I have declared a array here, and inside the constructor of this derived contract I'm passing in this reference, and therefore it is getting initialized. Now if I save it, deploy it, and now if I call this x function, because it was marked as public, so it is present inside derived, it was inherited, and since it's public, the getter function is generated. Now if I call this x, I should get the answer as 7 because the first element is 7. So yeah, the 7th should come, and it has come indeed. So I hope this part is clear. Moving on, we have this section, multiple inheritance and linearization. We have as such done it. Languages that allow multiple inheritance have to deal with several problems. One is the diamond problem, and if I open their link, this is what I get. The diamond problem, sometimes referred to as the deadly diamond of death, is an ambiguity that arises when two classes B and C inherit from A. Here B and C is inheriting from A, and class D inherits from both B and C. If there is a method, that is a function, in A that B and C have overridden and D does not override it, then which version of the method does D inherit? That of B or that of he? That of C, I mean. So that is what the linearization order tells us, and we are using this C3 linearization. Solidity is similar to Python in that it uses C3 linearization to force a specific order in the directed acyclic graph of the base classes. Now what is this directed acyclic graph? Basically, the graph that we draw previously, all these were directed acyclic, and this term directed acyclic you will understand if you understand all these terms. What is directed graph, what is graph even, and acyclic, directed acyclic graph means a directed graph with no cycles. So I wonder whether this much detail, but suppose these are 3 vertices and I connect the edges like this. Let me draw vertices with some other color. So these were the vertices, and these are the 3 edges, directed edges. Suppose if I write like this, so B to C one edge is there, C to A one edge is there, and A to B one edge is there. So what is a graph? Graph is basically a set of V comma E. We usually write in computer science terms that graph G is a set of V comma E, where V is the set of vertices, here A, B, C, and E is the set of edges. Here we have 3 directed edges, A, B, B, C, and C, A. So that is the graph. And this is the directed graph only because the edges are directed. They have this particular direction. And we say that it is acyclic in case there are no cycles in the graph. So for instance, in this graph there is a cycle that I can move from A to B, then B to C, and then C to A. I can reach back my starting point following these edges. So it is cyclic. Whereas this was acyclic. I cannot reach back to D. suppose I start from here D to C, C to A, I cannot take this edge A to B because it is directed from B to A. So I hope with this what is acyclic part is clear, and this part is also clear, the diamond problem. Okay, so to force a specific order in this directed acyclic graph, we use C3 linearization. This results in the desirable property of monotonicity, but this allows some inheritance graph, as we will see, especially the order in which the base classes are given in the is directive is important. As we saw, we start from the reverse part, from the right to left. You have to list the direct base contracts in the order from most base-like to the most derived. Note that this order is the reverse of one used in Python. Don't get confused by all this. Simply understand from right to left we go in that C3 linearization rule. And they have mentioned few things here, that another simplifying way to explain this is that when a function is called that is defined multiple times in different contracts, the given bases are searched from right to left, left to right in Python in a depth first manner, stopping at the first match. If a base contract has already been searched, it is skipped. So if you already know what is depth first search, etc., and if this makes sense, fine. But as such, I don't see why we should bother about it. So if you understand this depth first search, etc., fine. You can give thought to this, else you can ignore, in my opinion. In the following code, Solidity will give the error linearization of inheritance graph impossible. So they have this code, contract X, contract A is inheriting from X, and then contract C is inheriting from A, X. Now if we try to do that, the C3 linearization rule, so in that case, maybe that can also serve as a revision. L of C is equals to C itself plus merge, and what was it? A, X. So merge L of X, because we follow right to left, L of A, and then this list of parents X, A. Right? So let us find this L of X. L of X is X itself plus merge, and what is X parent? Oh, X is no parent. So X is singleton, just X itself. So this part we can ignore. Next, let us write about L of A, and if I saw it correctly, it was deriving from X. So in that case, it is A plus merge. Here we will write first L of X, which is X, and then this singleton X, the parent, right? So this is simply A, X. Now if we put it back there, let me change the color. So L of C is equals to C plus merge L of X, which is X, L of A, which is A, X, and then X, A. Now here, if I try to take this head X, it is appearing in this tail, so I cannot take it. Similarly, if I try to take this A, it is appearing in this tail. So we have reached, we are basically stuck. So in that case, the C3 linearization is, it has failed in the sense we cannot find a C3 linearization. So hence it is not possible. The reason for this is that C requests X to override A by specifying AX in this order, but A itself requests to override X, which is a contradiction that cannot be resolved. I hope by going through the C3 linearization rules, this part has become clear. Moving on, we have this. One area where inheritance linearization is especially important and perhaps not as clear is when there are multiple constructors in the inheritance hierarchy. The constructors will always be executed in the linearized order, regardless of the order in which their arguments are provided in the inheriting contracts constructor. This I hope in itself is clear, but they have also provided this example. So let us also go through this example to make it further, to have the picture more clear. So we have this one contract base 1, constructor is empty. This another contract base 2, constructor is empty. Now this derived one is inheriting from base 2 base 1. So the order will be D1, B2, B1. This will be the order D1, B2, B1. So this is the inheritance hierarchy which they have also listed here. So therefore the constructors are executed in the following order. First B1, then base 2 and then derived 1. Alright, and this is the order which we gave, but this order is, does not matter in which order we specify here. It will execute only through, following the order which is the actual inheritance hierarchy. Here we have this derived 2. They have changed, they have swapped base 2 base 1. So the order has changed. The first in the inheritance hierarchy is base 2, then base 1 and derived 2. So they are executed, the constructors is executed in this order. Now notice, you might think that base 2 is given here first, but here they have given base 1 first, rest all is same, and then also the constructors are executed in the same order. So this example was to solidify our understanding regarding this concept. Next, we have this section, inheriting different kinds of members of the same name. It is an error when any of the following pairs in a contract have the same name due to inheritance: a function and a modifier, a function and an event, and a modifier. As an exception, a state variable getter can override an external function, as we saw. Okay, so let us now move on to abstract contracts. Contracts must be marked as abstract when at least one of their functions is not implemented, or when they do not provide arguments for all of their base contract constructors. I hope this is clear in itself. Even if this is not the case, a contract may still be marked abstract, such as when you do not intend for the contract to be created directly, because that is the feature of abstract contracts, that you cannot instantiate them directly. Abstract contracts are similar to interfaces, which we will look shortly, but an interface is more limited in what it can declare. So interface is limited than abstract contract. Such abstract contracts cannot be instantiated directly. This is also true if an abstract contract itself does implement all defined functions. So in case you have a contract in where you are defining all the functions, but if you have marked that contract as abstract, then you cannot instantiate it directly using those new etc. keywords. The usage of an abstract contract as a base class is shown in the following example. So they have this example here. Here, to make this contract as an abstract, we have put abstract keyword here. And since we have these functions whose definition we have not given, so in that case this must be marked as abstract. Now this contract cat is inheriting from this abstract contract, and since it is defining the undefined functions inside this abstract contract, here they have defined it, and I like their sense of humor. So indeed we need not put an abstract keyword here. If a contract inherits from an abstract contract and does not implement all non-implemented functions by overriding, it needs to be marked as abstract as well. So here, in case we were not completing the definition of this utterance function, we would have need to mark this contract cat also as an abstract contract. Abstract. So what is the use of abstract contracts? Why do they exist in first place? This is for that. Abstract contracts decouple the definition of a contract from its implementation, providing better extensibility and self-documentation, and facilitating patterns like the template method and removing code duplication. So let us understand this one by one. Suppose I have a base contract. Some of the functions inside that base contract I have completely defined, but some functions I have not defined. I have told that such functions should exist. They must exist, in fact, in the child, the one inheriting from this abstract contract. Now the child needs to implement those uncompleted definitions according to its own need. Better explain about all this template method, code duplication, etc. I have this example. Here is my abstract contract pet. Why abstract? Because this function say hi is not fully implemented, although some functions are. For instance, every pet might have a price if case you are buying it and a name. So this constructor will initialize this price and name, and then I have this get price function which will return the price, and the get name function which will return the name, and then every pet will have its own way to say hi. Now in case if I do this contract dog is pet, here I need not implement all this again, the name, price, how to get the price and name, because that is inherited. So in this way I have avoided code duplication. Now I have a dog, I am adding additional property, the breed, and then using the constructor I am initializing all the values including the base one. And then I am also implementing the say hi function, and the way dog is saying hi, either bark or you can write bhau. So yeah, this is dog. Similarly, I have a cat. For cat also, I mean similar thing. I just made this say hi meow for the cat. Now in case I deploy this, suppose I deploy this cat, you can also do this in your contract. Initiate them like that. So here I am deploying my cat. So I have deployed. Here is my cat. I can get the name, price, and the way the cat says hi is this. Similarly, I can have my dog, right? So I needed to select here dog. Yeah, so the say hi is different. So the template method actually says, like here I have written this function say hi, and I am saying that my child's, the one inheriting from this pet, must implement this say hi function. I will write here what do I want say hi to do, either in form of comment, like yeah, I can give an Natspec comment that what this function say hi must do. I have given the idea. Now depending upon the context, like dog will say hi in a different way and a cat will say hi in a different way. So the childs can do the implementation part. I will give the design, the high level idea that this must be implemented. So this is the template method. So they decouple the definition of a contract from its implementation, providing better extensibility. Here you saw how I had a dog which is pet and also a cat which is pet. So that's why better extensibility and self documentation, because in the abstracted way here I can write what I mean in the abstract class itself. I can write what this say hi does, and one need not bother reading about the definition of the function. Just the comment, the high level idea is enough. And facilitating patterns like the template method and removing code duplication, we saw all that. Abstract contracts are useful in the same way that defining methods in an interface is useful. It is a way for the designer of the abstract contract to say any child of mine must implement this method. So I hope this is clear, and also we have this abstract contracts cannot override an implemented virtual function with an unimplemented one. So they have given this note here. Just like how we were calling functions, basically we used one of the ways to call the function of some other contract was to use an interface. I mean you could have used abstract contract also. Basically the purpose is to know the interface. And just like if I show you this IERC20, this is an ERC20 interface, and you see they have not defined the functions here. Of course, because it is an interface, we will see formally interface later. They have not given the definitions here, the functions definition, like what all the function steps are, but they have given the high level idea that this transfer function moves the amount tokens from the caller's account to 2. So just like how interface helps here, Same way abstracts can also do. Abstracts have slightly more features, slightly more power, that some of the functions can be implemented, like here I implemented this get price get name and so on. So I hope with this the abstract contract part is clear. Next, let us look at interfaces. Interfaces are similar to abstract contracts, but they cannot have any functions implemented. There are further restrictions. They cannot inherit from other contracts, but they can inherit from other interfaces. All declared functions must be external in the interface, even if they are public in the contract. They cannot declare a constructor. They cannot declare state variables. They cannot declare modifiers. So you see how interface is more restrictive. Interfaces are basically limited to what the contract ABI can represent, and the conversion between the ABI and an interface should be possible without any information loss. So I hope this is clear. We have looked in ABI before, and here they have this example of a sample interface. You can see inside this interface token they have defined an enum, a struct, and a function whose implementation is not complete. Contracts can inherit interfaces as they would inherit just like any other contracts. All functions declared in interface are implicitly virtual, so you need not mention virtual. And any functions that override them do not need the override keyword also. This does not automatically mean that an overriding function can be overridden again. This is only possible if the overriding function is marked virtual. So I hope this is clear. Interfaces can inherit from other interfaces. We have already read about it. This has the same rules as normal inheritance. All that same linearization, etc. And all, like here they're doing this override part. So just like your normal inheritance rule in contract which we covered. Types defined inside interfaces and other contract like structures can be accessed from other contracts. So here inside this token interface, other contract can access token.coin, token.token type they can do. So token.token type or token.coin is very well valid. And just to verify, I have this same interface which they had. Inside I'm using there this non-fungible value inside their enum token type. As we know that it is as such uint8, the very first one starts from 0, so it's 0, and this one is 1. So if I am assigning it to my state variable high inside this contract just try, then this should have value 1. So in case I try to deploy it and then call this variable high, I am indeed getting the value 1. So I hope this is clear. Alright, let us now look at libraries. This section is somewhat complicated, so I request utmost focus from your end. Basically, for instance, we have seen public functions, and we have noted that in public functions I cannot pass as an argument a storage reference type, right? That is not allowed in public functions or external functions, but is allowed in internal or private functions. But in case of library, a function which is defined inside library, that can be public and can also accept a storage reference type. Then the question comes, what is then the use of this visibility, internal, external, in case of libraries? So there is use, and I have told you this now so that when reading this section in the libraries, when reading about libraries, you pay focus about these areas. So let us begin. Libraries are similar to contracts, but their purpose is that they are deployed only once at a specific address, and their code is reused using the delegate call code until homestead feature of the EVM. This means that if library functions are called, their code is executed in the context of the calling contract, that is, this points to the calling contract, and especially the storage from the calling contract can be accessed. As a library is an isolated piece of source code. It can only access state variables of the calling contract if they are explicitly supplied. It would have no way to name them otherwise. How we explicitly specify as an argument we will see shortly. Library functions can only be called directly, that is without the use of delegate call, if they do not modify the state, that is if they are view or pure functions, because libraries are assumed to be stateless. Basically, we have seen in Solidity, as we had call, static call, and delegate call. These three we had, these low level calling utility which the Solidity provided to us. So library functions are usually called by delegate call, but you can also call them using the normal call opcode in EVM, but that is possible only if they are view or pure functions. And it is also important to know how Solidity does this, because we haven't seen anything like that. How can it stop like library functions can only be called directly if they do not modify the state, but we haven't seen something like that ever before, that how it is actually stopped. The thing is, yes, if we see this section, as mentioned in the introduction, if a library's code is executed using a call instead of delegate call or call code, it will revert unless a view or pure function is called. And this is what I meant, that like EVM does not provide a direct way for a contract to detect whether it was called using call opcode or not. I mean, as such, I can call anything using this call thing, any function whatsoever. Then, but what Solidity does is that, but a contract can use the address opcode to find out where it is currently running. The generated code compares this address to the address used at construction time to determine the mode of calling, and they do this only for non-view and non-pure functions. So in case, like if you see this, like this is not entirely important for us to have understanding of, but if we just read it more specifically, the runtime code of a library always starts with a push instruction, which is a 0 of 20 bytes at compile time. When the deploy code runs, this constant is replaced in memory by the current address, and this modified code is stored in the contract. At runtime, this causes the deployed time address to be the first constant to be pushed onto the stack, and the dispatcher code compares the current address against this constant for any non-view and non-pure functions. So the dispatcher is doing this comparison only for non-view and non-pure functions, and this is the therefore the reason why we can call using the call opcode the view and pure functions. But of course, you can do some clever tricks inside your view functions to make them sort of like non-view, but I mean that is not the point here, but I hope you understood this part. In particular, it is not possible to destroy a library. Let us read this also. Here I told you about public internal at the very beginning, so read this part carefully. Libraries can be seen as implicit base contracts of the contracts that use them. They will not be explicitly visible in the inheritance hierarchy, but calls to library functions look just like calls to functions of explicit base contracts, that is using qualified access like l.f. Of course, whereas the L is the library and F is the function inside. Of course, calls to internal functions use the internal calling conventions, which means that all internal types, what are the internal types? Your mapping, storage reference, etc., can be passed, and types stored in memory will be passed by reference and not copied. Basically, if I am calling some function of some other contract, and in that the reference type has the data location of memory, still first even then the copy operation is happening because I'm calling the external, some other contracts function. But for internal functions, as we know, that copy does not happen. It is actually passed by reference. So even in case of internal functions in your library, copy is not happening. By reference, it is getting passed. So, but how they do it? To realize this in the EVM, the code of the internal library functions that are called from a contract and all functions called from therein will at compile time be included in the calling contract, and a regular jump call will be used instead of a delegate call. And this is the difference. About public internal, let me also show that to you with the help of an example. This is the example that I have. Here I have declared this library named MEM. Inside I have two functions. One is this modify P for public I meant, and one is for modify I. Both are taking a dynamic array of data location type memory. The first function makes the first index element 3. I mean, the syntax is same, just that one is public and the other is internal, and of course the change of name identifier. So this is the library which I have. Fine. Now I have contract C. Inside I have a function, let's see, of visibility external pure. Now in this function, what I am doing, first I declare my memory array and define the first element to be 22. When I call modify P of this library function whose visibility is public, in this case the delegate call opcode is being used. We are using the delegate call opcode, and this array is actually getting copied. It is not passed by reference, but actual value is copied. So modifying the first element to 3 should not modify this element, and if I'm, and that also I'm checking later that my original value is indeed maintained. But if I'm calling this internal one, right, then this delegate call as such is also external message call. This delegate call opcode is not used. A direct jump is used, and therefore this is actually passed by reference, and it will modify this array indeed, and that is what I can check here also, that my this array is getting modified. So let me save it and let us run this. Okay, when I am calling this function, I should not see any revert, and I haven't seen that any revert. So this is working as I told, but then the doubt comes for memory data location. It is passed by value in case of public and passed by reference in case of internal, but then why in case of storage reference we are able to successfully pass by reference in both cases, either public or internal, as I will show in the examples too. Basically, if we read here, regarding this delegate call, creates a new subcontext as if calling itself, but with code of the given account. In particular, the storage, the current sender, and the current value remains the same. That is the message.sender, message.value, and the storage remains the same. Note that an account with no code will return success as true. So that is, so they are not talking about memory here, but about storage. That is the distinction which I understand to be the case. So if we move forward, reading, where were we? Yeah, here. We read this. Okay, note. The inheritance analogy breaks down when it comes to public functions. Calling a public library function with L.f results in an external call, delegate call to be precise. In contrast, A.f is an internal call when A is a base contract of the current contract. I mean, this is self-explanatory. They have given an example here which we can have a look because they are using storage reference for the public function. So let us see. They have their struct data type named data, which has this flags variable of type mapping an unsigned integer to a boolean. Alright. Then we have contract C, which is declaring a variable of that data type data with name known values, right? In that we have this function register, which takes an unsigned integer value. And first let us also see this set library. This is that set library which has this function insert, whose first parameter is the storage reference type named self. You can name it anything. And then the second parameter is this unsigned integer value. What it is checking whether that value exists inside or not. If it is already there, we are returning false. If it is not there, we are inserting it here, marking that yes, the value exists, and then returning true. So note that the first parameter is of storage reference, and thus only its storage address, not its content, is passed as part of the call, that is passed by reference. This is a special feature of library functions. It is automatic to call the first parameter self, usually better. You will see in practice that it is called self. If the function can be seen as a method of that object, this line, if the function can be seen as a method of that object, will become clear when we will see the using for. There is something known as using for, which we will see. Similarly, to remove it, you check. If it's already removed, you return false, else you remove it. This line is removing it, and then operation has successfully done, return true. Contains to check whether the value is present or not. Fine. This is that set library. Here we are calling that insert function, passing in my storage reference type, which is actually passed by reference. So here the public function is receiving your storage reference type. And with this, if we think about it, we have seen that your storage is your own. We have seen that only you can modify your storage. Some other contract cannot modify your storage, but libraries gives us a functionality where the calling contract's storage can be modified, right, by some other functions. Like here, this public function using delegate call, we are able to get our storage modified because we also sent our storage. So that is possible. The library functions can be called without a special instance of the library, since the instance will be the current contract. In this contract, we can also directly access known values.flags if we want, of course, because it is declared here. Next, they have this line. Of course, you do not have to follow this way to use libraries. They can also be used without defining struct data types. Obviously, functions also work without any storage reference type parameters, and they can have multiple storage reference parameters, and that too in any position. I hope it is clear. The calls to set.contains, set.insert, and set.remove are all compiled as calls delegate call to an external contract / library. If you use libraries, be aware that an actual external function call is performed. But as we saw, the message.sender and message.value, and this will retain their values in this call. Though prior to Homestead, a version of EVM, because of the use of call code, message.sender and message.value were different. They changed. Alright. Next, they have the following example shows how to use types stored in memory and internal function in libraries in order to implement custom types without the overhead of external function calls. So just like I have explained, in case of internal functions, we have this jump, we are not using the delegate call. I also wanted to share this answer which I saw in Stack Overflow about this function overhead which they are talking about. The way the function calls on a library are compiled is determined the visibility modifier. There are two ways. If you use public functions, you will have the external overhead, as the library will need to be deployed separately. In that case, your contract's bytecode must be linked to the library once it is deployed via delegate call, which we do. If you use internal functions, those will be compiled into the bytecode of the contract as we saw when we were reading this section, that to realize this in the EVM, the code of the internal library functions that are called from a contract and all functions called from therein will at compile time be included in the callings contract. Fine. And a regular jump will be used instead of delegate call. So that is what we see here. If you use internal functions, those will be compiled into the bytecode of a contract which uses the library. It behaves similar to inherited functions. That way your contract's bytecode will get bigger. So which visibility to use depends on your use case, right? So that is this answer. I found it good, so I wanted to share. And where were we? Yeah, we had this example. But first, let us understand this using for. The directive using A for B can be used to attach functions A as member functions to any type B. These functions will receive the object they are called on as their first parameter, like the self variable in Python. So if you know about this, about Python thing, you can relate to it. Otherwise also it is fine. So let us understand what we just read, this using for syntax. We have seen this example. We have thoroughly seen this example. We had this struct data having this flags variable of type mapping, and then this library had various functions: insert, remove, contains, and you can see that these functions are taking as the first parameter a storage reference type of type data, this struct, right? Fine. And this is what they had initially. Now what I have done, I have written using set for data, basically using this library for my data type of type data. I mean for this type we are using this, and what this has allowed me to do, instead of writing this set.insert etc., I can simply do non-values.insert value. Insert is expecting two arguments. First it itself, this non-value, second is this value. So what this has allowed me to do, that it will automatically pass the non-values as the first parameter. So let us formally look at about it further. We read this, continuing, it is valid either at file level or inside a contract, that is at contract level. The first part A here, this A part, we saw an example with library, but it can be further, other things also. This A can be one of a list of file level or library functions. So these functions, this F, G, H are file level functions most likely. Depends what is F, but this small symbol notation, most likely it is function, and this L dot T is a library function. So these functions are attached to this unsigned integer type. Only those functions mentioned here will be attached to the type. Fine. The name of the library, just like we saw, all functions, both public and internal ones of the library, are attached to the type. At file level, the second part, by the way, regarding this file level functions, we haven't talked about it. I will talk about it very soon, just after reading this. At file level, the second part B has to be an explicit type without data location specifier. Inside contracts, you can also use using L for star. So what this does, which has the effect that all functions of the library L are attached to all types. Fine. If you specify a library, all functions in the library are attached, even those where the type of the first parameter does not match the type of the object. See, the type is checked at the point the function is called. So here when you're doing using L for star, obviously, when we have written the function, even for the overloaded case, we still won't be covering every possible type. The function won't be written for the every possible type, but then this is allowed for the ease of accessibility on our end, and the type is checked not at the compile time, but at the time, at the time when the function is actually called and the function overload resolution is performed. Like in our example, if I do this using set for star and if I say comment out this line, then the code is successfully compiling. But as soon as I do x dot insert, since this insert method is not expecting the uint type, it is expecting a data storage reference type. So if I now save it, I get a compile time error. At the compile time itself, I'm getting the error, but when I'm actually invoking the incorrect function, the incorrect method. So when we read here, where was it? Let me find it. Yeah. The type is checked at the point the function is called and the function overload is performed as usual. So it is at the compile time only. Fine. If you use a list of functions like this, then the type uint has to be implicitly convertible to the first parameter of each of these functions. This check is performed even if none of these functions are called, as here we are explicitly specifying. Like, it's just not about explicit specifying, this is how it is. But in case for library, for instance, we use insert. Now this remove, if I have this, suppose it was something else, maybe uint, fine. Since the code definition is also something else, so I'm just going to say return true here, and it is compiling successfully. This is anyway, we have covered this. Now you see it is not giving me an error, even though this remove is not compatible. And if I do this, set this known values dot remove, you see I get the compile time error with the same reason that after basically it cannot find the suitable remove definition. The suitable remove definition will be the one where the first type will be data storage. Here that is not the case. So, but unsigned integer should work, right? So if I do this x dot remove, we are not getting the error. So in case of library, we have seen, in case we give individual, we have seen that the check is performed even if none of these functions are called. So here, if I were to do say individually, if I modify this like this, set.insert, set.remove, you see I'm getting the compile time error because this is not should not be unsigned integer but a data storage reference type. So if I do data storage and save, it is working as expected. And that star notation is valid only when we do this library thing. When we are using L4, then only we can use that asterisk sign. If I do that here, I get an error, right? Continuing, the using A for B directive is active only within the current scope, either the contract or the current module source unit, including within all of its functions, and has no effect outside of the contract or module in which it is used. I hope it is clear in itself. We will also see an example. When the directive is used at the file level and applied to a user defined type which was defined at file level in the same file, the word global can be added to the end. This will have the effect that the functions are attached to the type everywhere the type is available, including other fields, not only in the scope of using statement. So to understand this, let us look at this example. From here we will understand this global part also. But before I jump into this example, you notice this function is outside the contract. Similarly, this function, these are outside the contract itself. And these free functions is something which we have seen before in the same page itself. Like if I type here free, here it is where we covered free functions. We also noted that they must have internal visibility and we cannot also specify this internal keyword, just like for state reference variable we don't specify storage, and we can't even specify storage. Similarly, for these free functions we cannot specify the visibility, it must be internal. I mean, it will be internal. And we have seen all that their code is included in all contracts that call them, similar to internal library functions. Since they have internal visibility, they can also take those internal types like storage reference, and therefore your contract's storage can get modified by them. Actually, they were introduced to replace these internal library functions. Here in this contains function they are specifying the visibility, and this is the error on their part. I have raised a pull request, so hopefully it will be fixed. As an update, it is fixed with additions by Kamil. Kamil's contribution to this space has been immense, and he is also very helpful. So, knowing what are free functions, if we continue, we have them. These insert, remove, contains, and they are assigned to this data type of struct type, which is named data. I mean, this type we have seen. So almost similar, everything is same. Let me also clarify this global keyword. So this is their code which I have pasted here. Everything is same, just that I have added this keyword global in the end. Now in this get flags Solidity file which I have, I am importing it. Importing this file as flags. So flags.data known values, and now that insert method I can use here without issues. Whereas if this was not marked as global, this file is saving fine, but this if I save I get a error. So that is the use of global keyword as they have described. So with that, this example is done. Next, they have another example. There is nothing as such to learn. Basically, wait a second. They're just saying that with this way they can extend the built-in types. Basically, using this use for, as we saw, that we can have the method like this as a dot notation. So just like we have dot length, right, inside this array, similarly we can define our own functions to extend that built-in type. Here they have index of, and what this does, it determines the index in the array for which that element is equal to this what we have passed. So traversing through the length of the array, once we reach the hit, return that index. So that is simply what this index of function is doing, and the example in itself is very simple, so I don't think there will be any trouble in understanding it. Next, they have further clarified one point. Note that all external library calls are actual EVM function calls. This means that if you pass memory or value types, a copy will be performed even in case of the self variable. The only situation where no copy will be performed is when storage reference variables are used or when internal library functions are called. This I covered previously thoroughly. So with this, the using for section is complete. So moving back to the example, there is as such nothing to cover in this example because I have already showed you that in case you want to pass a memory reference, the function should be internal. As such, if you do pass a memory reference, then the value will be passed by value. A copy operation will occur, not the reference pointer. So use internal if you want that. So this example is just illustrating that they're able to extend their types, like this bigint library is used to extend the bigint type which they have declared here. So if you have a value of bigint type, they have added action these custom functionalities, this from unit and all these from unit, add, limb max, this support is added. This max function is internal to the library in the sense it is private, so we cannot call it. They are using max to in some of their function. In this add function they are using max. Yeah, so I mean, just to do some operations they have this function here. And what is this begint also, let me tell. In Solidity, as we know, the largest type for the unsigned integer is 256 bits, and we have seen its range also. But in case you want a larger number, an arbitrary larger number, or maybe a number say having 100 decimals, 100 digits and so on, in that case you should have your own type begint, and that is what the purpose here is. Some languages like Python have built-in support for arbitrary large numbers, but not here in Solidity. So you can simulate that big number using an array of integers, an array of unsigned integers. So that is what they are trying to implement here. So I'm not going over this example because as such there is nothing to cover concept wise. We have already seen the conceptual understanding. And now regarding this section, it's slightly technical and I don't see much point in going over it. So we are ignoring this section. You can read it if you want to go in detail, but I see it as a too much of technical detail, not much relevant. Now, in comparison to contracts, libraries are restricted in the following ways. They cannot have state variables, they cannot inherit or nor be inherited, they cannot receive ether, and they cannot be destroyed. This they cannot be destroyed we have already seen. Next, we have this section, function signatures and selectors in libraries. We have already seen, I mean, as such, for public functions, we cannot pass the internal types like storage reference, but for library it is possible. And therefore, while external calls to public or external library functions are possible, the calling convention for such calls is considered to be internal to Solidity and not the same as specified for the regular contract ABI. Because if we continue reading, external library functions support more argument types than external contract functions. For example, recursive structs and storage pointers. For that reason, the function signature used to compute 4-byte selector are computed following an internal naming schema, and arguments of type not supported in the contract ABI use an internal encoding. And what is that encoding? Again, I don't see much point that we delve too much deep into that. But if we continue reading, the argument encoding is the same as for regular contract ABI except for storage pointers, which are encoded as a U in 256 value referring to the storage slot to where they point. And in case you want to see the final first 4 bytes, similar to the contract ABI, the selector consists of first 4 bytes of the catcheck 256 hash of the signature. Its value can be obtained from Solidity using the dot selector member as follows, and this is the example for that. This library L has an external function f, and this function g in the contract C can, using this we can find the signature, this catcheck 256 hash of the signature, the first 4 bytes using this selector keyword. So I hope this part is clear. And with this we have covered the libraries. Now when we were covering the type section in Solidity, I left this delegate call part. So now since we understand it, let us also look what they have mentioned here. Regarding this delegate call, it issues the low-level delegate call opcode in the EVM with the given payload, returns success condition and return data, forwards all available gas, which is so adjustable. And if we look here, in a similar way, the function delegate call can be used. The difference is that only the code of the given address is used. All other aspects, storage, balance, are taken from the current contract. The purpose of delegate call is to use library code which is stored in another contract. The user has to ensure that the layout of storage in both contracts is suitable for delegate call to be used. Basically, the function which you are calling give that storage pointer etc which you the type should match what you are calling that upon. We have seen all that. So this is clear. And regarding this adjustable, that you can tell which gas you can send, like the way we saw here, right? So with this way, that part in the type section we have done. Now let us also cover this function types in the type section which we initially left. But now since we understand various concepts, this will become easy to understand. Basically, in Solidity, the functions have first class support. Just like how an unsigned integer has a first class support in the sense you can assign it to some variables pass as a function argument and get a return value also. An unsigned integer can be returned from a function. Similarly, functions are also having this first class support in the sense you can pass functions themselves as an argument to some another function, and that another function can also return a function to the caller, so on. So and the function you can also assign it to some variable. So functions have first class support in Solidity. And if we read the documentation, function types are the types of the functions. Basically, when you declare a variable, you mention the type also, right? So in case you are declaring a variable which should hold a function inside it, so you should give the type. What is the type of that function? So that is the function types. Variables of function types can be assigned from functions, and function parameter of function type can be used to pass functions to and return functions from function calls. I have explained this. Function types comes in two flavors: internal and external functions. Internal functions can only be called inside the current contract, more specifically inside the current code unit, which also includes internal library functions and inherited functions. Because they cannot be executed outside of the context of the current contract, calling an internal function is realized by jumping to its entry label, just like when calling a function of the current contract internally. I hope this is clear in itself. We have seen thoroughly about all this. External functions consist of an address and a function signature, and they can be passed via and returned from external function calls. When we will look at the examples, then it will become very clear. But first, let us also read the theory part. Function types are noted as follow. You use the keyword function, then you give the parameter types, the input parameters which the function is taking. You specify the visibility, it is internal or external. Then you specify all this pure, view, payable, mutability, and then you type return types. In case the function is not returning anything, you ignore this square bracket part. We will see that. In contrast to the parameter types, the return types cannot be empty. In case your function is not taking any input parameter, you simply don't put this part which I have highlighted. But in case your function is not returning anything, you don't just put empty here, you delete this whole part, the returns keyword itself. So the return types cannot be empty. If the function type should not return anything, the whole returns part has to be omitted. By default, function types are internal. So if you don't mention, by default it will be internal, the function type. So the internal keyword can be omitted. Note that this only applies to function types. Visibility has to be specified explicitly for functions defined in contracts. They do not have a default. We have seen that already. Moving on, this conversions part is there. A function type A is implicitly convertible to a function type B, just like how a uint 8 is implicitly convertible to uint 16, right? Because no semantics is lost. So here also we have this implicit conversions. But if and only if their parameter types are identical, their return types are identical, their internal external property is identical, and the state mutability of A is more restrictive than the state mutability of B. In particular, pure functions can be converted to view because pure function is view also, right? But view need not be pure, so that's why. And non-payable function similarly, because pure function is non-payable too. View functions can be converted to non-payable by the same logic. Payable can be converted to non-payable functions because if you pay attention to a payable function, I can pay nothing. I can send a zero amount, right? So in that sense, it is non-payable too. They have also explained it further in case the explanation is not yet clear. No other conversions between function types are possible. The rule about payable and non-payable might be a little confusing, but in essence, if a function is payable, this means that it also accepts a payment of 0 ether. So it is also non-payable. On the other hand, a non-payable function will reject any ether sent to it. So non-payable functions cannot be converted to payable functions. I hope this is clear. Moving on. If a function type variable is not initialized, calling it results in a panic error. Okay. The same happens if you call a function after using delete on it. Fine. If external function types are used outside of the context of Solidity, they are treated as the function type which encodes the address followed by the function identifier together in a single bytes 24 type. Now, before I explain this, let us first have a look at a simple example regarding this external function types. We have this contract oracle. They have declared their type, a struct type named request, having these fields. One of the field is this external function type. I mean this variable of external function type, right? Now we have this dynamic array of this request type named requests. This query method is there. What it does, it pushes inside this state variable request a request type having this data as the what is given in the input, and the function, you see the external function here is passed as an argument, and that is pushed, that is inserted as this request type here inside this array, and then they are emitting this event that we have this event is their new request, and then they are emitting this event with the request number. Fine. And then this reply method is there. So for the given array index, the request id which starts from 0, you call this function which we passed with the given response, as this function is taking an unsigned integer as an input. And they have this comment, here goes the check that the reply comes from a trusted source. So let us see how they are using it. We have this contract named oracle user. Inside this contract of the type oracle contract, we are giving the value address. They would have already deployed this contract, so they know the address, and from there they are initializing this variable, so a known contract. Then they have their private variable, private state variable named exchange rate. So the idea here is clear that they need to know the price of an asset from an oracle. So oracle will tell the price. How? This function buy something is there which will query the price for say USD and send the function this oracle response function, which will take the input response and assign this state variable value to that response what is being sent, and they are checking that message.sender is equals to address oracle constant. The contract type is here, so they are computing its address. So only oracle can call this function. This function can be called by the oracle itself, so oracle is the one with the authority to give this input value, because it is calling this function, right? So whenever the oracle has the reply with it, it is going to send that response to this function. So that is the idea, and in this way you can see how we use an external function. Speaking of external functions, external or public functions have the following members: the address, which returns the address of the contract of the function, okay, and the selector, which returns the API function selector. Now this line as such had nothing to do with the example we just saw, but my motive was to not give so many things at once. So once we have seen external functions, how we usually use it, this is explained here with regard to the ABI. Like if we look at the contract ABI specification, let us also quickly read it. The contract application binary interface is the standard way to interact with contracts in the Ethereum ecosystem, both from outside the blockchain and for contract to contract interaction. Like we use the low level calls function, right? That dot call, dot static call, etc. Data is encoded according to its type as described in this specification. The encoding is not self describing and thus requires a schema in order to decode it. We assume the interface functions of a contract are strongly typed, known at compile time and static. We assume that all contracts will have the interface definitions of any contracts that call available at compile time. This specification does not address contracts whose interface is dynamic or otherwise known only at runtime. So function selector we saw thoroughly. If we just give a quick read also, the first 4 bytes of the call data for a function call specifies the function to be called. It is the first left, that is the first 4 bytes in the left, from the leftwards if we see, or higher order bytes in case you are looking from the viewpoint of big Indian. As such, if you don't know big Indian, you understand higher order bits, right? I explained you, so same thing. I mean similar. 4 bytes of the Kechek 256 hash of the signature of the function. We saw this. This signature is defined as the canonical expression of the basic prototype without data location specifier, so called data memory you don't give. That is the function name with a parenthesized list of parameter types. Parameter types are split by a single comma, no space is used. The return type of a function is not part of this signature. In Solidity's function overloading, return types are not considered, as we have already seen. The reason is to keep function call resolution context independent. The JSON description, however, contains both inputs and the output. In the remix, when we compile the contract, we can see the JSON description. And the JSON description is also given in the same file. It's 2 down, I guess. Yeah, here it is, JSON description. You can also give a reading to it yourself. I would suggest that you give it. This will explain that what all fields we have in that JSON file, right? Going back to where were we? Yeah, argument encoding. Starting from the 5th byte, as the first 4 bytes are taken, the encoded arguments follow. This encoding is also used in other places, example the return values, and also event arguments are encoded in the same way, without the 4 bytes specifying the function. Now you can read about all these types what the ABI has. ABI also has this function type. This is to be noted here, which is an address followed by a function selector 4 bytes encoded identical to bytes 24. So when they are saying this, which encodes bytes 24, I hope this is clear. Now, if the external function types are used outside of the contracts context, they are treated as the function type, as we saw in that API. And I also came across a good example which will make this crystal clear. Ismail has done significant contribution in this community. If you look at this person's question, he's having trouble encoding this ABI. If you look at this, they have this function foo, which is taking the callback function here. This is the function, just like the example which I showed you. Similarly, they have this function here, okay, which is taking these arguments. The name is callback, visibility external, so on. Now, if some other contract, this contract say, want to call this function foo of contract B, one way we know. But if we want to use this low level call, like this person intends to do, then what you will think? You will find the signature and so on, right? So what he was doing, and this is important to see what he was doing. He was encoding like this when calling the function. encode with signature. First is the signature and then all these things. So the signature he mentioned was this. The first, which was bytes 32, this one. We don't specify the data location. The second function, he wrote like this. He or she, whosoever. Fine. And then the arguments. But the issue is, we did not see this in that ABI. What we saw was just function. And that is where the issue was. And that is what Ismail replied. Where is it? Yeah. Yeah. Replaced all those, the parenthesis part is removed, just the function keyword has to be given. And if you, so that was the issue. If you want to read, you can read this entire question and answer. Just search for this in the Ethereum.stack exchange. But I hope with this part is clear. Moving on, note that public functions of the current contract can be used both as an internal and as an external function. How? To use f as an internal function, just use f like that. If you want to use its external form, use this .f. We have seen this multiple times. A function of an internal type can be assigned to a variable of an internal function type regardless of where it is defined. This includes private, internal, and public functions of both contracts and libraries as well as free functions. External function types, on the other hand, are only compatible with public and external contract functions. Libraries are excluded because they require a delegate call and use a different ABI convention for their selectors, which we know. Functions declared in interfaces do not have definitions, so pointing at them does not make sense either. I hope this is clear. Members we already saw, and they have this example just to illustrate this member selector. Fine. Next, we have an example that shows how to use internal function types. So we have this library named array utils. So it's a utility functions for array. We have this map function, and what it does, it is an internal type. So this memory reference type will be passed as reference. There won't be a copy operation. And this other type which is taking is a function variable of type function named f. So this function type is taking an unsigned integer as an input, is a pure, and returns an unsigned integer. So what they are doing, they are returning a new array, and this is the length taken from here, and for all the elements which are present in that array, they are computing this function f for them and assigning the output to this array. If you have experience with functional programming, say standard ML or Haskell, such things are common. This map, etc., reduce is also there. Similarly, for this reduce, if you look carefully, this is also internal, so this will be passed as reference. Again, a function type is given which is taking two inputs, this time both unsigned integer, and returns an unsigned integer. What it is doing, takes the first element, so this in turn is assuming that this is not empty, and then for all the remaining elements you compute this function and assign it to r. So r is getting updated each time. So I hope this reduce is clear as such. Range, this function gives me a new array of the given length where each element value is its index. So this is what it is. Next we have this pyramid contract in which we are using this library for all types. We have this pyramid function which will take the length input, and what it is doing, so first this will help find a new array of the given length where each element is its index, right? So this part has now returned me an array in memory. To this array, since I have attached my library functions, I have this map function available. To this map function I am passing this square function, and what this square function is doing, it will simply return the square of the array element. So each array element will get modified to its square now. Therefore we are mapping each element to its square. This is what this part has done till now. To this we are doing this reduce function, which is taking the sum function as the input. What is this sum function? Simply find the sum of two values. So what this is going to reduce my array to a single unsigned integer, which will have the sum of all the array elements. As we see, returning an unsigned integer here, so it is computing this sum for all the array elements. So with this we have seen an example of internal function types being used, and we have already seen this external function types example. So with this the function types part is completed. Alright, we are almost done with Solidity. Let me also cover some fringe topics. One is this Natspec format. Solidity contracts can use a special form of comments to provide rich documentation for functions, return variables, and more. This special form is named the Ethereum Natural Language Specification Format, that is Natspec. Natspec was inspired by Doxygen, you can read about it if you want. While it uses Doxygen style comments and tags, there is no intention to keep strict compatibility with Doxygen. The supported tags are given below, which we will see. This documentation is segmented into developer focused messages and end user facing messages. So when you are writing the documentation, you have the choice about which of the part is for the end user and which part is for the developers. We will see with the examples. These messages may be shown to the end user, that is the human, at the time they will interact with the contract, that is sign a transaction. It is recommended that Solidity contracts are fully annotated using Natspec for all public interfaces, that is everything in the ABI. Natspec includes the formatting for comments that the smart contract author will use and which are understood by the Solidity compiler. Yes, when you are writing Natspec comments, you will see Solidity compiler responding to them. If, for instance, you have put some incorrect tags, Solidity compiler would see the Natspec comments and parse them accordingly, just like we had our SPDX license identifier. Also detailed below is output of the Solidity compiler, which we will see the files it generates, which extracts these comments into a machine readable format. Natspec may also include annotations used by third-party tools. These are most likely accomplished via custom name. You can declare your custom tag with this syntax, either custom a colon and the name of your custom tag. And a good use case is analysis and verification tools. Now, just like how we had the SPDX license identifier, it was not included in the bytecode but was present in the metadata. Yeah, our license was present in the metadata, but the bytecode contained the metadata hash. Similar is the case for the Natspec comments. They are included in the metadata. So documentation example. Documentation is inserted above each contract, interface, library, function, and event using the Doxygen notation format. A public state variable is equivalent to a function for the purpose of the Natspec. For Solidity, you may choose these 3 forward slashes for single line Natspec comment, and for the multi-line Natspec comments, you can use this. You can use this for each of your line again and again as a multi-line comment, which we will see. Viper thing we need not focus. Viper is another high-level language like Solidity, though not presently used much. The following example shows a contract and a function using all available tags. The Solidity compiler only interprets tags if they are external or public, that is function. You are welcome to use similar comments for your internal and private functions, but those will not be parsed. This may change in future. So they have this example right here. These two lines are common, which we know the meaning. Now for this contract named tree, they have this Natspec comment here, and the tags which they are using, the first one is @title. What is its meaning? So @title, a title that should describe the contract interface. So it is used for contract library and interface. So the description of the contract is that it is a simulator of trees data structure. And the author, you can understand the meaning of author, the name of the author used for contract library interface. So the author is this person. And then @notice is for the end user, explains to an end user what this does, and this is used for all these things. So to the end user, you can use this contract for only the most basic simulation. Then @dev for the developers, all function calls are currently implemented without side effects. Then they have their own custom tag named experimental, which, and the description is this is an experimental contract. So what is this contract tree contains? It contains, as we can see, the two functions age and leaves. So what this leaves does, so @notice, so for the end user, returns the amount of leaves the tree has, and @dev returns only a fixed number. So this is fine. Then for the age, calculate the tree age in years, rounded up for live trees. And @dev, the Alexander N. T tiering algorithm could increase precision. So yeah, this message is for the developers. Then @param. Now we have this input parameter this function is taking named rings. So we have written @param like this. And I also showed you another example where we had multiple parameters. I think it was in case of events that I showed you. And so for each parameter you will have its own line. So in case there was some another parameter named whatever, suppose circles, then you will have one more line @param circles, then the description. So for this rings, the number of rings from some word sample, then return for what this function is returning. Again, just like parameters, you will have multiple lines for multiple returns. So return age in years rounded up for partial years. Similar is for this. We need not see the remaining part. There is also this inherit, and we will see that tags. So all tags are optional. Yeah, we are here only. All tags are optional. The following table explains the purpose of each Natspec tag and where it may be used. As a special case, if no tags are used, then the Solidity compiler will interpret the 3 forward slashes or your multi-line in the same way as if you were using @notice tag. So we have all this description. So @dev explains to a developer any extra details. Param documents a parameter just like the oxygen must be followed by a parameter name. Return documents the return variables of a contract's function. Then inherit doc copies all missing tags from the base function, must be followed by the contract's name. And then @custom, the custom tag semantics is application defined. This inherit doc, but first let us read this. If your function returns multiple values like int, quotient, int remainder, then use multiple return statements in the same format as the param statements. Custom tags start with custom colon and must be followed by one or more lowercase letters or hyphens. It cannot start with a hyphen, however. They can be used everywhere and are part of the developer documentation. And regarding this inherit doc, if you see here, they had this inherit doc tree. So first of all, this has no tag, so that means @notice returns the amount of leaves that this special kind of tree has. And if you notice, this leaves function is inside this contract, the kumquat tree, which is inheriting from this tree contract. So what they want, that this leaves function should inherit these tags from the tree contract. So that is what this line is helping them achieve. But it will inherit only the missing tags. So in our case, we had this notice tag return the amount of leaves that this special kind of tree has. And notice there is some difference in this notice and this notice. We have this special kind words. So what this tree will have ultimately one notice tag, which is this, and one dev tag, because only the missing tags. So if you read here, copies all missing tags from the base function must be followed by contract's name. And if I also paste their contract, what they have in that example here, so for this leaves we as such have two tags, and if we notice that also, one is this, for this leaves we had this, and you can notice this special kind, so it is not that notice tag but the updated one. And also regarding that dev, so that is also there, returns only a fixed number. Inside dev doc we will read about this also, so let us read about that also. Dynamic expressions. The Solidity compiler will pass through Natspec documentation from your Solidity source code to the JSON output as described in this guide. The consumer of this JSON output, for example the end user client software, may present this to the end user directly, or it may apply some pre-processing, like for example some client software will render this @notice tag which says this function will multiply in colons this a by 7 to end user as this function will multiply 10 by 7 if a function is being called and the input a is assigned a value 10. So I hope this is clear. Specifying these dynamic expressions is outside the scope of the Solidity documentation, and you may read more at the Natspec project, so it's up to you. Now regarding inheritance nodes, functions without Natspec will automatically inherit the documentation of their base function. Exceptions to this are when the parameter names are different, when there is more than one base function, when there is an explicit inherit doc tag which specifies which contract should be used to inherit. I hope this is self-explanatory and is clear. Now regarding the documentation output which we just saw inside Remix, when passed by the compiler, documentation such as the one from the above example will produce two different JSON files. One is meant to be consumed by the end user as a notice when a function is executed, and the other to be used by the developer. So they are showing how to get that output for their using the Solc compiler, and you can see that. But as such, they are producing two outputs, the user doc, the dev doc. But as such in Remix, we saw that in the metadata, when we say we have both our dev doc and the user doc, and they have this note also. Starting the Solidity version 0.6.11, the Natspec output will also contain a version and a kind field. Currently, the version is set to 1 and kind must be one of user and dev. In future, it is possible that new versions will be introduced, deprecating the older ones. So yeah. And regarding the outputs, one is this user documentation. The above documentation will produce the following user documentation JSON file as output, which we have seen how the user doc looks like. We have this here, user doc, and note that the key by which to find the methods is the function's canonical signature as defined in the contract API, and not simply the function's name. Next, the developer documentation. Apart from the user documentation, a developer documentation JSON file should also be produced and should look like this for their example. So I hope with this the Natspec comments part is clear. Next, I want you to be aware about this units and global variables page, which is here. Although we have seen some part of it, at times you may need to refer it. I will not be going through the complete page, but you can refer here in case you would like to use or need more details about, say, message or sender of the message current call. So You can see all that, but some part I will do. Ether units. A literal number can take a suffix of v, gui, or ether to specify a subdenomination of ether. We saw the subdenomination chart at the very beginning of the course, where ether numbers without a postfix are assumed to be v. So 1v is equals to 1. 1 gui is equals to 1e9, that is 10 to the power 9, and 1 ether is 10 to the power 18. So the only effect of the subdenomination suffix is multiplication by a power of 10. So that is fine about these units. So by the way, we saw something known as state variables, and I told you the variables that you are using defining other than the state variables are the local variables. The third class is this global variables, which are available beyond the contract. So these as such above the file level, also the global available variables, which we saw this v, gui, ether. Some more. This time units suffixes like seconds, minutes, hours, days, and weeks after literal numbers can be used to specify units of time with their own caveats, as we will see. Where seconds are the base unit, so 1 is equals to 1 seconds, and units are considered naively in the following way. So as they've written naively. Take care if you perform calendar calculation using these units, because not every year equals to 365 days. We know this for a fact. And not even every day has 24 hours because of leap seconds. Due to the fact that leap seconds cannot be predicted, an exact calendar library has to be updated by an external oracle. So this part is what I wanted to cover regarding these global variables, and you can refer to it later for more info. Now let us look at this site, damnvulnerabledefi.xyz. As I would have told in the introduction, we will be doing the first 10 problems, and surprisingly, this is the new problem which the author has put. I also have not done this yet. Now, how to play this game? First of all, if you click on the challenges, you will see their description. What is the challenge about? And now, how to play? You need to clone this repository. So let me do that. In case you don't know how to clone the repository, kindly search it in the net. So this is how I cloned that. So I'm going to clone this repository now. Let's wait for it to finish. Alright, now it has finished, and I do see it being present here. There is one more thing. Check out the latest version with git checkout version 2.1.0. When I did this, it was 2.0.0, since they had this new junior miners also present. So 2.1.0. So let me copy that and go here and paste this. Oh wait, I need to first shift now here. Okay, we now have shifted to that, and I can see that also being shown in my terminal. Install the dependencies with yarn. Now in case you look, they have this yarn.lock. You might not know about what are these lock files. So this is JavaScript related thing. If it was when we started using Hardhat, we used npm, right? In case of that, we will have the log files corresponding to that npm package log, but they have used yarn here, and therefore we have yarn.log files. What exactly is this log file? Maybe the gist I can give you is that to fix the dependencies, I mean, you might have written your program with some dependencies versions in mind, so that there is no change in that. We have these log files. You can just YouTube search about this. It is not, I mean, it's JavaScript related thing, node related, I mean, this package management related thing, not part of our course. And how to get yarn? Since you already have npm, you need to do this core pack enable. since you would have used the latest version of Node. So this should give you the access to yarn. Now regarding damnvulnerabledefi, install dependencies with this command yarn. So let me do that. I'm gonna put yarn here. So it's gonna install all these dependencies. So I'll resume the video once it's done. Now the installation is complete. So let me open this on my editor, this folder. I'm using Visual Studio Code. You can use whatever editor you are comfortable with. Alright, we see various folders, contracts, tests, etc. So let us go over these challenges one by one. The very first challenge being unstoppable. So let us do that now. And regarding this yarn npm, it's a matter of your preference. Just like we have different editors, similarly we have different package managers. Yarn is also famous, npm node is also famous. So yeah, now doing this unstoppable. So inside this test folder, when I open this unstoppable.challenge.js, this is one file which we have to see. And inside this contracts folder, regarding this unstoppable, these are the two other files of interest. Also, let us first see the description of what this is about, this unstoppable. So if I click here, there is a lending pool with a million DVT tokens. So a token named DVT, that lending pool has million of those in balance, offering flash loans. I will explain what is flash loans for free. If only there was a way to attack and stop the pool from offering flash loans. You start with 100 DVT tokens in balance. So let me talk about this flash loans now. What is flash loan? Basically, it's a loan which you get just for a flash, right? Suppose you have a function inside your contract. Inside that function, you borrow some DVT tokens from this lending pool, and then you do some operations, and at the very end, after doing your operations, you return what you borrowed to the pool back with some fees usually, but here it is free. So you just need to give back your initial amount and you will be good. And then your function execution will finish after doing whatever steps additional that you may plan. So in this function, you borrowed money, you did some operations, and you gave back the money back to the pool. And this is what is called as flash loan, because it was available only for that function's life which you got, right? Usually when we take a loan, we must return it in the same transaction back. So in case in this function of your contracts function which you had, when you will invoking it, that is a single transaction, and within that function you might do multiple calls that is part of that same transaction, and ultimately you have given the funds back to the pool. We will see the example when doing this program itself, so that will make it more clear. And so you have to stop the pool from offering flash loans, and you start with 100 DVT tokens in balance. So let us now try to understand these files. So yeah, Pragma, Solidity, SPDX license identifier, they are importing these two files. One is for the ERC20 tokens. Basically, as you might be aware also, in Ethereum we have seen many tokens, and it's better for them to follow this standard. There is this standard known as ERC20. We expect tokens to follow that, and regarding this we will see later. We also have this re-entrancy guard. I haven't talked about re-entrancy as such, and if you see, the contract is inheriting from this re-entrancy guard and using this modifier non-reentrant, which is defined in this file. In this re-entrancy guard, they have this modifier here, you can see that. So let me first explain about reentrancy. Here I have created the contracts. One is this pool.sol. This I took in from this. In Ethernaut, there is this level. Ethernaut is just like damnvulnerabledefi, although there are good number of differences. One of the main difference being that it is not updated. It's still using the older versions, these Ethernaut challenges. So I took this example from there, but I have done suitable modifications which are needed due to the latest versions. I mean, one of the difference being they are using this library known as safe math, but as we have seen the arithmetic, there is something like checked environment and the unchecked environment. So we don't need safe math library now. So let me try to explain reentrancy using this. We have this contract reentrance. Ignore this import as of now. There is this balances and we have constructor which is nothing, but to this constructor I have given this payable keyword, and what this will allow me, it will allow me to deploy this contract with some ether balance. So this contract will also be having some balances inside it. Then they have this donate function where somebody can donate ether to it. So this is payable and somebody can send ether to it, which is signified in this message.value, and that message.value is added to that addresses balances. So they have this state variable balances, which is a mapping type. So to a particular address they are keeping the check how much ether that entity has deposited. So this is this donate part. Then this balance of it will simply return the balances of a particular address. So fine. Then we have this withdraw function. By the way, this my balance function will simply return the balance of this address. Now this withdraw function is there. Person after having deposited some amount can also withdraw it later. So they will check if the amount the entity is asking to withdraw, is it justified? I mean, whether has he or she or entity whatever deposited that much amount before. So balances this should be greater than the amount asked to withdraw. So in that is the case, ignore this console part. They are doing this low level call. Since nothing is provided, the receive or payable fallback function will be executed, and with the value, how much value, so they are actually sending back the amount which the person is asking to withdraw, and we are requiring that yes, it's successfully done, otherwise the transfer failed, and then they're decrementing the balances amount. Okay, you might have noticed that I have made it integer, not an unsigned integer, and I will tell you the reason for that. Then they have this receive function if somebody wants to send some ether to it. Regarding this console.log part, basically it will, once if the execution reaches this point and once this line gets executed in the terminal, I will see this I am inside. So when I'm going to run this, it will become clear. Now the issue is when the person is calling this, the receive function, you see that receive function can again call this withdraw function of this contract, right? That receive function can again call withdraw of this amount, and again it will be able to get to this point because we have not updated this yet. This is updated later, but it's not updated yet. So this value will be still the same, the initial value. Suppose the user is depositing 1 ether, it has deposited 1 ether, so balance 2 will become 1 ether. Now deposit, so now it is withdrawing say 1 ether. Since 1 ether here is greater than equal to 1 ether here, we will come inside, then we are calling the receive function, and when we are inside this receive function, this whole contract's balance has decreased by 1 ether, but this state variable has not been updated. That receive function can again call withdraw function here to say withdraw 1 ether again. And since this is again 1 ether, we will be able to come here inside again, and again this contract will send 1 ether to that receive part. So and so we can keep on doing it until this balance is exhausted. So I have written this attacker file. Here this attacker contract is there. First, since I want to call the functions of pool, I have declared this interface donate and withdraw functions, and in the constructor I will give the address of this deployed contract, which will get initialized here. Then this my balance, just a utility function for my sake to see the address balance. And then this attack function is there. What this attack function will do, it will first donate to this pool 1 ether so that this state variable is updated. Then it will withdraw 1 ether. Once this withdraw function is called, inside it they are calling this empty call data. So we will come in this receive part. In receive part, I am just printing what is the pool balance now, and we are checking that if the pool balance is greater than equal to 1 ether, so that this contract still has some money to exploit, the attacker will withdraw 1 ether again, and that is what the attack is, and this is what the reentrancy is. So let me also deploy this to show you whether it's working right or not. So to this reentrancy contract, I'm going to deploy this with say 10 ether. So I have now deployed it. So now my balance, you can see it has 10 ether. I have created this my balance function which I called. Now in case you want to send ether to this pool, either there is this donate function. I told you while deploying also we can have ether in it if the constructor is marked as payable. Other method is you can simply use this receive part. So how do you do that? Let me also tell you. Suppose I am depositing say 2 ether, then I will have my message.value set as 2, call data is empty, and then I'm going to click this transact. Now if I do this and now check the my balance, it should be 12 ether, which it is 12 ether, right? So I hope that part is clear. Now for this attacker, let us deploy this attacker. It needs the address of the pool, so I'm going to copy the address of the pool here, paste that here, and going to deploy it. Now this attacker is deployed. What is the attacker's balance? Currently nothing. So I'm going to deposit 1 ether here using this attack function, which I have marked as payable. The thing is, you cannot do that empty call data thing here because the receive function is not the usual receive. It is using this attack. The attack vector is inside this receive part, so you don't put value in this attacker contract via the empty call data, but you can of course mark any function as payable and then give ether. So I'm going to give ether to this attack function. So I'm going to put 1 ether here, and then I'm going to call this attack function. When I'm going to call this attack function, from this the console.log part will also become clear. So it is running, and I have a revert. The transfer failed. Let me see what is the issue. So I have no idea why did remix fail that time. Even if I try to run it again, I'm seeing some issues with my transaction getting pending, so on. So personally, I don't see any issue, and when I'm running the same contract, you can see everything is same. This is the attacker contract, and the pool contract is also same, just that I have added one more line here. I mean, even if I comment this line out, it won't make a difference. It just I'm also logging to the terminal the balances part each time it is getting updated. So these two contracts are same, and if I look at my script which I just wrote, so await ethers.getSigners, we have seen what does getSigners return. So one is my deployer, which is by default attached when we do this get contract factory, etc. And the second one is attacker. So first I am deploying my this contract, this reentrance contract here, and since in the constructor As it is payable, I'm also sending 10 ether value while I'm constructing it, so that I can illustrate the exploit, right? So that is how you do. You put, if you want to send value, you send in the curly braces like that, putting value, and then this is a library function which is helping me put 10 ethers. Basically, I have opened few links to explain this. We are using the ethers.js inbuilt is using big numbers library, their own library. The way why can't I just use numbers? So let us first read this. Why can't we just put 10 to the power 18 when sending the value, because 1 ether is 10 to the power 18 V, the smallest unit in EVM, the Ethereum. The first problem many encounter when dealing with Ethereum is the concept of numbers. Most common currencies are broken down with very little granularity. For example, there are only 100 cents in a single dollar. However, there are 10 to the power 18 V in a single ether. JavaScript uses this standard IEEE 754 double precision binary floating point standard numbers to represent numeric values. As a result, there are holes in the integer set after this big number. So 3, 6, 9, 12, 15. So 9 into 10 to the power 15 roughly. But 1 Ethereum is 10 to the power 18. And just like how we have uint 256 in Solidity as the biggest type, JavaScript has this. So, but we need we need to store bigger numbers, right? And so, such small support is problematic for Ethereum because that is only around 0.009 Ether in V, which means any value over that will begin to experience rounding errors. So, to counter that, they have their own library, big numbers, which you will see when working with Hardhat. Many times you will come across their big numbers syntax. I mean, big numbers will be shown because that is what they're using inbuilt. And there are other utility functions which the ethers library is providing to us. So if I use this ethers.utils.parse units, then it will return me that big number. So I can give the value, and by default the unit is ether. In case you plan to use unit and ether as, then you better use parse ether. But for the other units which exist, and we have seen many different units before, you can just put in the value and tell what unit it is. Like they have example ether, Gwei, and so on. And this is how you will see, like as a big number. Fine. Similarly, you can display also. Here I'm using as the input, and in case you want to display the big numbers, like here they have this format units to which you give your big number as the input, and you also specify what unit you want to parse it with. So in case my big number is 9 ether, so in the internal representation it will be 9 followed by 18 zeros, and I want to, if I put here that parse units, that big number comma ether instead of GUI, if it was marked as ether, then the output should be 9.0. And you can see these examples to get more sense out of it. Also, I have opened this section, this big number section, and you can see they have different methods to add to big numbers, to subtract, to multiply, divide, and so on. You can also do this comparison operators, equal, etc. Then you can also get a string representation of that big number if you want to like print it, so that time it could be useful. Now moving back, here I'm simply putting that big number having the value 10 ether in the constructor part while we are deploying our pool contract. So this part I hope is cleared. We have seen what it means. Now what I'm doing, I did two things when I was showing the example. First I put 10 ether here, and then I sent 2 ether with that empty call data. So that is what I'm simulating here. I send my transaction to this pool address with this value 2 ether, and I'm just waiting for it to get mined successfully. Once that is done, I'm also deploying my attractor contract. This time I'm also sending the signer. By default the signer is deployer, but since I have mentioned attacker here, so this contract will be deployed by the contractor, I mean the attacker, and I am deploying it by sending the pool address, as its constructor requires the pool address here. So that is what this part is doing, waiting for it to get deployed. Now I'm invoking its attack function by also sending, as the attack function is payable, I can send ether to it. Here it is, payable keyword, and so I'm sending 1 ether to it, and then the all that will go as I have explained. So let me now run this. Now I'm going to run this script. Here the script is running, and now if I try to explain this, also this import hardhat console.sol, hardhat provides us this feature to print something in the terminal, and it is also integrated to Remix, and that is why I was able to import this in Remix also. Now this has allowed me to print something to the console, and I am printing here 2 times. Whenever I am inside this if block, I am saying that I am inside. Secondly, just like .log method is there, there is also log int to log the integers. You can read more about these functions console.log in the Hardhat documentation. Here I am in the documentation of Hardhat, and you can read about this console.log here. You can call console.log with up to 4 parameters in any order of the following types: uint, string, bool, address. So that is what these types I can use in console.log, but I was printing an integer, so for that I need this logint. You can also print bytes 1, 2, 3. There is also log bytes. So all these methods are there, you can read about them. So once I'm inside here, I'm calling that receive function of the attacker contract here. In that, I'm printing the pool's balance. Pool balance was 12, but I deposited here 1, so it became 13. From 13 I'm withdrawing, and now it is sending me 1 ether here. So the first time it is going to print 13 minus 1, 12. So it will print 12 the very first time. And it is what it is doing. I am inside and printing the 12 ether. Fine. Then I'm calling this again pool.withdraw, so on. So again we are here to withdraw the amount. This is not updated, so it is again 1 ether. 1 ether is greater than equal to 1 ether. So again inside, again it is going to do the call, and so on, so on, so on, until the pool balance finally becomes 0. Then that if condition here in the attacker won't be executed. Fine. And at that point we will come here, and this is where I am making balances. Since the balance was 1 ether, so 1 ether minus 1 ether will make it 0. Fine. And once the balance is 0, and when I'm printing this login, this state variable's value, I'm getting 0 here. And so then that receive function, since it's a recursive receive function, I hope you're able to see, we will again come back here for that recursive receive function. Since this will pass, then to 0, we are decrementing 0 by 1 ether, so we will have minus 1 ether. And that is the reason why I took this type to be integer, not an unsigned integer, because with unsigned integer I wasn't able to illustrate the reentrancy exploit in this example, because in the checked environment, making an unsigned integer negative would return the revert, so this result will become false and I will get the error. So this is the reason I took int here, and so on. Finally minus 12. The attacker's balance now is 13 ethers. We started with 1, 12 it stole, so now in total 13. So this is the reentrancy exploit. Now here, if instead of doing this effect, updating my state variable after the call, if I would have done it before the call, say like this, then this won't be possible any further because my this is already modified. If the call fails for any reason, then this will also get reverted. That is the atomicity about the transactions. So we need not worry about that. And this is what is called as checks effect interaction pattern. Earlier we were doing checks interaction and then effect. Preferably we should do check effect and then interaction. Just like how we had withdrawal pattern, we have this check effect interaction pattern. So I hope with this reentrancy is cleared and you have also learned about check effect interaction pattern. Now if you remember, we did this in the contract section when we were learning about modifiers. We also came across this contract mutex, where we understood how we can avoid this reentrancy by having the state variable logged and marking the state variable logged as true when we enter this function f. And now if somebody else is trying to re-enter this same function, the entity will not be able to because logged will be set as true. So this will become false and we will raise the revert. So this is how we avoid reentrancy. And the library which they are using is basically doing almost the same thing. It's a very small code also, so you can try understanding it. So it's doing roughly the same thing. So this is what this inheritance part is doing. Fine. And marking it as non-reentrant. We are using this modifier non-reentrant here. In case you want to mark all your functions and non-reentrant, then you will have to use this keyword in front of all your functions. In that way, if a function has entered this, it won't be able to re-enter some other function or this function, same function. This modifier will not allow to do that. But in that case, put this non-reentrant in front of every of your function if you want no reentrancy everywhere. So now let us try to understand this contract. We have seen about reentrancy. This IERC20 is something which will become clear the more we will use it, right? No point in covering each and every method the ERC20 has. We can see that in many of the examples which we will do, we will cover all these, this transfer, total, balance of, to get the balance the particular address have of this token, we will be able to. The more we will understand by looking at the examples. Okay. Yeah. So inside this unstoppable lender contract, we have a token. Somebody will deploy an ERC20 token named DVT, and in the constructor the address of that will be passed, and we are typecasting it to this ERC20 type, just like, so that we are able to call functions. Like here we are calling transfer from function of ERC20. So we have seen that we use an interface to help us with that. We could have very well used the contract also. So we are doing this typecasting here to this DVT token, which is of IRC20 type, so that we are able to call its methods. Fine. And they are requiring the token address should not be 0 because we want some token address here. Next, they have this deposit tokens function, external non-reentrant. So I'm trying to explain you this contract, and hopefully by understanding the contracts you will be able to see the exploit yourself, because if I were to give a small spoiler, it's ad hoc, nothing much. So require amount greater than 0, must deposit at least one token. they want you to deposit at least one token. So once you are depositing, then we are transferring. Message.sender is calling this function with an aim to transfer tokens to this contract. Fine. So from message.sender, you transfer this to this address, this amount. But no, I mean, we cannot call transfer from like that. I mean, as such, then anyone can steal the tokens from my wallet if they can just put my address here and their address here. To be able to call transfer from for some other, to get to transfer from basically transfers the tokens from somebody to somebody. But we need power, the authority to be able to transfer from somebody. So in that case, that somebody would have given us the allowance, would have approved us first. So transfer tokens from sender, sender must have first approved them. So this is the responsibility of sender. Sender will approve it. And then they have this variable pool balance declared here, to which they are adding this deposit amount. Fine. Now we have this flash loan function. What this function is doing, the person, the entity calling it will tell the amount which it wants to borrow. So the borrow amount must be greater than 0. You must borrow at least one token. Then balance before. Now, just like the transfer from function exists in this ERC20 tokens, there is also balance of, which I have told slightly about before, that it will give the balance of the tokens for that address which you have passed. So they are finding the tokens which this address has. So clearly the amount you can borrow should be less than equal to the amount I can give you, which is my available balance. So the borrow amount must be less than equal to the amount which I have. Otherwise, I am raising the exception with not enough tokens in the pool. Then they have their assertion that pool balance is equals to balance before, and they have this comment that ensured by the protocol via deposit token functions. This one. Then we are doing transfer. This transfer function will transfer the tokens from yourself to some other. So in this case, you don't need any approval because you are the one invoking this transfer function. I mean, this check it does that only the owner, I mean, basically you are the one calling this transfer function, right? So no issues here. You are transferring yourself with your authority to some other guy. So in this case, message.sender, the one calling this function, and then you are telling the borrow amount. But of course, this transfer function will do its own checks, like whether you have this much amount which you are transferring, that you are not sending to, I mean, the from address is not null, etc. It will do. You can read about this code in the ERC20 file. Like here, I have these ERC20 contracts file open, and you can see it has this underscore transfer. Basically, when we are doing this transfer function, then it will invoke this underscore transfer from the owner, which is the message sender, to end amount. So in this underscore transfer function, we have all these checks that require address is not 0, so on, and basically you can read about it if you want. So after transferring the loan to the one who wants to borrow it, then they have this, the way it is asking back the tokens is that they expect that the receiver will have this function defined, receive tokens. To that they will pass the address of the token and the amount they want back. Fine. So that is why they have this interface here to be able to call that function. So receive token is the function. You give the address of the token and the amount which you want back. So that is how their flash loan is, and user can do operations inside this receive tokens function, right? So balance after, they are checking whether the balance after is greater than equal to balance before. So uint6 balance after damn valuable token dot balance of address this, and they are checking whether the user have paid at least that much amount which it borrowed. So flash loan hasn't been paid back will be the exception in case this check has failed. So I hope with this contract you have easily understood, and the reason why they were able to why they were importing these two files. And OpenZeppelin is the one which helps whose contracts are the most popular regarding these. So they are importing from OpenZeppelin. Next, we are looking at this receiver unstoppable file. All this is same, and then they are importing this file so that they are able to call its functions. Otherwise they could have defined the interface, and they have this import for this IARC20 for the same purpose, to be able to call the functions. Now inside this constructor, they are initializing this owner variable to the message.sender, the one deploying this contract, and to this pool, which is of this type unstoppable ender contract type here. They are taking this address and initializing using that address. So this part I hope is clear. Then the execute flash loan function, you tell the amount, and they require that only owner can tell the amount. So only owner can execute flash loans. And then using this pool, which was initialized here, you are calling this flash loan function, and pool in turn will call this receive tokens function to receive back. And as we can see, so first of all they check whether the message or sender is the pool or not. So sender must be pool. And then they are not doing much with their flash loan, they are simply returning it back, right? So again we have that transfer method, message.sender amount. In case it fails, so transfer of tokens fail. So I mean, also we know that atomicity about transactions, right? So in case it fails, so everything else which it did will get reverted to. That is how Ethereum transactions work, and we don't have any try catch here. So with this, I hope these two contracts are clear to you. Now let us try to understand this file, unstoppable.challenge.js. We have this as normal, the require hardhat for the ethers. Then this is something new which is not seen. Then also this describe before, this expect something to equal, and it after. So these few things we haven't seen. And in case I go to the Hardhat documentation, basically we are using Mocha here. This describe before, after, it is provided by the Mocha to us. And and they have helped us. The Hardhat has a good example to understand these also. So let me see that. We import chai to use its assertion functions here. All that expect something to equal is done with the help of chai. Next we have this describe keyword. So describe is a Mocha function, or mocha, I don't know how it's pronounced, that allows you to organize your tests. It's not actually needed, but having your tests organized makes debugging them easier. As you will go through these examples, this will make sense to you. All Mocha functions are available in the global scope, so we need not import Mocha here. Describe receives the name of a section of your test suite and a callback. This part we call this as callback. The callback must define the test of that section. This callback can't be an async function. We have seen async functions before. Alright. Mocha has 4 functions that let you hook into the test runner lifecycle. These are before each, after, and after each. Let me also read their descriptions here. So hooks, with its default behavior driven development, you can look about this acronym in Google, it's a paradigm. Style interface, Mocha provides the hooks before, after, before each, and after each. These should be used to set up preconditions and clean up after your tests. So we have this before, which runs once before the first test in this block, and before each will run before each test in this block. Block is described by this describe keyword. And what are these tests? We write test using this it keyword. If I show you, here we have a test here. So using this it keywords, we write the test. all right, and we have after, which runs after the last test in this block, and after each will run after each test in this block. Continuing here, so these before each etc are very useful to set up the environment for test and to clean it up after they run. A common pattern is to declare some variables and assign them in the before and before each callbacks. So we have seen about these before, after etc. So let us continue. We have these variables deploy, attacker, some user initialized in this before block, and we also have this tokens in pool. A token contains 1 million DVD tokens, if and each token, just like 1 ether is 10 to the power 18 similarly, so 1 million of those, and initial attacker balance is 100. If I show you here in this damn vulnerable DeFi, the very first challenge, we were we had this that pool has 1 million and we have 100. So that is the motive here. We assign these variables using our get signers, then they have this contract factory they are getting of this damn valuable token, which is shown here. Let me first go through the other part. Here they are just deploying, and the other contract factory is unstoppable lender, which we have already seen, this unstoppable lender. Fine. And now they are deploying this damn valuable token. Now when they are deploying this damn valuable token, I have told you even by default it is deployer. So even if deployer was not mentioned here, still it will work fine. Inside their damn valuable token, they are minting these to the message sender, and they are minting these many tokens. So the message sender, which is the deployer, this guy, he will get all the tokens initially. Initially he will be the one having all the tokens. So when I'm doing this, I'm having all the tokens here. Two additional things to note: they are not doing this dot deployed method, and to me, I don't know why they're not doing it. For instance, if I go here, you can see this is the ethers.js documentation, and you can see that they are deploying an instance of the contract using this await keyword also, so dot deploy, and they're saying the address is available immediately, but the contract is not deployed yet. So in my opinion, the deployed method should be used. Maybe because we have so many other awaits, this other await is also there, that is why there was no need. The code is working fine even without that dot deployed method, but in my opinion it should have been used. And what is this keyword? All right, if I were to explain you, we are having a variable token here assigned this contract, which we can use later also, like here they have used using this keyword. But if you want to understand it technically, since my course is focused on Solidity, but you can have a look at this YouTube video. This is by this Fireship channel. You can have a look at it, and this will help you regarding this keyword. So with that, it's fine, but the semantic is just that we can use this token variable again, this contract again, to my others. This here also I can use this dot token. Fine. All right. Now I want, since the deployer has all the tokens, right? This part deployer has all the tokens. Also they are deploying that unstoppable lender contract with the token address. Okay. Now deployer wants to send the pool 1 million tokens. This is the setup which we want. So instead of doing this simple transfer, they could have done that. What they are doing, they want to use this method, this deposit method, and this deposit method will then transfer from the deployer the tokens. but that requires the approval. So here the deployer is approving this pool address, the pool contract, that you can take at most these many tokens from me, the tokens in pool. And then we are calling this deposit tokens in that contract, the lender contract, with the amount tokens in pool. So the contract will take it. But to the attacker, we are simply transferring using this dot transfer method. Since we are the one calling, so we don't need any approval here. And we are sending these many tokens which the attacker wants, that is 100. Now we are expecting, they are just checking whether the pool actually has received these many tokens. So they are checking that balance of the pool is equal to the tokens in pool, which it should be. So this should work fine. Similarly for the attacker balance. Now show it's possible for some user to take out a flash loan. Now this receive part, receiver unstoppable, they are deploying. So await get contracts factory, that receiver, and some user, so not the deployer, some other user is deploying this contract, and that makes sense, that is what they want actually. So we are waiting for this to deploy, and then they are executing the flash loan for the 10. And what is this 10? Yeah, it's amount, so it is just like v, 10v, it's like that. So fine, and you have to code your exploit here. You have to make the pool not functionable, and after they will verify that when the user is trying to make a flash loan call, it is to be reverted. So that is what they are expecting. Fine, and that is what you have to do. I have explained you all these three files now: this file, the unstoppable lender, the receiver file, and this main file. Now it's up to you to understand to figure out where is the exploit. I'll be pausing my video here, and most likely I believe you will be able to find it. Give some time. If you are not able to, then you can continue with what I have as a solution. Now I'm going to give one hint. So I'm giving a hint now. This part as a hint. Again, I'm pausing the video. So I hope by now it is clear. Basically, first of all, this is unnecessary. In the sense, the smart contracts should be minimal. One thing, and this example tells why. So the more additional useless things you have, the more chances of exploit. So this is not needed also. And secondly, like, this can change. We are having this deposit tokens, but I can transfer otherwise also, just like how here the deployer transferred the tokens to the attacker. Similarly, the attacker can transfer to this contract, the pool contract, not via this deposit token method. Secondly, when the flash loan is being paid, some additional amount can be paid, but yeah, if you pay additional amount, then also we will have this mismatch. So yeah, in these ways you can exploit it. And if I were to just simply code that exploit for you. So what we want to do this part, to simply transfer to the pool, right? So here I will do this dot pool dot address, and you can send in any amount, it's up to you. I'm gonna send 1 into 10 to the power 18 DVT tokens here. And who is transferring it? The attacker. Basically, we want to call this transfer function, but anyone can call this public transfer function, right? Who we want the caller should be? the attacker. So that is what this connect method helps. By default, it is connected to the deployer. So we want the attacker to do that. So I'm gonna save it here. Now to run the test, I write this yarn run unstoppable and I'm going to hit enter. Let's see what it gives. So it has finally stopped running and I'm getting passing. So we have done the first challenge. Congrats. Also, inside this damnvulnerabledefi.xyz, they mention how to run the exploit. So run your exploit for a challenge with yarn run the challenge name. So that is what I did. So if it's executed successfully, you have passed. Let us now look at the second challenge named Knife Receiver. You know, these names are also the sort of like an hint about the challenge. There is a lending pool offering quite expensive flash loans of Ether, which has 1000 Ether in balance. You also see that a user has deployed a contract with 10 Ethers in balance, capable of interacting with the lending pool and receiving flash loans of ETH. Drain all funds from the user's contract. Doing it in a single transaction is a big plus. So I hope the description is clear. Next, I'm going over these files. Pay attention to each and every keyword. Fine. So license identifier, pragma solidity. They are importing two files. Reintrinsic guard, we have seen its purpose, and then there is another one, address. We will see its purpose in this file. So they are having this utility and they are attaching it to the address. So if I open this, we have this library with variety of functions that whether a contract at this address is actually a contract. So they use this ext code size opcode to determine whether it's a contract. Contract will have size greater than 0. Of course, this also has its own loopholes. Other than that, there is this send value function call. We do this low level call, right? So this function call will help regarding that. So if we it has all these methods which you can look. More will become clear when we will be using that. So now the fixed fee. So the fee is fixed, which is 1 ether. Now they have this getter function to return this fixed fee amount. Fine. I might not go over all these keywords, but this constant, private, etc. But you should pay attention when reading. I'm just explaining here about the contract. Next, we have this flash loan. Then the borrower and the amount to borrow. So external, non-reentrant, balance before using this. Then check whether you can actually give this much amount, otherwise not enough ETH in pool. So you require that a borrower is contract. Fine. That is the one use of this address library which we saw. So borrower must be a deployed contract. Since we are using this is contract, let us also read this. So it returns true if the account is contract, that is the motive. However, it is unsafe to assume that an address for which this function returns false is an externally owned account and not a contract. So if it is returning true, then definitely it's a contract. But if it's returning false, even in that case it can be a contract. So among other possibilities, this is contract will return false for the following type of addresses. One is being externally owned account. Next, a contract in construction. Third, an address where a contract will be created. Fine. An address where a contract lived but was destroyed. So I hope this is contract is clear. Also, if I read few more comments, this method relies on ext code size which returns 0 for contracts in construction, since the code is only stored at the end of the constructor execution. Next, if you look, they have this inline assembly here, which I haven't talked about really, because that is something sort of like only experts use. But you can write in sort of an inline assembly. It is not exactly the EVM opcodes which we see. It is the language known as Joule. So if I show you some info about it, we have this section inline assembly. You can interleave Solidity statements with inline assembly in a language close to the one of the Ethereum virtual machine. This gives you more fine-grained control, which is especially useful when you are enhancing the language by rewriting libraries. The language used for inline assembly in Solidity is called Yule, and it is documented in its own section. This section will only cover how the inline assembly code can interface with the surrounding Solidity code. Inline assembly is a way to access Ethereum virtual machine at a low level. This bypasses several important safety features and checks of Solidity, obviously. You should only use it for tasks that need it and only if you are confident with using it. An inline assembly block is marked by this, where the code inside the curly braces is code in the Yule language. The inline assembly code can access local Solidity variables as explained below. We need not bother about it. Different inline assembly blocks share no namespace. That is, it is not possible to call a Yule function or access a Yule variable defined in a different inline assembly block. So here they are accessing this size variable declared outside and assigning it this value, ext code size of account. So that is the EVM opcode, and then checking whether the size is greater than 0. If it is, return true, else return false. So I hope with this it is clear. So here the naive receiver is checking whether the borrower is contract. So otherwise borrower must be a deployed contract. Then they're calling this function call with value. Let us also see all these methods which we are using. So about this function call, I am inside here this address utility. So inside this address utility, so regarding this function call, it performs a Solidity function call using a low level call. A plain call is an unsafe replacement for a function call. Use this function instead. So for any reason, if you plan to use the low level call, instead of that you can use this function. If target reverts with the revert reason, it is bubbled up by this function just like regular Solidity function calls. If you use the low level call, you know that it returns the success condition, which is a boolean. There is no exception raised. So returns the row return data. To convert to the expected return value, use API decoding. And these further additional checks, that target must be a contract, so it does that check. Also calling target with data must not revert. Fine. Similarly, this function call where the additional parameter is string error message. So this function overloading is same as function call, but with error message as a fallback revert reason when the target reverts. So in case the target reverts, this function call will do the revert with this string, right? So I hope this is clear. Then we have function call with value, same as function call, but also transferring value v to that target, and the additional checks which it does. The calling contract must have an ETH balance of at least the value which it is transferring, and the called Solidity function must be payable. Similarly, regarding this string error message, which is the same as that. So these are the methods. There are other methods also which we need not bother currently. Also in that code, if you look, this function call with value and all other functions, mainly this function call etc., they also in turn call this only, this function call with value. So function call is also calling this function call with value. They put the value as 0. So inside this function call with value, they check whether do you have the suitable balance, whether the target is a contract or not, and then they have this additional verify call result which will revert in case of an exception, in case this was false, right? So I hope this is clear. Moving back to our example, so function call with value, they are telling what function and what is the value. So the function API encode with signature, this is the function with this unsent integer. And what is that unsent integer? Is this one, this fixed fee, and it is the value which it is sending, the loan. And now after all this is done, they are requiring that the address this dot balance is greater than or equal to balance before plus the fixed fee, otherwise flash loan hasn't been paid back. So this receive function will allow the usual deposits in case somebody wants to do that. Since I don't see anywhere the payable keyword besides this receive function, so this is indeed needed to fund this contract in the first place. Next, let us look at this file, the flash loan receiver file. So these two, and they are again importing the address file of the OpenZeppelin. Now this contract flash loan receiver using address library for this address payable, and they have this pool which is initialized in the constructor. They get the address of the pool. Now next, this receive ether function which will take in the fee public payable. Require message.sender is pool, so only pool should call this function, otherwise it is disallowed. Amount to be paid, pool is sending the value plus the fee which the pool is demanding, right? So that fee. Require address this dot balance greater than or equal to amount to be paid, otherwise you cannot borrow that much. So the user should have at least for the fees, right? Then execute action during flash loans, whatever the actions user want to do. For now this is empty. Then once it is done, pool dot send value the amount to be paid. This send value is also provided to us by this address library. And here if we read about this send value, so it's a replacement for Solidity's transfer. That is the motive. It sends the amount V to the recipient, forwarding all available gas and reverts on errors. Regarding transfer function, it does roughly the same thing except this forwarding all available gas. As you know, it forwards 2300 gas if I remember correct, and that helps in avoiding reentrancy though. And this EIP 1884 increases the gas cost. This 1884 is a thing of past. You can read about it if you want. Increases the gas cost of certain opcodes, possibly making contracts go over the 2300 gas limit imposed by transfer, making them unable to receive funds via transfer. So sends value removes this limitation because it forwards the all available gas. They have this important note which we know as such, but still if we read it, because control is transferred to recipient, care must be taken to not create reentrancy vulnerabilities. Consider using reentrancy guard or checks effects interaction pattern, which I have told you. Now how does this send value works? It's actually very simple. And if we look at this code, first they are checking whether you can send this much amount. Then they do this low level call, not send, not transfer, but a low level call with that value. So it is going to execute the receive function of the recipient. Then they require this success. So that is how they raise the exception part. So with that, this send value part is clear. And with this, they also have this receive function to fund this receiver, right? So with this, we have covered this contract also. Next, let us look at this last file, the third file, naive receiver.challenge.js. All this is usual stuff. So ethers in pool starts with 1000 ether, fine, and the receiver starts with 10 ether. So that is the motive here. Now this before function, so get signers, deploy user attacker is what they are getting. Now they are about to deploy this receiver lender and this flash loan receive. So the receiver lender is here, this contract which we covered, and flash loan receiver is this one which we covered. Then they deploy the pools contract. Now send transaction to this pool.address and value. So they are calling this. So the deployer is sending ether. When we usually run this Hardhat, all these signers, they start with some ether balance, right? So from its own balance it is sending ether to this pool's address. Basically this receive function will be invoked, which is payable, so ether will be received and the given value. Fine. Next they expect whether the transfer went through successfully. Moving on, they expect whether the fixed fee is indeed equal to 1 ether. Now for this receiver they deploy this with the pool's address. Fine. Now the deployer is funding this receiver also with 10 ethers. Next they expect whether the balance of receiver is indeed 10 ether. Here is where you have to code your exploit. Afterwards they expect the receiver's balance should become 0 and the pool, the pool's balance should be equal to ether in pool plus the receiver's ether, so that they got transferred here. That is what they expect. Now with this I have explained you the code thoroughly. Now it's up to you to exploit it. I'm going to pause this video here. So now I'm going to tell you the answer. No hints this time. So in case you want to pause the video now and think further, it's up to you. But I'll give you the high level idea. Basically here I can give this is an external function and anyone can call this function, and here I can give the address of the receiver. So for the receiver's contract I can give the address here and tell the borrow amount. Then this contract will call this receive ether function. Here this will be called and the pool itself is calling it. So the amount here will be taken from this contract. This contract will send the value back to this pool, and we have as a third person taken this 1 ether from the user. It is although not gone in our pocket, but the user has received a loss and pool has received the advantage. Now the way I can do this is inside this part here I can call this flash loan function, right, via this attacker which is initialized here. I can call this flash loan part function 10 times. I will need to call this function 10 times, each time taking 1 ether away as a fee from this user, and as the user has 10 ether, so that is why 10 times I need to call. So but if I do that here like so, then these all are 10 individual transactions. Again we have a for loop just like we learned in Solidity, and in this I'm doing this. So all these are 10 individual transactions. So if I want a single transaction, I simply just need to write a contract where a single function will call this another function 10 times. So that is what we are going to do next. So here I'm gonna create new file named, wait a second, attack naive receiver.sol. Fine. So let's do this quickly. Maybe so as to save time, I have this contract ready. What I'm doing, I'm importing this address and the ownable. Why ownable? Just to have some security, but it is not needed as such. So using address for address, and this pool address is taken in the constructor, then this attack function can only be called by me, the owner. So for this, in this attack function, I'm calling this 10 times. We could have taken the interface, that might have been better, but let's keep the spirit of function call. I mean, yeah, so ABI encode with signature, flash loan address U256. This is the address and the value which we want to take flash loan, which is 0. Making the value 0 will help so that I need not fund this contract. And this naive address is taken from here, which is sent. So this is the contract which I wrote. And if we go back to our this naive receiver challenge file, this is the second method which will do it in single transaction. So ethers.get contract factory, you get this contract, you deploy this with this pool's address, and it is assigned here. You wait for this to be deployed, and then you attack it with the receiver's address. So if I run this now, so if I run this naive receiver, the test is getting passed. So with this, the second challenge is also done, and I hope that it is crystal clear to you. Also, I realized that I haven't talked much about this ownable, and if I show you, basically it will give me access to this owner variable, which is initialized in the constructor with the message sender. So that is the purpose here, that the one deploying this contract will be the owner, and I want this attack function to be only called by me, the owner. Basically just some practices which I follow, so I just followed them here also. Also, I would like to take this challenge as an opportunity to tell further about this hooks. We haven't used before each and after each, right? Before each runs before each test in this block, and after each runs after each test in this block. And also, tests can appear before, after, or interspersed with your hooks. Hooks will run in the order they are defined as appropriate. All before hooks runs once, then any before each hooks, tests any after each hooks, and finally after hooks once. So here in the program that we had, this before is roughly the same just like before, except I have moved two lines from before to this before each, namely these two. This when the deployer is sending ether to the receiver's contract, and then they are expecting that the value is indeed what they expect it to be. So that is the modification I have done to the before, basically split into the two parts, one before then before each. Also, I have declared this new variable, let expected ETH in pool equals to ether in pool. As of now, what I am doing, I have two exploits here. One is this method 1 based on 10 individual transactions, and it is what it is doing. Then I'm updating my expected ETH in pool to this. Since all the ETH from the receiver has been stolen and is inserted now in the pool, so that my expected is added by that amount. And then once this test is run, so after each test I have this where they are expecting the same thing, just that here I have replaced it to expected ETH in pool, because once after this test is run, then again before each test will run for the second test, again I'm sending 10 ether to the receiver, and then those 10 ether is being stolen from the receiver and put into the contract. So here also we are again adding by the same amount, so it has become now 20, added by 20 in total. So that is why I had this new variable. And now if I run this, it is working as expected. So I hope with this that part is also clear, this before each and after each part. Next, let us move on to the third challenge. More and more lending pools are offering flash loans. In this case, a new pool has launched that is offering flash loans for DVT tokens for free. Currently, the pool has 1 million DVT tokens in balance and you have nothing. But don't worry, you might be able to take them all from the pool in a single transaction. So this challenge name is Truster. As I've told you, the challenge name is also sort of an hint about how to solve the challenge, right? So let us see the files associated. So with regard to Solidity, there is only one file to look at, and that file is also very short. So let us see that. All this is fine. Then this contract name, Truster Lender Pool, which is inheriting from reentrancy guard. They are using this library address for address, and then they are using this token, damnvulnerable token, whose contract address they take here and assign it here. Interface is known, so we can now call its functions, right? Now they have this function flash loan, which will allow somebody to take a flash loan. External non-reentrant and balance before. So they find the balance before of this ERC20 token using this balance of method, and they provide the address of this contract. They check whether the borrow amount is less than equal to what their balance is. Otherwise, you raise an exception, not enough balance, not enough tokens in pool. Then you transfer these tokens to the borrow amount which he or she or whatever has asked. Then this target and this call data which this flash loan is taking as an input is being called here. So this is where the pool is expecting that calling this function whatsoever, they will get their funds back. So balance after damn valuable token dot balance of address this, and check whether balance after is greater than equal to balance before. Otherwise, raise an exception that flash loan hasn't been paid back. So it's a very short and simple Solidity file. I hope the understanding part is done. Next, we have this truster.challenge.js. The tokens in pool, which is 1 million DVD tokens they want, and then this they are getting signers. Here they are deploying, this part and this part is done to deploy this damn valuable token contract, and this part and this part is done to deploy the Truster Lender Pool contract, where they are passing the address of this damn valuable token. Then they are transferring these tokens from the deployer to the pool amount, which is 1 million of these DVD tokens. Next, they are expecting that the pool has received indeed the tokens that we want, and the attacker balance is 0. So attacker starts with 0 as already told. Here you have to code your exploit. Next, afterwards they are checking that your balance is equals to token in pool. So you have taken everything from the pool and the pool's balance is 0. So with this I have explained you about this contract, this challenge. I believe that you should be able to find the exploit. Just have in mind what all we went through in all the challenges. So I hope you will be able to figure out. I'm going to pause the video now. So now I'm going to tell you the solution. Basically, if you look at this contract, this flash loan function is actually trusting that you are calling the legit thing here. But if you remember, we have been using this approve function of ERC20, whereby in this approve function, the message.sender can approve some amount of tokens to the spender, the address which we send in the approve function. So basically to this approve we send two things, the address of the spender, second parameter being the amount. So here also we can actually call that approve function, because the target can be that damn valuable tokens address and the call data can be corresponding to that approve function with of course the appropriate parameters. And to have this here, the borrow amount can be 0, so that we need not worry about sending later, because the approve function, the approval is done by the message.sender. So message.sender has to be this contract here. So we should not introduce any intermediate functions, just the approve function here, and borrow amount should be 0 for that, because otherwise we would have to introduce intermediate function, and in that case the message.sender won't be this contract. So let's see what I have here. So I'm going to paste my solution. Instead of writing a contract, we can very well write the contract and get this done, which will also be the single transaction. But I want to illustrate ethers.js library. So the way I'm going to do this is this way. We basically in Solidity we would have done this ABI encode with signature, where we put the function's name, the signature of the function, and then the parameters. Fine. But to do that same thing, like to do that same thing in ethers.js, this is how we do. First, we declare this variable named ABI to give the interface. So approve function which takes the address of the spender and then the amount, right? So you use this library function to get the interface. Fine. And here now I'm calling this flash loan function. Anyone can call this flash loan function. Here the deployer is calling, so maybe I should do this to make it more genuine. Now the attacker is calling this flash loan function. Borrow amount is 0. Then address of the borrower, I'm putting it as the attacker's address. Now the DVT tokens address. Now as the call data, we are putting this approve function with the address of the spender, here being the attacker, and the approval is for these many tokens, the whole tokens in pool. I personally learned about this in this from this question. I learned about how to be able to use ABI in ethers.js. The normal way, the contract way, we already anyways know. We have done various examples in which we did via contract. If I remember, in the attacker naive also, we were doing this ABI encode function with signature. So this way you already know how to do this. You can write your function and call that pools flash loan function with the appropriate parameters like this. This we already know. So let's now learn about ethers.js way. So alright, this part is done. This is one transaction and this is the second transaction. So here I'm doing two transactions. You can very well do it in a single transaction. I'm doing this way to illustrate about ethers.js. Now you connect your spender and then you call this transfer from function of the DVT token from the pool to your address for this much amount. Actually, regarding this spender thing, you see, when we do this transfer from function, what it does, it takes the from and it sees whether the spender, the attacker here, has the allowance of that much amount. If the spender has the allowance of that much amount, then that entity can, the spender can send to some address. It need not be the spender's address, could be any address. So very important to connect spender. I actually did two transactions above, but you can of course write a contract including the above two steps. Also, if I tell more about this transfer from function, here we have this transfer from function. The spender is message.sender, so that is why I connected my attacker, so that attacker is the one calling this function. Now they check the spend allowance from this address, and then the spender. So whether the spender has the allowance of this much amount. So this is what this function is doing. You can also see it if you want. Spend allowance, here it is. So the current allowance, they check of the owner to the spender, and they want the current allowance should be greater than equal to the amount that you are spending, right? And next they have this approve function, so that the allowance is now updated because you have taken the some amount. So now they are updating this allowance to this amount, current allowance minus because the amount which you have taken. That is what is getting updated here. Next, after this allowance check, where it is, yeah, after this check, then the actual transfer is happening. We can also perhaps see that here it is underscore transfer. So they deduct the balance from and add to the 2. So that is how. I hope this part is clear. So now let us run this and check whether it is working correctly. So yarn run truster. Let's run this. And indeed it is working perfectly fine. So I hope with this everything is clear about this third challenge, and congrats in making this far. Now let us look at this fourth challenge. Surprisingly, the challenge name is side entrance. A surprisingly simple lending pool allows anyone to deposit ETH and withdraw it at any point in time. This very simple lending pool has 1000 ETH in balance already and is offering free flash loans using the deposited Ether to promote their system. You must take all ETH from the lending pool. So this is the description of the challenge. The associated files are these two, side entrance lenderpool.sol and this side entrance challenge. Here we have the contract, and in the test folder we have that test file, right? So let us look at the contract. Let us start here from this contract name side entrance lender pool. So this is fine. So they have a state variable balances mapping address to an unsigned integer. So deposit function which is marked as payable, so anyone can deposit Ether in that. So for the address, the depositor, they have added that value which the depositor is depositing. Message.value, as you know, contains that value, the Ether. So that is how it is receiving Ether. Then we have this withdraw function where they find the amount to withdraw. Then they have this effect before any interaction. So that's nice to see. So they are making this balances 0, and then they are sending the sender the value which he is entitled to, he or she, whatever. Then we have this flash loan function where you tell the borrow amount. So balance before, just like normal. So balance before should be greater than or equal to the borrow amount. So otherwise you will raise an exception, not enough Ether in balance. Then the receiver, they expect receiver to have this execute function marked as payable. So they are calling that execute function with the value. So that is how they are sending the value. And there is no receive function here. So this execute should return the money back. And since there is no receive, then I guess you will have to use this deposit to send the money back. Then we have this require address this dot balance greater than equal to balance before. Otherwise raise an exception that flash loan hasn't been paid back. So I hope this contract part is clear. Let us now look at this file side entrance challenge.js. All this is normal stuff. So Ether in pool, they want 1000 Ethers in the pool. So setting up the environment, get signers, deploy attacker. Then they are deploying this side entrance lender pool here and assigning it to this pool, this dot pool. So these two lines are helping the deployment part. Now they are depositing from the deployer, this guy. As I have told you, they already have some Ether balance in their account, and they are depositing the value this much, value in Ether. Fine. Then this dot attacker initial balance is equals to await. They are finding the initial balance of the attacker so that they can compare with this later, as we will see. Then they are expecting that the balance of the pool is actually this Ether in pool, that our deposit has went through successfully. Next is the it part where we code the exploit. Then afterwards they are checking that the pool balance is indeed 0, and here instead of checking that your balance is equals to your balance before attack, that is your balance before attack plus ether in pool, instead of checking that, they are simply checking whether your balance is greater than your balance before attack. Why are they doing that? Because let us read, not checking exactly how much is the final balance of the attacker, because it will depend on how much gas the attacker spends in the attack. If there were no gas cost, it would be balance before attack plus ether in pool. Now to attack this contract, we will deploy our contract with this signer, this guy. And now at that point some gas cost will be taken away from this attacker, and when attacker himself attacker itself will be calling its attack function, in that case also some gas will be taken by from this attacker account. Basically, whenever we were calling some functions, right, in past in these various challenges, we were calling them via this deployer, some user, attacker. So whosoever were calling, that entity's gas, that entity's ethers was being consumed as gas cost. Fine. In the intermediate part, actually the main caller, the initial caller, that is the one paying through all the gas. As we have seen, the gas gets forwarded and so on. So here the attacker will be calling its own attack function. So this guy's ethers will be lost some amount, very little amount, as gas cost. So that is why they are not doing the exact equality check, but are greater than the initial balance. So with this, I have explained you these two files of interest, and in my opinion the exploit should be clear to you. So I'm going to pause this video now and come back later. Okay, now I'm back and I'm going to tell you the solution. It's very evident. Here, when you are taking the flash loan, a user can ask for the complete amount, that send me whatever you have. So the whole of the pool's balance will be sent to the message.sender, and the execute function thereupon will be called. Thereby, user can just deposit the whole amount here. Fine. Then the whole amount is deposited also. The loan has been paid back successfully. So this part will be over, and this part is done. Now, but this is updated with message.value, and now you can just, the attacker can therefore next call this withdraw function to get the whole amount back. So then the attacker's contract will get the whole amount. So this is what we are going to do for the exploit. So I have written this contract, attack side entrance lender pool. This is fine. We are getting the address of the pool inside the constructor. I am using this ownable, otherwise you could have declared this owner variable yourself. Basically I want to have this modifier, and also let us go through first this attack function. Attack function is calling that flash loan function with the entire pool's balance. So whatever the pool is having, I want that. Inside the pool will in turn call this execute function, thereby also sending the value because it is marked as payable. Then pool, here I'm going to call that deposit function, right? I'm calling that deposit function here. So that part is done. The control will reach back, execute. Once the execute function is done, the control will reach back here, then it will do this check, and then after the finishing this function, the control will reach back to the caller here, right? Next we have this line, and I'm going to withdraw the complete amount. Once I have withdrawn, then I'm going to send the funds from the contract to the deployer of this contract, the actual owner, right? So to the owner I'm sending the address back. Here the gas cost will be paid by the person, by the entity who called this attack function. So the entire contract's balance marking here is fine, because I mean, if you have this confusion that if I am marking this whole address balance, then won't this create issue with the gas? Because this contract, when it is sending the whole amount, it it should not send the whole amount because it might need some amount for the gas, but that is not the case. The gas is paid by the entity calling this attack function, right? The gas gets forwarded. So I mean, I think this should be clear. We have done this thoroughly, but I just wanted to make this extra clear. So that's it. Also, we have this receive function here, which is needed because here this withdraw is calling that send value, which we know is a call with empty call data, so that the receive function will be triggered. So that's it. And if I look what I have written in the exploit section, just deploying the contract and attacking it. Maybe I should also add this line dot deployed. So fine, this is done. Let us now run the run this test and see whether it's working fine or not. And yes, it is passing, so congrats in completing this challenge. Now let us look at the fifth challenge, the rewarder. I have something to say here, that it is not possible for me to as such explain this problem without also showing its loopholes. Like for instance, in the last challenge that we did, I told that there was no receive ether function, and therefore to send the funds back to the lender, you have to use that other deposit function. And in that way, I might have also given out the solution to that problem. Similar is for this problem. When I'll be going over its functions, there are some bugs which are very much evident, and I just cannot go over them when I'm explaining the contract. So for this challenge, try to understand the contracts yourself, but to help you a little, even this description I don't want to cover. Just to help you a bit, I will just tell about these things. They maintain an accounting token. The purpose is for accounting purposes only. This setup role basically setting message.sender this role, and assigning default admin role to message sender, assigning snapshot role to this guy, burner role to this guy, so that the mint function can only be mint by the person having this role, minter. So has role, this message.sender should have minter role, else revert with the exception forbidden. If this has passed, you mint to this address these many tokens. Fine. Similar is for burn. Only burner can call this burn function. Snapshot is there. Basically, they take snapshots of a state of the network so that they can refer to it later and see what were the, suppose now today I am having 100 tokens and you are having 50 tokens, and after 2 days our balances have changed, but after 2 days if I were to check what were my balance 2 days earlier at that particular snapshot, see, that is the purpose of snapshot. So at that particular snapshot I can query what were the balances. For instance, I was having this token and you were having that token. That is the purpose of snapshot. Transfer they are not allowing, and approve they are not allowing. So this was their accounting token. Flash loan pool, something is talked about in that challenge about flash loan. So we have a flash loan pool. Flash loan pool code is very similar that what we have done previously. Then there is this reward token, just like accounting token, they have their another token named reward token. Almost similar. This setup role is what the things is extra which we haven't covered. So I'm just telling about it briefly. And then is their main contract, the rewarder contract. So, and of course there is this challenge file. So try to understand this, and I'm going to pause the video now. After I resume this video, I will explain the contracts. My aim won't be to give the solution, but to explain the contracts thoroughly. And in that case, I might also give the answer, but that is not my purpose. My purpose would be to explain the contracts. So now I'm pausing this video. All right. Now I'm resuming it, and we are going to see this challenge. Challenge 5, the rewarder. There is a pool offering rewards in tokens every 5 days for those who deposit their DVD tokens into it. Now, the way I see the contracts, it is not every 5 days, but at least 5 days. That is my understanding. Now, Alice, Bob, Charlie, and David have already deposited some DVD tokens and have won their rewards too. You don't have any DVD tokens, but in the upcoming round, you must claim most rewards for yourself. Oh, by the way, rumors say a new pool has just landed on mainnet. Isn't it offering DVD tokens in flash loans? So it's clear we have to use this flash loan to exploit this rewarder contract. So let us now see the contracts. So first let us see this flash loan pool, which is very simple, and we have already covered this almost same contract before. So this flash loaner pool is there, their DVD token is there, which is being initialized in the constructor, which yeah, and we have this main flash loan function where they are checking that you the borrow amount should be less than equal to your balance, otherwise not enough tokens, raise an exception. Now they are checking that the message.sender has to be a contract, so borrower must be a deployed contract. If these checks are passed, you transfer the DVD tokens to the message.sender about the borrow amount. Afterwards, they call this receive flash loan function. So in the message.sender contract, they expect this receive flash loan function. They are sending it with this amount. So this is the amount that they want to get back. So basically no fees. This part, once this part is done, then they are requiring that yes, I have received the contract. So the receiver flash loan should do this similar transfer to this contract's address. Alright, this is that flash loan pool. Now we have this rewarder pool. Here they have this constant variable, 5 days is what they want, that after 5 days we give the rewards. These two variables are there, last snapshot ID for rewards and last recorded snapshot timestamp. Basically, when is the new reward round? New reward round is the last recorded snapshot timestamp plus rewards round minimum duration, which is 5 days. So when the current block timestamp is greater than equal to this thing, then is the new reward round. But then what is this last recorded snapshot timestamp, where actually it is getting updated, right? Here is the place where it is getting rewarded, updated. As you can see, only in this place, the line 89th is where it is getting updated. So next the question comes, when this record snapshot is being called. So at the constructor time it is being called. So initially, if the constructor we see, one is this DVD token, liquidity token, which they have this state variable. Next is their accounting token. Basically they want to keep track at a particular snapshot how many DVD tokens the following entities had, their users, right? So that is the purpose of accounting token. And the reward token purpose will be to give rewards in their own tokens, right? So out of thin air you're getting rewards. And in the initial part, very initial part, the record snapshot, if you look at this person, and also many places you will see that private functions this use this underscore to begin its name. It's not something mentioned in the style guide, your personal preference, but usually this is what is seen. So last snapshot ID for records for rewards, accounting token dot snapshot. In the very beginning, So in the very beginning, as such, the users don't have any of this accounting token, right? Their balance is 0. So that is the starting point, the for this snapshot ID. And we got this block stamp a value inserted in this last recorded snapshot timestamp, and now they are incrementing this round number. Fine. This is one place where this record snapshot is being called, and there is another place where it is also called here. Now understand the concept. But uh, when we are understanding, the loopholes is also becomes clear. Suppose 5 days have passed. Nobody has deposited anything. Nobody has deposited anything, and 5 days have passed. Now I am depositing. Fine. I am depositing. As such, when I'm taking the snapshot should be of the past duration. The 5 days which have passed. Snapshot should be in those. What I'm trying to say here, suppose I'm depositing something. They check whether my amount is greater than 0, which it would be. Then they are minting this accounting token and depositing to me. Fine. And now they call this distribute rewards function. So the amount which I'm depositing, they are first minting that amount to me, giving it to me, their accounting token, before they are doing this distribute rewards. And when I look at their distribute rewards, notice I have told you that 5 days have already passed. And what the procedure here is, after constructor, nobody has touched this contract and 5 days have passed. That is the initial setup which I am assuming when explaining this contract. So this deposit is calling this distribute rewards. Inside this distribute rewards, they have this own local variable rewards equal to 0. Now they check whether the new rewards round is there or not. Since I'm calling this deposit function after at least 5 days, then is new rewards will check this thing was initialized in the constructor part, right? 5 days have passed and the current block time is definitely greater than equal to this thing. So there is new reward. It is new rewards round. Now they are doing this record snapshot with after taking my amount. So this record snapshot, what it is doing, they are taking this snapshot, but this snapshot has my new amount basically, which will be used when giving the rewards. They have taken this snapshot, updated this variable and incrementing the round number. So now they have taken the snapshot. First let us go through it, then I think you will be able to understand what I'm trying to convey. So total deposits is equals to account token total supply at last snapshot ID for reward. It should have been the last, but it is actually sort of like current in the sense because I'm depositing now after those 5 days, right? After those 5 days I'm depositing, but I am being very well considered in getting the rewards. So accounting token dot total supply at, so since I am the only person depositing, so my amount will be there. Amount deposited for this message or sender, again my amount, so these two turn out to be same. So amount deposited greater than 0, yes. Total deposits greater than 0, yes. Then they compute this reward amount. Simple ratio they do, that this amount deposit divided by total deposits, multi into 100 into 10 the power 18. So according to them, out of 100 they are doing this. 10 the power 18 is just like, how 1 ether is 10 the power 18 V, right? So same thing. So 1 token is 10 the power 18, that smallest unit. So out of 100 they are doing this. Since I was the only person, so this thing is equal to this thing. So this divided by this will be 1 into 100, so 100. So these 100 tokens. So if rewards is greater than 0, which it is 100, and has retrieved reward. Basically, they are checking whether have I taken the reward in the past. So last rewards timestamp for my account, which is, I mean, they are passing message dot sender here, right? They check whether my account lies within that 5-day window. So that last recorded snapshot timestamp, I mean, greater than equal to this thing and less than equal to that 5-day window. And initially, I mean, like if we look at this variable, this state variable, this thing, last reward timestamp, right? Let us see where actually it is getting updated. So actually in one place only, and initially the default value is 0, that we know, right? And 0 will definitely be, I mean, will be less than this quantity, last recorded snapshot timestamp. Since it will be less than that, this will return false, and not of that will become true. I have not taken any reward as of now, so they are minting me the rewards. So even if some other people have deposited what all their amount, I can as a come in 5 days later and deposit my amounts and still be part of that reward of the last, I mean, this the last 5 days duration reward. So I hope with this the this contract is clear. We have also seen this contract, and regarding this accounting token, very simple. They have this ERC20 snapshot which will give them the snapshot capabilities, and access control is also there for all this setup role, etc. Alright, so they have this minter role, snapshot role, burner role taking the check hash, and here they are assigning these roles. Let us not go into too deep, but just understand the semantics here. If you want to go deep, you can just read their documentation or the look what this function is doing in the backend, I mean the actual contract. So fine, they are assigning here. The token name is R token, the ticker, the symbol is RTKEN, and then this mint function is there. So only minter can mint to the particular address the particular amount. Only burner, the one who has the role of burner, can burn from a particular account this amount. Then snapshot function is there to do this snapshot capability, and only the one with that role can do that. Transfer is not implemented, do not need transfers of this token, they are just minting burning, and do not need allowance. This approved thing is not needed for this token. Very and if you also read, by the way, this is the the Natspec comment. So at the rate notice, a limited pseudo ERC20 token to keep track of deposits and withdrawals with snapshot capabilities. So this contract is done, and we have this reward token, very similar. The setup role is there, etc. All right, and then this mint is there. So only the minter can mint to a particular account, particular amount. So with this, we have understood these contracts. Now let us look at this, the rewarder challenge.js. So this part is as usual. So they have these variables, the users, that is how you declare variables using this let keyword. Let constant, the main difference being constant. Once you have assigned it a value, you cannot update it. But for the let variables, you can update it later. So 1 million tokens is in the lender pool. So before part, they are having these signers. Fine. Users Alice, Bob, Charlie, David, the one which will deposit and get the rewards initially. This part is for this flash loan pool, the rewarder pool, DVD token, reward token, accounting token. Although this reward token, accounting token is something the rewarder pool is instantiating, then you might wonder why is this the rewarder, this JavaScript file having these. Basically they will attach this thing to what this constructor is instantiating. So to this instance only, to be able to access this instance, we have declared these variables to which we will attach. I mean, it will become clear as we will see the code. So the liquidity token is being deployed here. The flash loan pool is being deployed with this token's address. Then they are setting the initial pool's balance. So they send these many tokens to the pool, which it deserves. Then the rewarder pool, they are deploying this contract, the rewarder pool, with the parameters which it needs, the liquidity token address. Now the reward token, they are attaching it to here, and the sort of like silly thing being, the author is using the await keyword here, which is not needed. They don't return a promise. You don't need to put await keyword here. I also raised a pull request. I think he hasn't responded to that. So fine, await is not needed here. Also, by the way, you can see if I hover over it, it tells me await has no effect on the type of this expression. So I received some help there. Okay, so accounting token we are again attaching to that instance, right? This dot rewarder pool dot reward token, this dot rewarder pool dot accounting token. Now these users are depositing 100 tokens each. So first we transfer to the deployer the users that amount 100. Then we are approving the rewarder pool to take this much amount from us. Fine. If you look at the rewarder pool, in the deposit they use this transfer from. So that is why we are approving them. Of course, we need to do this connect type. Similar for this, after doing the approval, we are doing the deposit. Now they are just checking whether this has gone through successfully. The accounting token is updated. Next, they are again checking whether the total supply is 400 because 4 users have deposited, and the reward token supply should be 0. Now this is something new in the sense they are now increasing the time by 5 days. So 5 into 24 into 60 into 60, 5 days. Of course, not exactly, but roughly. So that is what this has done. Now they are calling this distribute rewards function one by one to get their rewards, which will be 25 because 100 divided by 4 is 25. So they are checking here whether each user has received 25, and the total quantity of this reward token should be 100. Now they are checking whether attacker starts with 0 of these DVT tokens, which it is, and they check whether how many rounds have happened. So 2 rounds should have occurred so far. If you look at the rewarder pool contract, this function, this variable round numbers, it is marked as public, so anyone can access it. Let's also see where it is getting updated. So only in this one place. So at the constructor time, since this record snapshot was being called, we have incremented by 1, and when this new reward has happened after the 5 days, when we increase the EVM time, so this will get triggered whenever anyone is calling distribute reward. But once it is triggered and the 5 further days have not passed, then this thing won't be valid anymore. But at the very first time it is valid, and therefore the snapshot will get recorded, and that is how this round number will become 2. Fine. Next, here you have to put in your exploit. Then after that, they are checking that only 1 round should have taken place, and users should get negligible reward this time. It is not 0, it is negligible. So you are supposed to get most of the rewards. So fine, they are calling this distribute rewards function, and they are having this reward for a particular user, what rewards that user has received. Now they have this small delta, right? I mean, subtracting their previous reward 25. And what I mean, we saw that user already received 25, so now its balance will be greater than 25, but that increase should be negligible. So to that rewards, if we subtract 25, they want that this delta should be less than 0.01 token, right? And 1 is 10 to the power 18, so 0.01 will be 10 to the power 16. So that is what this parse units is helping me do. Parse ether is same as parse units, where the second input being 18. So that part is done, and then expect that rewards must have been issued to the attacker account. So expect this dot reward token dot total supply to be greater than 100, of course, for the next round, and then let rewards they are finding now for the attacker. And yeah, since the amount of rewards earned should be really close to 100 tokens, that is what they want. So it should be close to 100 but a little less, because other people would have also received some negligible amount of rewards. So for the attacker, the rewards the attacker has received, so from this 100 we are subtracting that rewards the attacker has received, and this should be very small number, so delta. So they're checking it whether it's less than 0.1. That's is what being done here. So attacker finishes with 0 DVD tokens in balance. So started with 0, ending with 0, but has in process received lots of reward tokens. So that is being done. With this, I have explained you thoroughly these files and this JavaScript file. Now try to think of the exploit. I'm going to pause this video now. So now I'm telling the answer. Basically, after 5 days, you take the flash loan and do this deposit. Since take the large amount as the flash loan, and since you will be the largest depositor, these all people have just deposited 100, and you are the largest depositor with the largest amount. So you will get most of the rewards. After that, return the borrowed DVD tokens to the flash loan pool. They're also not taking any fees, and in the process you would have got all these reward tokens. So yeah, anyone can do this deposit after 5 days and still be considered. So fine, I'll just code the exploit, put the code of the exploit now. So after 5 days, I'm making the time traverse by 5 days, and I'm deploying my contract, and I'm just calling the attack function in that contract. So what is my contract? This is my contract. So in the constructor, I need the address of the reward pool, I need the address of the DVD tokens, need the address of the flash loan pool, and need the address of this reward token. Basically, in the end, I want to transfer the reward token to the owner of this contract, the deployer. Fine. The one who deployed this contract. We also have a deployer variable. So not that deployer. Attacker will be the one deploying this contract. Fine. So attack function is simply calling this flash loan with this much amount, basically 1 million tokens. Since 1 million is 10 to the power 6, so 10 to the power 6 into 10 to the power 18 is 10 to the power 24. So, and then the flash loan is calling this receive flash loan function. So this is a simple assert I just did when I was checking my program. Now I am calling this approve function for the rewarder pool address, this person, with this much amount. So the rewarder pool can take a 1 million of these tokens. Then I'm calling this function deposit function with this much amount, 1 million. And this deposit function will in turn call the distribute rewards, and I would have thus received all those rewards there, as you have I've explained you why before. And then I'm just withdrawing my rewards. Not my rewards, sorry, my amount which I deposited here. I'm withdrawing these tokens, these DVD tokens which I sent. Now I'm just transferring my reward tokens to the owner, all the balance, and then DVD tokens I'm sending the message to the message.sender, the flash loan pool back the amount. So that's it. Pretty simple once you understand the codes. I mean, all these 10 problems are ad hoc. I mean, nothing as such. I mean, these reentrancy, etc., which we learned, or the withdrawal pattern, or some things like that, were quite interesting. But most of these problems, as you will see, are quite ad hoc. So now, if I run this, yarn run the rewarder, it is successfully passing. So, congrats in the completion of this challenge. Alright, next we have this challenge named Selfie. A new cool lending pool has launched. It's now offering flash loans of DVD tokens. Wow, and it even includes a really fancy governance mechanism to control it. What could go wrong, right? I think it is clear to us what could go wrong. You start with no DVD tokens in balance, and the pool has 1.5 million. Your objective is to take them all. So let me go through the files also. We have these contracts of interest, the selfie pool, the simple governance file. These two are inside this folder. Here, the selfie folder. And of course, in the test file, we have this selfie file. So let me first go through this file. So token initial supply, they are assuming 2 million tokens. Out of these 2 million tokens, they give 1.5 million to the pool. Fine, so 2 million tokens and 1.5 will go in the pool. So we are getting our signers like normal. Now instead of taking damn valuable token, we are taking damn valuable token snapshot, which is basically our normal token with the snapshot capabilities. Like if we have this damn valuable token which we were using initially, where to the deployer this message.sender, I mean to the caller message.sender, these many tokens were being minted. Now we have this token snapshot whereby you give the initial supply, and to the caller they will mint these many tokens. This initial supply will go to the deployer. Fine. So fine. Now deploying for the simple governance and the selfie pool. Now this dot token, they are deploying that token with the initial supply 2 million. Governance is being deployed with this token address. I will also then tell the governance token the token needed to control the governance. Once we will go through this file, it will become clear, is also the same token, this DVD token. Fine. Now this pool is being deployed with two constructor arguments, the token address and the governance address. Now they are transferring this token from the deployer to the pool. Amount is 1.5 million, and they are expecting whether it has reached successfully or not. Here you have to code your exploit, and after that we are expecting the attacker has stolen all these tokens in the pool, and the pool balance is therefore 0. Right? Let's go through this selfie pool contract. So is reentrancy fine? ERC20 snapshot token and simple governance. I mean, this contract name is simple governance, so an instance of that is also here. An event is there. Now modifier only governance, they are using at this function this modifier only governance, the objective being the message.sender has to be the governance. So only governance contract can call a function having this modifier, and here they are placing the function's body. Now in the constructor, as it's taking two arguments, the token address and the governance contracts address. Here is the flash loan function. Before flash loan, let's also see this drain all funds function. So the receiver, they want only governance, only the governance contract should call this drain all funds, and they will tell the address of the receiver. Then basically transferring everything to this receiver, and then they are emitting this event that all the funds has been drained. Next, this flash loan function, you tell the borrow amount, it is non-reentrant. Balance before you find this balance, and the borrow amount has to be less than equal to your balance. Then you are transferring to the message sender, the caller, the borrow amount. You verify that the caller is contract, and therefore you call this function, receive tokens function, in that caller with the two arguments. One is the address of the token, the second being the borrow amount. So that is this part. Then the caller's job, I mean the callee, this function is calling whatever, I mean the message dot sender, which is a contract. So in that contract, it is now the responsibility of the contract to give these funds back, these DVD tokens which it has borrowed. The contract should give it back. Fine. So balance after they check. Now balance after should be greater than equal to balance before. Otherwise, you raise an exception that flash loan hasn't been paid back. With this, I think you understand the working, the semantics of this contract. Let me also go through this damn valuable token snapshot contract. We saw its constructor, right? At any point, if you want to take a snapshot, you call this snapshot function. It is having this variable. Initially, it is having value 0. So to initialize it properly, the snapshot function you call, which is, I mean, here it is getting initialized underscore snapshot, and then this will return the last snapshot ID. So in case you want balance of something at some snapshot, so get balance at last snapshot, you send in the account, and for the last snapshot ID, they are calling this balance of add function. So balance of this address at this snapshot. What is that snapshot? Is this last snapshot ID. Fine. So get total supply at last snapshot. Similarly here, you find the total supply at a particular snapshot, that particular snapshot being this last snapshot ID. Fine. And if I go through this simple governance file, okay, in the constructor part, if you look, it is taking the governance token address, which is our damn valuable token snapshot token. Okay, so they do this simple check, the address should not be 0. Then they initialize to their governance token and make the action counter 1. Governance token state variable is here, and action counter here. So let's look at these functions one by one. Queue action. For the queuing of the action, you give these arguments: address receiver, bytes, I mean this data variable, call data, and the v amount. Basically, if you look at this struct which they have, this governance action struct, it is having this address, this data part, and this v amount. Basically, they plan to invoke this function call with value function. The function name is function call with value. So call part is this, value part is this, and where to whom they are, whose function they are calling, this receiver's function. So that is about this part. Proposed at and executed at will become clear. Let us go through the code. So first they check whether the message.sender has enough votes or not. What is the enough votes criteria? Majority of the votes. That is more than 50%. So uint balance governance token dot get balance at last snapshot. They use that function, get balance at last snapshot. So for a particular account they do this, and then governance token dot get total supply at last snapshot upon, I mean divided by 2. So that is what they want, and they want this balance to be greater than half total supply. So your balance should be this, I mean has enough votes. This account will be that message.sender only. If we go, yeah, here as you can see it is message.sender. So your balance should be greater than half. This half will not be exactly half, as we know it is rounded towards 0. So in case the total supply was say 5, so 5 by 2 is 2, not 2.5. So your balance should be greater than 2. So in that sense it is not exactly majority, but I hope you get the idea. So that is has enough votes. So here they first check, do you have enough votes? fine. If you hack, then the receiver should not be the address of this contract, so cannot queue actions that affect governance. That is what they're saying. Then action id, they put this action counter, so the action counter's job is to have this action id, I mean this variable. So basically when they are emitting this event, and also here, so let us go through that. So since this is a state variable, they have this storage data location, all right, and to this variable, if they are assigning, they are actually assigning to the state variable, so as it is a local storage reference. So to receiver, they have this receiver v amount, they have data, they have, and proposed at the current block timestamp. Then increment the action counter, and they are going to emit the an event. Then an action has been queued with this action id, and the one who has invoked this, I mean queued this action, is this person, this entity message.sender, and then they are returning this action id. Next, you can call this function execute action. It's an external payable. So regarding, they take the action id, so you tell which action id, I mean this function is also returning action id, so you can tell which action id. Now can it be executed? What is the criteria for it to be executed, for a particular action to get executed? We have this can be executed. They get the action, they are copying it to memory. Next, they check whether has he executed. Once, I mean when the action is executed, this executed at will be updated. So if it's not, it will be 0. And other check, they want that 2 days have passed. So I mean if we look at this, action delay in seconds should be 2 days, and we know how, I mean this days is a global variable, which, I mean we have seen that how many seconds it is, we have seen. Now here, so block.timestamp minus action to execute proposed at should be greater than equal to action delay in seconds. Basically block.timestamp, I mean you can, I mean I think this much arithmetic is clear to you, that they are basically checking that 2 days have passed or not. Fine. So if 2 days have passed for this action, I mean, and it has not been executed before, then okay, you get it here in this story, I mean reference, you take a reference, then you update the executed at which with the current block timestamp. Then you, for this receiver, you do this function call with value with whatever the data was and whatever the v amount was. Then you are emitting this event that action has been executed with this action id and this message.sender. And get action delay was just simply returning that state variable. So with this contract is done. They had this comment that an action can only be executed if it's never been executed before and enough time has passed since it was first proposed. So with this, I have explained this selfie pool file, simple governance file, this damn valuable token snapshot file, and the selfie challenge. So try to write its exploit. I'm going to pause the video now. So now I'm going to tell the exploit. It's as such simple. You just need to take the flash loan to get the enough voting power. Just take the whole amount, 1.5 million, which is far above that total balance, total supply, I mean half of that total supply. And then you take the snapshot. Anyone can call this function, so you just call this function snapshot to have the snapshot done. And now the snapshot is also done, and therefore you can encode this drain all funds function as a call data here. Since you have enough voting power also, it will go through, so your action will be queued. Afterwards you just need to wait 2 days to execute it. So that is the whole exploit. I'm going to show its code to you now. So this is the code. I have my attacker contract deployed by attacker, and it takes the constructor arguments, the pool address and the governance address. Token address anyway, the pool will give me. Then I'm invoking this attack start function, and then I'm increasing the EVM time by 2 days, and then I'm calling this attack finish function. Since I don't need to use this anywhere else, I can just put const here, and this is also equally good. And if I look at my attack selfie pool file, this is that file. I have my interface for the simple governance so that I can call the functions thereby easily instead of doing all this function call with signature, this encode with signature. So in the constructor, I take the pool and the governance address, and then attack start is simply calling this flash loan thing, because after getting the funds, we have this receive tokens being invoked, and here I'm getting the token address, so I'm typecasting it to this damn valuable token snapshot. Then I'm taking the snapshot, anyone can take it, and now I am calling this queue action function with the pool address and this all this that, because the receiver thereby is pool, and we want to access this drain all funds address should be the owner's address, so straight away pass it to owner. V amount is 0, we don't need any V amount here. This is the action ID, and then after getting the loan, now it's time to return that loan, since pool is calling that receive tokens function, so message.sender the amount. So that part is done. Now after 2 days, this attack function is being called, which is simply going to execute this action ID which I got here. So let's run this. So I'm running it, yarn run selfie, and it is passing successfully. So with this, we have completed this challenge also. Congrats. Alright, let us now look at this challenge named Compromised. While poking around a web service of one of the most popular DeFi projects in the space, you get a somewhat strange response from their server. And this is a snippet which you are getting. Fine. A related on-chain exchange is selling absurdly overpriced collectibles called DV so damn valuable NFT, now at 999 Ether each. This price is fetched from an on-chain oracle and is based on 3 trusted reporters, namely these. Starting with only 0.1 ETH in balance, you must steal all ETH available in the exchange. So let us go through these contracts. We have these files. If I go here, the trustful oracle initializer, trustful oracle, and this exchange file. So let me first go through this one, trustful oracle initializer. We will call this contract with these variables, the sources, symbols, initial prices, basically the address of those 3 sources, the symbol, the 3 symbols, but they're actually the same symbol, which is DVNFT. Basically the oracle job will be to a particular source for a particular symbol will give the price, right? So the symbol is DVNFT, and the initial price is what the deployer wants of these sources, maybe, but let us first read this only. So new instance of this trustful oracle, which is imported here. This contract, we are initializing it with these sources and this marked as true. We will see what it means. Then oracle dot setup initial prices, these sources, symbols, initial prices, and then they are just emitting an event. So this contract is very small and is done. Now if I open this trustful oracle, this is being initialized with by this contract, right? So now if I go in the constructor part, we gave the sources and then this variable enable initialization. What is happening here? First they check whether the sources length is greater than 0. Then all these sources, they are assigned this role, trusted source role. They are assigned this role, and the contract which called this, which is deploying this contract, has got this initializer role. Fine. So this part is done here, and then we were calling the setup initial prices, which takes these arguments as we saw. Then who can call it? Only the initializer. So what is this only initializer modifier? This thing. So has role initializer role, which the message or sender received when deploying this contract. So that part is, I hope, fine. So only initializer, and in the end they are also revoking that role. So it's done. It's initial thing which is now done. So requires sources dot length to be equal to symbols dot length, and symbols dot length should be equal to prices dot length. So all these three arrays should have the same length. So only allow one symbol price per source. That is the motive. So now going over all these sources, we are setting the price for that source and that symbol and that price. What is this function setup price doing? Let us look at it. Here we have that setup price. So they find the old price, which would be 0 initially, because by default we know the default values of the state variables. And then they are assigning this new price to what? Now we have this prices by source array, which is a multi-dimensional array. So in this 2D array, for a particular source and a particular symbol, we are putting the price. That is the motive. And then we are emitting this event that we have updated the price. And if I also show you this state variable, we have this prices by source. So for a particular address and for the particular symbol, we have the price, right? All right. Okay. If we continue reading, we did this setup price, and this function also I went through. Let's also look at other functions that we have. One is this post price, basically to update the price. And who can update the price? Only the trusted oracle, the trusted source. So the trusted source, as we know, we had set up this role. So only those sources can invoke this post price function, and they can update the price here. So message.sender, for that dvnft, they can set up the price here. So that is this external function post price. Then how the other contracts will use this oracle to get a price? They will use this get median price. So they will give the symbol dvnft here, and then they will compute the median price. If you remember, if you may know, the median is the middlemost value in an array, right? So in case the array length is odd, then we have a unique middle value. Suppose array length is 3. If I show here array length is 3, then this person, the middle finger, is the middlemost value. And in case we have even number, suppose 4, then we have two middle values, right? These two fingers. And in that case, we take their average. That is how the median is computed. But first of all, the entries should be sorted. So if we look at this compute median price function, here they are going to first source the values, the cost, the values reported by different sources to us, how they do it? Get all prices for a particular symbol they call. And what this get all prices function do, first it finds the number of sources. And if I look at this get number of sources, get role member count trusted source role. So I hope the semantics is clear. We get this function by the contract which we are inheriting from this thing, access control enumerable. So it is helping us with these utilities. So get role member count for a particular source, for the particular role we have got here, right? Yeah. Now we have the number of sources and we create a new array, this prices, having the length this number of sources. Now we need to populate it. So for all the available sources, we get a role member. It is going to return me the address of the source. So I'm saying I want these first, second, third. So index 0, index 1, index 2, like that. And this is helped with this access control enumerable is what is helping us achieve that. So yes, here I was. And then they're just doing this get price by source, which is just using that 2D array to get a particular price for the symbol and source. So this part is done and then they are returning this price array which we found, but this won't be sorted. So they need to sort it here. And this is a simple sorting algorithm. Basically you want to sort the list of numbers. Suppose my list was 3 to 1, right? 3 to 1. Then the output should be 1 to 3 because that is the sorted order. So they have this simple binary sort which is efficient if you have for the input of 3. This is quite efficient. There are other efficient algorithms, but for the input size 3 you can even hard code it, so that's fine. Okay, so where I was, here. Now you have sorted it. Now you want to find the median in case of an odd length, say 3, right? Then we will be inside this else block. This is true for the even. When you divide by 2, the modulo is 0. If you don't know about modulo, just Google about it. So this is that part, but in case my length was 3, then I want the middle value, and the middle value will have index 1, right? 0, 1, 2, middle one is having index 1. But now if I do 3 divided by 2, I will get 1 only because it rounds towards 0. So this is valid. Fine. For the odd is fine. And for the even, you find those two corresponding entries and you take their average. This is how they do. And something funny which I found, like I wanted to show the Google's formula and it appears to me incorrect what the Google is recommending here. You can look at it. If n is odd, then we have this thing. So I wonder what they're doing here. So that is about this. All right. The outside contract will call this function to get the price, and we saw how that price is obtained. So with this, I think I have covered this contract. Yeah, I think I have covered this contract. So these two contracts are done. Next we have this exchange contract, right? Which is the one playing with these NFTs, right? So here the constructor will receive the address of that oracle, this one, the trustful oracle. We will receive its address, this exchange will receive. So that they have put in their oracle variable. Also now they are declaring this new instance of NFT named, assigning to this token variable. Here they are importing this contract, the damn valuable token NFT, and damn valuable NFT. here they have this, I mean, inside the constructor is also initializing the constructor of ERC721 with the NFT name and the NFT ticker, the symbol. Now here they are setting up the role, the default admin role to be of the message.sender, and the minter role also they are assigning it to message.sender. Now basically that exchange will be the one to mint the tokens and also to burn them, right? Mint to a particular address, so they find this token ID, they are using some counter library for that, and then they safe mint to this address a particular token ID, and then they're incrementing their counter. Fine. If I continue here, now the receive function, it's I mean, as such clear what it is. Now we have two functions of interest, the buy one and sell one. For the buy one, somebody will buy the NFT token, and the price as such is 999 ether, if I remember correct. So they will need to send that value, so payable, known reentrant and external. So amount paid in V, message.value, they want it to be greater than 0. So current price in V, they'll ask the oracle for this token dot symbol, which they have, I mean, they have their, which is DV NFT. What is the price? So the oracle will tell the price, right? Then they want the amount that the user is ready to pay should be greater than equal to current price in V. Otherwise, there is an exception. Now they are minting that new token and sending to the user the balance. They just want this current price in way. So the remaining, the user might have paid extra, they are sending it back to the user, right? And then user has also received the token because here message.sender, right? Fine. And then they are returning the token ID. So this is the buy one function. Similarly, we have sell one. To sell NFT, you tell the token ID. First of all, you should be the owner of that token ID. Fine. So token.owner of, I mean, the usual meaning which you can think of, that is the meaning here. We need not see the documentation, I mean, explicitly, but as such in your free time you should. So token.owner of token ID, seller must be the owner. Then what this get approved function does, it tells for a particular token ID who is approved. So we want that this contract, the current contract which we are in, should have received the approval. I mean, if you think about it, in case of ERC20, we had the approval for an amount, right? But here we have a single NFT token, so approval for that. Now this, by default it was 0, so in case it is 0, so nobody, we haven't set anyone to have the right to play with our token. But here we expect that the seller must have approved transfer, so get approved should return the address of this contract, so that this contract can actually transfer this token from the, I mean, the message.sender here. Alright, then they find the current price again using the oracle, and they want now this address, this contract, when you are selling the NFT token, this contract will send you the ether by taking your NFTs. So not enough ETH in balance in case this is not possible. Then token.transfer from message.sender possible as we have the approval to this address and this token ID, and then you are just going to burn this token ID. Fine. Then to this message.sender you are sending this value, the current price in ETH in VE, and then you are emitting this token sold event. So I hope these two functions are clear. And if we go here, so these are the three sources that we have. Then exchange initial ETH balance 9990. This I don't understand. Like, why is the author funding the exchange with Ether? I mean, this is not clear to me. As such, I understand that it is there, so we can exploit it, we can take it back. But what was the motive to put it there in the first place? This is not clear to me. So initial NFT price they are setting as 999, fine. Then we have this before describe, inside this describe block, before hook. So get signers, deploy attacker, fine. Then this exchange, this NFT, Oracle, and this Oracle initializer. Deployed by default it is, so we need not mention. Then they are setting balance of each of these sources to 2 ether. Now you may have doubt, what is this hexadecimal number? Basically it is the representation of 2 into 10 the power 18 in hexadecimal form. Like if I show you also, I have it here. Yeah, 2 into 10 the power 18 is this hex number starting with 1 BC. So now if I go back, so you see 1 BC, so it's that same number only. And next they are expecting whether it is actually equal to 2 ether. Then you are funding the attacker with 0.1 ether. That is the thing. So the attacker as such already had some ether when we do this get signers thing, but they are now setting it to exactly 0.1 ether. And then they're expecting whether it is indeed 0.1 ether. Next again they're using await keyword here, which was not at all needed. So I'm going to remove that, because this attach does not require an await. So we have this await. These array is just dv nft sources, dv nft, initial nft price. You know why we are sending this to Oracle initializer. Next they are getting this Oracle instance from that deployed contract, right? We are using this attach for that purpose. Next, so they are deploying the exchange with this initial balance. It is there for us to exploit, but why it is there, I don't know. And now we have this NFT token, again attaching it to this exchange's NFT instance. Here you have to code your exploit. Then afterwards they expect that all of the ether inside the exchange is stolen. Attackers' ETH balance must have significantly increased. So if they are comparing with exchange initial ETH balance, this plus 0.1 which we funded in the attacker minus some gas costs which the attacker will consume. Next they are expecting that attacker does not own any NFT, and also that the Oracle is reporting that same price, 999 ether. Fine. So with this I assume that I have explained you all the involved contracts, that with this you should be able to write the exploit. So think for some time. The issue which you might face is in the decoding of that here. That is the issue which I think you might face, that you might not know what is this number, and you might have an idea what this could represent. Just think about it. It's fine if you don't understand how to decode it. It's fine, but the intuition should be there. You should have the, since we have seen all the involved contracts, you should at least have a strong guess of what this could represent. The exploit as such should be evident, that if these things represent that, then whatever I think the exploit should be clear. So I'm going to pause this video now. Think about it. Okay, so this, I'm now telling the solution part. What is this number? Let me first try to decode it for you, and then you can think again. Then again I will pause the video. So let's try decoding it. Right. Now this is the low level data that is being passed. If I'm sending you numbers, I'm sending you 2, 5, 6, whatever the numbers. We know that numbers have the binary representation, and that binary representation is what is getting sent. and they're using 1 byte to represent 2 hexadecimal characters. Similarly, if I'm sending you a string of characters, we know they have their ASCII representation. Suppose I'm sending you letter A, then the letter A has some ASCII representation. It will take a byte, and that byte will be representable with 2 hexadecimal characters, right? So similarly, we have this low level data. So first, let us find their corresponding string. Here I am in this website, online string tools convert bytes to string. I have pasted that bytes, and I have received the corresponding string. Next, the second issue is when we are actually sending messages, there is a popular encoding which is using the power of 2, base 64 encoding. Why base 64 and what is base 64? When I'm covering the exploit, I have a good links which you can refer to understand about base 64, like what is its use, etc. So let me just use base 64 decoder to decode this string. Now I am in this side, base 64 decode. I have pasted that string, and this is the output which I am getting. Does it look any similar and familiar? So try to do this with that other data also. And this is where I'm going to pause the video once again, think about the exploit, and then I'll resume. Alright, now I have resumed this video and I'll be telling the exploit. I hope that you were able to solve this challenge. For me personally, when I was solving this challenge, I did not knew how to decode this, but it was quite clear from the name of the challenge that these will be the private keys of those two. I mean, we have 3 sources, right? If we control one of the source, we won't be able to modify the price, because if we make the price 0 or say a large number, in either case it won't be the middlemost. So we need to control at least 2. So it was quite clear that this will represent the private keys, but I personally did not knew how to decode it, so I needed some help there. And now we have these 2 private keys. So the solution is simple. You just use that, we had this post price method. Just a second. In this oracle, we had this post price which a source can invoke. So now you use that post price to make the price 0. Buy the NFT for say 1V, just 1V, because it demands to be greater than 0, right? After you have bought it for 1V, then again post price to that 9990, the max available price, and then just sell it for that price. In that way you have drained the whole of that pool, right? So you will be buying for 0 because the 2 oracles will post 0, although you will need to send at least some amount. So you can send 1V, but it will get refunded to you back, so that's fine. And then you can just sell for the very large value, this 9990 value you can send to effectively drain the pool. So now if I go over my exploit, this is what it is. So we have these 2 private keys. I have told you how to get the original message in case you are reading this from the repo. Also, I have provided these 2 good links which I personally saw to understand about base 64, what it is and why it is, and why we have it, I mean. Then we have these 2 private keys. Now, how to get a wallet? From the private key we can get public key, but not vice versa. And how do we create a wallet? This ethers has the function. You provide the PKA and this ethers.provider. So that is the address that you will get. Similarly, this is the address. So you can see it corresponds to which of the wallets. Fine. then this dot oracle dot connect source है, you post the price as 0. This is what I'm doing for both these sources, and then I'm just going to buy one. I'm going to buy one, and I'm going to send 1V, a very small amount, 1V. You can send any amount because as such it is going to get refunded to you back. So it doesn't matter in that sense. I mean, I hope that you remember that they are sending the remaining, and the current price will be 0. Fine. Now I want this token ID which it is returning. I want this token ID. But the issue is I can't just do constant token ID equal to this. Why? You can read this link which I have provided, and the message is, since a state changing non-constant function can take a non-trivial amount of time to mine, the response is a transaction and cannot return values directly. Using events, we can simulate a return value from a non-constant function. Fine. And how do I listen? I mean, how do I get the event? I just do this by tx dot wait. I'm gonna wait. Once the transaction has gone through, I'm gonna get the event uh, using this events dot pop. So first, let me just log the event part in this receipt. As such, we have worked with events, but why I'm doing this event dot pop? Because there might be multiple events. So usually, if I look at here, I can see my event being the last one to get emitted. So usually this will be a list of events, an array of events, and you will, even if it's a single event, even in that case it will be a list of that single event. So you use the pop to get the last element. Even if it is single, you will get that single element out. And here actually we have two events. Let me just show that to you. So I'm saving it in my terminal. I'm gonna run this yarn run compromised, and I console log that event part. You can see it's an array containing these two objects. One is this one, and the second is this one. So these two events it got. My event is here, token bot 1, but what is that other one? Fine. That other one is actually being emitted by that safe mint. We had this inside this exchange, we were using this safe mint, right? And if we go very deep, we had this safe mint here which was calling this internal function safe mint, and I go inside very deep. Inside that safe mint will somehow we will reach this function, and here I am having this transfer event being emitted. So that is that other event, and if you take its kachak hash, kachak 256 hash, you will see that it is indeed this 0xdd. What is what? If you look at the terminal, the first topic is 0xdd. So I hope that part is clear. So using that, now why I'm taking this? To get the token ID. So this is how you can do it. To that receipt dot args dot token ID. If you look here, we had these arguments, right? They exist in two ways. Either you can do args dot token ID, or you can take this, the first index. So zero index, first index. So these two options that you ethers provide us. So either you can do this args dot token ID, or you can do this args1. So that is what I wrote, or args1, like here. So we have the token ID. We need it to sell it. Now I'm updating the oracle price using these two sources as the 9990 ether, the exchange initial ETH balance. Fine. And then I'm going to sell this NFT which I got. I have now drained everything funds, but since the check wants that oracle should report 999 ether price, I'm updating it to 999 ether. So this is the test, and I have run through it also, and you have seen that it was getting passed here successfully. So with this challenge is also done. Congrats in making it this far. One more thing which I wanted to say, we got the event from our receipt, right? This is how we got it. But actually, there is a way to listen to a particular event. But it has few caveats as such. So I suggest you to visit these links to understand about how to listen to events in a way that works fine with Hardhat. So kindly refer to these links here. Let us now do this challenge. Challenge 8 Puppet. There is a huge lending pool borrowing damn valuable tokens where you first need to deposit twice the borrow amount in ETH as collateral. Not actually borrow amount, you can say borrow value. The pool currently has 100,000 DVT tokens in liquidity. There is a DVT market opened in an Uniswap V1 exchange currently with 10 ethers and 10 DVT tokens in liquidity. Starting with 25 ether and 1000 DVT tokens in balance, you must steal all tokens from the lending pool. So that is the challenge. Let us also look at the challenge file. So the two files of interest is this puppet.challenge.js and puppetpool.sol. Now let us first understand about this Uniswap v1, the portion relevant for us. Let us go through this example. I feel that by going through this example, the concept will become clear, right? Suppose we have 10 ethers and 500 OMG tokens in a liquidity pool. So these are deposited into a smart contract by liquidity providers. People like you and me can deposit tokens, and in total the pool currently has 10 ethers and 500 OMG tokens. An invariant is automatically set such that this ETH pool into OMG pool is equals to this invariant. Basically, we have this 500 OMG tokens, 10 ETH tokens. If we now multiply them, we get 5000. So that is the invariant. Now, if somebody deposits ETH to take out some value of OMG, the new, let us go through this example. I think then it will make more sense. So ETH pool 10, OMG pool 50, invariant is set to this 10 into 500 equals to 5000. An OMG buyer sends 1 ETH to the contract, a 0.25 percentage fee. Actually, it is 0.3 if you read. This example uses a fee of 0.25%. The real Uniswap contract has a fee of 0.3%. But for the sake of this example, let's continue with 0.25 percentage fee is taken out for the liquidity providers, and the remaining 0.9975 ETH is added to the ETH pool. So the user was depositing 1 ETH, but for the process of getting the OMG tokens, etc., only 0.9975 ETH will be added to the ETH pool. As from the input tokens, this input token being Ethereum, Ether token, Ether coin, whatever, they have taken 0.25 percentage cut. So what is remaining is 0.9975, and this cut is taken from the input only. If you were depositing OMG, then 0.25 percentage will be taken from that OMG. Fine. Next, the invariant is divided by the new amount of ETH in the liquidity pool to determine the new size of OMG pool. The remaining OMG is sent to the buyer. So buyer sends 1 ETH and 0.25% is taken. So this is actually not 500, it is 400. There is a mistake done by them. So the value deposited is this 10 plus 1 minus fee equals to 10 plus 10.9975. So this ETH pool into the OMG pool should be the same, this invariant. Fine. So now to determine what this OMG will be, you divide this invariant by this ETH pool. So you do this 5000 divided by this and you get 454. So this is the new OMG pool. That means the buyer has taken 500 minus this 454.65, that is 45.35. Fine. Now, by the way, this is not actually 454.65. If you do this 5000 minus 10.9975, you will get, let me do that also, you will get this 454.64. I mean, it does not end here, it's a continuing decimal, so even after this 15 there are many digits, so they have just rounded it. Now here is a little catch. This invariant, although we call it invariant, is not actually invariant because the fee which we took, right, now it is added back into the liquidity pool, which acts as a payout to liquidity providers that is collected when liquidity is removed from the market. Ignoring this part, just remember that it is added back to the liquidity pool. Since the fee is added after price calculation, the invariant increases slightly after every trade, making the system profitable for liquidity providers. In fact, what the invariant really represents is ETH pool into OMG pool at the end of the previous trade. So, for the end of this trade, the invariant becomes ETH pool. They have added that fee back, so this now becomes 11. OMG pool is as it is, that continuing decimal which I told. Therefore, the new invariant is this 11 into this. So, from 5000 it increased slightly, right? 5001. So, I hope how the Uniswap works in this sense. We call it the automated market maker. So, I hope this part is clear. Now, if I also go through these files, notice that the price which I am getting, suppose in this Uniswap pool which you have seen, this pair thing, the price I am getting is dependent upon the size, right? The inputs, suppose I am sending in token A in the pool to get token B, then what is the price I will get for the token B depends upon the amount of tokens that I am selling into the pool, as we saw in that constant, I mean this automated market maker model. So let me explain this function before jumping to this puppet pool.sol file, so that that Uniswap thing is clear to us. So this function calculates how much ETH in V Uniswap will pay for the given amount of tokens. That is, we are selling these DVD tokens to get ETH. This comment is, by the way, added by me. So we are selling DVD tokens to get ETH, and we want to know how much ETH we will get. Now it depends upon how many tokens we are selling, right? Assuming that x comma y represents the amount of token A comma B in pool, here A will be DVD and B will be ETH, but this is a general example that I am taking. We have this, we are selling delta x to get delta y tokens. So the new amount of y tokens will be y minus delta y, and new amount of x will be x plus delta x. Actually not this, but this thing, as we saw, that is not x plus delta x, but x plus 0.997 delta x. Why? To accommodate for the fees. So that is the seller sells delta x tokens of A to buy delta y tokens of B, but if we accommodate fees, this gets modified to this, right? This is the previous invariant xy and the new one here. I mean, we are using this to get the delta y. I have given the link here also of that Uniswap V1 white paper, and their example has a slight error. I told about this. So delta y, if you use this formula, you can get that delta y is equals to this y minus xy divided by this x plus 0.997 delta x, which is equals to 0.997 into delta x into y divided by x plus 0.997 delta x. This you can see, right? So if we look at, so this function that they have is also doing the same thing, 0.997 into delta x into y divided by x plus 0.997 delta x. So in the end this division part is there. Since we are dealing with big numbers, that is why we are having this dot mul dot div methods dot add instead of simply doing that divide etc or plus symbol for the add. So for this div, what you want here is this. Notice this part. So what this is doing, token sold is that delta x, where it is, this is token sold. So we need to do token sold dot multiply 0.997, and instead of dealing with decimals, they have further simplified it to, if I write here this formula, if I write this is 997 divided by this 1 2 3, this 1000, so that gets here, yeah. So that is the modifications which they did. So instead of multiplying with 0.997, they are multiplying with 997. That's this part, and this is added to this 1000x. So tokens in reserve, which is this x is this tokens in reserve. To that they multiplied this 1000, and then to this whole thing they added this number which I told. So that finishes the divide part, and for the upper part it is simply 997 into token sold into this y, which is ether in reserve. So token sold multiply 997 multiply by ether in reserve. So I hope this function is clear, and with this the Uniswap part is also clear. So in this example, the new invariant will be this x plus delta x, putting that fees back, and y minus delta y, and not this not 0.997, since we are putting the fees back. So for the next time, this will be the invariant. So with this, I think the Uniswap part is clear. Let me now explain this function. I mean this contract, puppet pool contract. So reentrancy card, they're doing all that. In the constructor part, they are taking the token address of the damn valuable token and addressing and putting it, assigning it here to this token variable. Then we have this Uniswap address also passed in the constructor for this pair, right? Next, they have this borrow function. This is not the loan. This is not like the flash loan where you have to put the loan back. Here you are borrowing something by giving the collateral also. So that is the difference. So here you are giving the collateral, so you can keep what you borrowed. If you want to return, then at that point you will get your collateral back, and you will need to give the amount, obviously. So but that is not implemented. That redeem etc. is not implemented here, not of our interest. So borrow, you tell how much you want to borrow, then they will calculate the deposit required, which should be 2 times the value in ETH. So if you look at how they compute this deposit required, you want to borrow the tokens, right? And they will check what is the tokens worth in ether. What is the tokens worth in ether, multiply with how much you want to borrow and take twice of that. Fine. They are dividing by 10 to the power 18. I hope that becomes clear why they are doing it. And this compute oracle price, suppose the pool has 10 ethers and 10 DVD tokens. Pool has 10 ether, 10 DVD tokens. Then how this function, their implementation, is getting the price of DVD tokens by simply dividing that ether divided by DVD. So this dot balance, as we know, balance tells the address is ether balance. So this is dot balance. They are dividing it by this, the tokens balance in that Uniswap pair pool, right? So how much is the token balance in that Uniswap pair pool? So if the pool contains 10 ether and 10 DVD tokens, this will simply return 1, because this thing is 10 and this thing is also 10. So 10 divided by 10 is 1. I mean this part, I mean you know why, because 1 ether is 10 to the power 18 y. So this is done. Then they require that the amount of ether that you are sending should be greater than equal to the deposit required. And if you are sending strictly more than that, then they are refunding you the remaining amount. So they are also maintaining how much a particular user has deposited in this table, I mean in this state variable. Then they are transferring you the borrow amount. Fine. Once they have transferred you the borrow amount, they are emitting this event, this borrowed event. So with this, I hope you have understood this Puppet pool file. Now if we go back to understanding this challenge file, so we have this describe thing. So Uniswap initial token reserve 10, initial ETH reserve 10 ethers. Wait a second. Yeah. Attackers initial token reserve 1000. So attacker starts with 1000 of these DVD tokens and 25 ethers. Pool initial token balance is this 100,000 DVD tokens. Then they have this before block. First, let us also read this after. So in the end, they expect that the lending pool is tokens balance, DVD tokens balance has been reduced to 0. So attacker has taken all tokens from the pool, and the attackers now balance of DVD tokens is greater than the pool's initial DVD tokens, that is greater than 100,000. So to be greater than 100,000. Fine. It block is where you will have to code your exploit. And I hope with this as such it is clear, but let us also quickly go through this before block. So this is for that Uniswap exchange factory. They are getting its bytecode from here in these required files. So that is how they get the ABI bytecode, and that is how they get the contract factory. So exchange factory, DVD token factory, puppet pool factory, and then they are setting this balance. I have told you that they are just putting the corresponding hexadecimal value, and they are setting it to 25 ether, this attacker, and they are just checking whether it has actually gone through successfully. Then deploy this token. Also, with regard to this problem, you might need to go through this file when you are implementing your exploit. Go to this file and see try to figure out the relevant functions. Also, if you want to read more about this factory exchange, what are these, you can read here. Okay. So where were we? They are deploying this exchange, deploying this factory. Then, okay, initialize factory with this exchange template. Then they are creating an exchange for this token, and they are setting the gas limit. Usually, like every transaction, you know that it has to, the bytecodes, the operations consume gas, right? So if we set the gas limit in a transaction, and if the transaction exceeds that amount of gas limit, then it will be reverted because we are out of gas. So they are here trying to set the high enough gas so that this operation goes through. Then they are finding the events, and from that events they need this argument thing. You can see what this create exchange needs. So they are having attached to this, the instance is being attached and stored in this Uniswap exchange variable. Then they are deploying this lending pool with this .uniswap exchange address and the token address. You can see in detail if you want to why and what all these functions actually under the hood do, but as such it is not needed if you understand the semantics. For this example, then token.approve you are allowing, because you are sending to this Uniswap pool this amount of tokens, Uniswap initial token reserve, so that is why you are approving it. That's how the Uniswap deals, they will most likely be calling the transfer from. So add liquidity, you tell this is the minimum liquidity which this function will require. You can read about this function in that documentation I just shared. So initial token is what you are going to send. Then this is the deadline which they have put at this value, and then how much in case, by the way, I should also tell this, The Uniswap V1 pools, they are of this form: ETH and ERC20. So one of the pair must be ETH, and second is that ERC20. So to get the ETH, you simply put the value here, Uniswap initial ETH reserve, right? And the tokens you have approved the amount to send. And here also they are putting up the gas limit. Next, they are expecting, okay, the price that they are getting, and they are using this function get token to ETH input price. So for that token, this one, they are checking the ETH price and whether it matches with their function here. Fine. And then set up initial token balances of pool and an attacker account. So that is what these two are doing. I think it is pretty self-evident. Then ensure correct setup of pool. For example, to borrow 1, need to deposit 2. Initially, since the pool has 10 ethers and 10 DVD tokens, this 1-to-1 is getting matched. But if it changes, then it won't match. So expect, yeah, I think this to calculate deposit, again they are calling. Yeah, fine, almost the same thing. So with this, I think you have understood the files. You will need to go over this to play with Uniswap and understand better. So with this, I am pausing the video here. Next, I will tell the solution. Alright, the exploit is very simple. Looking at the pool size and your size, it is it's very much clear. What you can do is you can sell all of your DVD tokens in this pool, and that will make this, and you in return you will get the ETH. Fine. Now the pool will be very much imbalanced. There will be very little ETH and a large amount of DVD tokens. So the price of one DVD token will be very much little in value for ETH. So one DVD token will be worth very little ETH. And if you want to know the exact amount before carrying the exploit, first of all, this is what I am doing. I have approved, I plan to sell all of my DVD tokens. So I have approved the Uniswap exchange this much amount, all of the tokens. Now, this is the function I am using, token to ETH swap input. If we look at its documentation, token to ETH swap input. So message dot value fine, which is the amount of ETH you are selling. Sorry, this is not what I plan. Token to ETH I want. Yeah, token to ETH swap input. There comes in two flavor. One is input, one is output. We will see their differences. I have used them both in my example. So token to ETH swap input, it takes this parameter token sold, which is the amount of ERC tokens that you are selling. Then minimum ETH, the minimum amount of ETH you want to get, otherwise reject. Then the deadline, transaction deadline. So actually, according to the formula, if I am selling 1000 DVD tokens in that pool having 10 ETH, 10 DVD tokens, I should get these many ether, 9.90069. This amount of ether I should get. You can work out that formula. You can use that formula and get this same value too. So that is why I have put my minimum 9.9. As such, there is no need because it will pass as such the transaction. So this is the deadline and the gas limit. Fine. We are waiting for this transaction to go through, and then we are finding the ETH bot. They will have an event which will tell you the argument. One of the argument will be this ETH bot. So I'm just using that. And I'm also logging this to the console so that you can verify that indeed it is this value 9.9. So here I'm running that command yarn run puppet, and yes, ETH bot, if you notice 9.900699513. So this 69513 matches here. So yeah, that formula is working correctly. And with this, I think you will have received further clarity about this Uniswap. And then the attacker's balance now will be this 25 plus the ETH bot minus the gas fees which anything spent. So this will be the attacker's balance now. Now ETH required to get all tokens from the pool is what I'm logging. So I'm calling their calculate deposit required method. And if I do that, I can see to get all the tokens from the pool, I just need to deposit this 19.664, which you with your hand calculations, I mean you can use calculator also to determine this. So we just need only around 19, I mean 19.9 something whatever. So I'm putting the 20 here. I'm borrowing the complete amount. I'm putting the 20. They're anyways refunding me my little ETH which will remain. Now as such we are done here. We are done as such. But the thing is, I would have got all these tokens from the pool. But here they want my token balance to be strictly greater than this. Not GTE, I mean not greater than equal to, but strictly greater than pool initial token balance. So let's use that Uniswap pool to buy one token. I anyway have this much amount. I need only one more. And this is where I will also illustrate this output method. So ETH to token swap output. So maybe okay. So what are the parameters that this is taking? Message value will tell the maximum amount of ETH sold, and here this is the of interest tokens bought. You can actually tell that I want to buy these many tokens. So that is what I have done here. I am telling them exactly that I just want one token. Fine. Although I am sending one ether, but I will get the my I mean, not exactly one ether will be used, very little to get this one extra. I mean, this one DVD token. So I should also log this, my balance. We have seen this balance of mine. Here we have deposited some ether, so some will be lost. So after borrow function, this will be my balance, and wait a second. Yeah, let me just, so to save time I have written this already. So attackers ETH balance after calling the borrow function, that is what I am logging here. Then after we have done buying this one more extra DVD tokens, so attacker ETH balance after buying one more DVD tokens. Although we are sending here one ether, I want to show that not whole of this one ether will be consumed, actually very little. So if I go to my terminal and type this yarn run puppet, you can see that attacker ETH balance after calling borrow function is this much, and after buying one more token, very slight decrease. So not one ether has been taken. So I hope now this challenge is very much clear, and with this we have completed this challenge. Congrats. Now let us look at this challenge, Puppet V2. The developers of the last lending pool are saying that they've learned the lesson and just released a new version. Now they're using a Uniswap V2 exchange as a price oracle along with the recommended utility libraries. That should be enough. You start with 20 ETH and 10,000 DVD tokens in balance. The new lending pool has a million DVD tokens in balance. You know what to do. You have to steal all the million DVD tokens inside the lending pool. And if I go through the files, we have two files of interest, Puppet V2 pool and Puppet V2 challenge.js. So in this file, it is roughly the same. By the way, regarding this Uniswap v2, since in the challenge 10, the next challenge, we will also be using this Uniswap v2, I think it would be better that you read this article. What is the difference between Uniswap v1 and v2? No need for this v3, v1, v2. Just read through this article before before attempting this problem. As such, also it will be useful when doing that next challenge, the free rider one. And in this link, this Uniswap protocol v2 reference smart contracts router 2, you have the functions which you might need to use for this challenge. Moving on, you will see that when you will read that article from Hackernoon, you will see that we use WETH. Previously, we were using ETH with ERC20. Now we use WETH. Also, there are some additional functionalities Uniswap v2 provides. You can just read that. So token address, Uniswap pair address, Uniswap factory address, fine. Then borrow. So the borrow amount should be less than equal to your balance of tokens. So fine. Deposit of WETH required. Calculate deposit of WETH required, just like last time. So this calculate deposit of WETH required. Now they are multiplying by 3. Previously it was twice, now it is thrice. And get oracle quote is this function. So reserves ETH, reserves token from this Uniswap v2 library. They are getting the get reserves function, and they are passing this factory address. Where was it? By the way, v2 library is important here. And the reserves address, yeah, here. Oh wait, Uniswap factory, right? Let me see where it is. Yeah, here, and where it is initialized inside the constructor. You put the address of WETH and the token, get the reserves, and then again in this library use this quote method. The amount which you want to borrow, putting the whole amount, so 10 to the power 18, the reserves token and the reserves WETH. Previously, in the previous challenge that we did, we basically did this normal division, this WETH divided by token, ETH divided by token is what we did in the previous problem. And if I look what this code function actually does under the hood, so these are the contracts. Here also they are doing that same thing, that ETH divided by token, and just multiplying with how much amount you want. So I don't see any difference here with regard to that. So okay, you found it, the deposit required, then you're doing this transfer. So approval would be needed since we are using transfer from function. Sending to message Ether the deposit amount, and here we are doing this internal accounting in their own state variable, and then they are doing this actual transfer of this borrow amount, and then they are just emitting the event. Fine. Here, since they themselves are taking the WETH, the required WETH of the exact this much amount, so no need for any refund. Previous problem we had a refund. So this completes this Solidity file. Next we have this challenge.js file. So Uniswap initial token balance is 100 and WETH balance is 10. Previously in previous problem it was 1010, now it's 1000. Attacker initial token balance 10,000. Pool initial token balance is 1 million DVT tokens. So this before thing is there, setting the attacker's balance of ETH 20, and then they are checking whether it is actually 20. Then all this Uniswap stuff is there. This WETH 9 the author has written here. If you go in the contracts folder, they have this weth9 file here, so they're getting it from there. Then okay, all this is fine. So approve, okay, to the Uniswap they're approving the initial token reserve, because then the transfer from will happen. So adding liquidity, the initial token that they want, and the value, that is how they are sending the weth, just like we normally do. So they have put this 0 minimum amount, need not bother. Deploy address fine, then the deadline, getting the exchange from the factory, all that is fine. And then deploying the lending pool with all the constructor arguments that we saw, then transferring to the attacker its token balance, and to the pool the pool's balance. Then they are just doing some further checks. Calculate deposit of weth required for this one DVD token, and they are checking it to be equal to 0.3. If we look at the pool setup, we have this. They have not mentioned here. Here they have mentioned in the beginning. So 10 weth is there for 100 DVD tokens. That means the price of one DVD token will be 0.1 weth, right? 10 divided by 100, 0.1. So 0.1 into 3, 0.3. So that is what they did over here. Then expect, await, calculate deposit of weth required. Yeah, the same thing they have done, just scaled it a bit. Now here you have to write your exploit. Then await part, this after part is there. Expecting that the pool balance has now been 0, the tokens inside it, and you have greater than equal to, finally they have made it GTE, the pool initial token balance. So at least you have this much. Fine. I think with this we have covered these two files. Try writing its exploit, and you can refer here in case you need any support of some functions, and also read this article as I told. So I'm pausing this video here. Alright, now we will be working through the exploit. As such, there is nothing new in this challenge. My assumption here is that since the challenge 10 requires Uniswap v2, therefore the author introduced Uniswap v2 in this challenge. Personally, I don't see anything new compared to challenge 8 here. So just like the last challenge, sell all of your DVD tokens in this pool to get the price down, and then just borrow. So same thing we have to do here. If I go through the code, this is the code I wrote. So we are approving our initial token balance, which I plan to sell. I have shared the link here, and just like the last problem, we are expected to get that same ETH 9.900695, same amount. Although there is a difference in fee, total fees is still 0.3%, just that there is also 0.05 protocol fee, and the LP's cut has been reduced to 0.25%. I have also shared this link for the function of this function, swap exact tokens for ETH. These are the tokens I want to swap. Here I am telling the minimum desired. The path, we also give the path. So from this DVD token to this weth, 2 is me. I want to have this sent. It can be anything, but since I want into attacker's wallet, so attacker is here. Then deadline and the gas limit. You can also read about this swap exact tokens for ETH here. You can read about it here. Alright, so okay. Then just getting the receipt of it. Also I'm logging the how much of the ether I bought. So in the events part, popping the last part, getting the data of that event, and then ABI decoding that for this uint type. Fine. Also, when I decode it, I will have a list having this single element uint. So I'm having 0 index here, and then I'm just formatting it. Also, I'm logging the attacker's balance. So since we bought around 9.9, so 20 plus 9.9 should be around 29.9. Next, I am approving the lending pool to transfer all of my WETH. Although here I have received ETH, not WETH. So I will also be converting my ETH to WETH here. Maybe it's better that I put it above. Won't change anything, but it would become more clear. So I am depositing from my ether. Basically, I'm wrapping my ether to wrapped ether. How much amount? So to determine that, I'm calling this lending pools function calculate deposit of WETH required. Fine, it should be around 29.5 if you do the calculations. This part is done. Then I'm also approving the lending pool to be able to call this transfer from of this much amount. Fine. Actually, I have approved it through all of my balance, but my balance has now changed. So I just put this here. Earlier this line was at above and I approved for the whole of the balance, but now since it is below, I will approve for the appropriate balance, which is that same amount that I got here. Or better yet, I do this dot balance of attacker address to save some time complexity. Alright, then I'm logging the attacker's balance after this deposit. So from this 29.9, around 29.5 will be taken. So just to verify that. And then finally, I'm calling this borrow function. Fine. So this is what I have done. And if I run this, we get all these outputs. So amount received is exactly that 9.900691513. The attacker's balance is this, and after deposit it becomes 0.40384. So with this challenge is also done. Congrats. Alright, let us now look at this challenge, free rider. Always pay attention to the names. Like in last problem, the pool was our puppet. We were able to dictate the price. So pay attention to the name. Regarding this challenge, the description is a new marketplace of damn valuable NFTs has been released. There's been an initial mint of 6 NFTs which are available for sale in the marketplace, each one at 15 ETH. So total 6 into 15 is 90 ETH. A buyer has shared with you a secret alpha. The marketplace is vulnerable and all tokens can be taken. Yet, the buyer doesn't know how to do it. So, it's offering a payout of 45 ETH for whoever is willing to take the NFTs out and send them their way. You want to build some reputation with this buyer, so you have agreed with the plan. Sadly, you only have zero point 0.5 Ether in balance. If only there was a place where you could get a free ETH, at least for an instance. So, flash loans. Now, before going over the smart contracts, etc., involved, maybe it is better that you pause the video now and try to solve it now itself. Try to solve yourself, because when I'm explaining the contracts, I may give out the answer. I will try not to, but it might happen. You, when reading the contracts, might not pay attention to it, but when I am explaining, then it might, you know, it might ring a bell in your head when I'm explaining. So that's up to you. You can either pause now or continue. So continuing further, Let us look at the contracts etc. involved. This is the marketplace. Here they have this constructor. The deployer will send the amount to mint, which will be 6. In this free rider challenge, you will see they will send the amount to be 6 when deploying this. We will see that it should be here. Yes, here it is. So they are sending this amount of NFTs which will be 6, and they're also sending some value. I personally don't understand why they are sending this. The value which they are sending is 90 ether. I don't understand why they are doing it in the first place. I understand that it is there so that we can steal it, but what was their motive? Not clear to me. And this value marketplace initially ETH balance, if I show you, here you have it as 90 ETH, and amount of NFTs is 6. Fine. So if we go here, they get 90 ether due to this payable, and this is 6. Then they are instantiating the new instance of this contract, damn valuable NFT. Here they are importing it, and then they are just minting. And who will be the owner of that NFT? This message.sender, so the deployer of this contract. Fine. So this part is done. Constructor. Next, they will call this offer many function with the token IDs, which will be 0, 1, 2, 3, 4, 5, total 6, and the prices which they want to set as 15 ether. If we go here, we were in line 91, and here offer many, they are calling this. Also, we have this function set approval for all. What this function does, what it is doing, for all the tokens, this guy, this dot marketplace dot address has the right to transfer them. And whose tokens? The caller, the message dot sender. By default, we know it is the deployer. So deployer is calling this set approval for all and making this address to have the right to transfer all of the tokens on behalf of this message or sender, the deployer. That is done. And then we have this offer many. So if we go here, offer many, they took the token IDs and they took the prices, which was 15 ETH. Here you can see this is the array containing 6 elements, each being NFT price. And what is this NFT price? Here, this line. So 15 ETH. Fine. So here we are in this function offer many. So for all these elements, they are calling this offer one function. First they check their length is same. Fine. And in this offer one function, price has to be greater than 0. The message dot sender has to be the owner of that token. And then they are checking, since we have, there are 2 checks here, and if any of them, we have this or, so any of them passes, then we are done. So get approved, what it does, that for a particular token ID, does this guy address, this contract, does it have right to transfer it? Fine. And what this is checking, that for all token IDs, for all possible token IDs, thus it has right to transfer it for message.sender. And since we have given it the right for this, both of them are true. Alright, so we move on to the next line. By the way, for each of these functions, if you want to read their description, you can see ERC 721 standard in OpenZeppelin. Here I have this set approval for all, which we did. Sets or unsets the approval for a given operator. An operator is allowed to transfer all the tokens of the sender on their behalf. And then this is approved for all tells whether an operator is approved by a given owner. We took this this address of the owner. And what was this? Get approved, right? And if I search for it, oh, here it is only. Get approves gets the approved address for a token ID, or 0 if no address is set, reverts if the token ID does not exist. So I hope these functions part is clear. And then they are setting this state variable offers for a token ID, setting the price and incrementing this and amount of offers variable, and then they are emitting an event. Only message.sender is allowed to create an offer here. So this was this offer function. Fine. Now we have seen the constructor, the offer many, and the offer one function. Now in case somebody wants to buy these NFTs, right, then they can give the token IDs array. So for the token IDs dot length, they call this buy one function, and inside this buy one function they first find the price and they require the price to be greater than 0, otherwise the token is not being offered. Your message dot value should be greater than or equal to this price to pay. Then they decrement this amount of offers, and then they transfer this token from the owner to you, and for this token ID. Then they pay the owner of the token this price to pay, and then they are emitting this event. Fine. So with this we have seen this and free rider NFT marketplace contract. Next we have this buyer contract. So in this constructor it will take the partner, which will be the attacker's address. So attacker address, the NFT address, and this is payable. So they require that at least you pay 45 ether, because that is what the buyer will transfer to the attacker in the end. So partner is the attacker. They are they are typecasting this NFT address to its ERC721 interface so that they can call function. Then set approval for all message.sender, which will be the, you can call it buyer. So buyer will be deploying this contract. So message.sender will be buyer, and therefore buyer has the right to transfer the tokens of this contract. Fine. Then regarding this, we have just one more function here and nothing else. This function is what we have. You can read about it in this link, or even otherwise we have it here. If you notice this save transfer from function, safely transfer the ownership of a given token ID to another address. If the target address is a contract, it must implement this on ERC721 received function, which is called upon by this save transfer, and return the magic value. So it must return this magic value. Otherwise the transfer is reverted. Requires the message.sender to be the owner and other things. So here they are also returning that, and using this part here they are able to return this. This is inbuilt and they are able to return this here. And the additional code that the author of this contract is doing. So require message.sender is address NFT, transaction origin, the partner. We also have this global variable tx.origin. You can look it up in that Solidity documentation. But also it must be used with caution. If you read the security practices, the security consideration in the Solidity documentation, you will see that. So token ID should be in the valid range, and the owner of the token ID should be this address. They are incrementing this received. Once this received is equal to 6, then you pay the partner the job payout, that is 45 ether. Fine. So with this contract is done. Moving on to this free rider challenge. This we saw NFT price 15 ether, amount of NFT is 6. Marketplace initial ETH balance, they are funding it with 90 ether. Buyers payout 45 ether. And we have this Uniswap pool here having the initial tokens as 15,000 and initial WETH reserve as 9,000. Fine. And there is your balance also. Attacker has this 0.5 ether And that's it for the attacker. So this part, WETH9, all this part, making of this Uniswap pair of this token, I mean whatever token, and this WETH pair token is damn valuable token. This part we have seen multiple times, so we need not bother about it. So moving on this, from this line 90, we have also seen this freerider NFT marketplace. I have explained that to you. This part I have explained. Then just some check whether the amount of offers is equal to 6 or not. Then this buyer's contract, they pass in the attacker's address, NFT address, and the value as buyer's payout when constructing this contract. Fine. Here you have to write your exploit, and afterwards they are checking that attacker's balance is greater than the buyer payout, which was 45, and also checking that the buyer contract balance is 0. The buyer extracts all NFTs from its associated contract. So yeah, so from the contract, since the NFTs were transferred to the buyer contract, this contract, and now from this contract the buyer is transferring it to itself. So, and since the approval was there, it can do it. Token ID, right? They do this, and then they're just checking whether they are indeed the owner. So exchange must have lost NFTs and ETH, so amount of offers should be 0, and balance they are checking it to be less than marketplace initial ETH balance. So with this I have explained the associated files. Now try writing its exploit. I'm going to pause the video now. So let us now see the exploit. I wonder when I was telling about the description of the code whether you got it or not. So here is the issue. If we see clearly, they are checking when they are paying to the seller, they are actually paying to the owner of the token, and just here we transfer the ownership of the token from the deployer to this message.sender. So here is the actual issue. We are paying back to, I mean the contract is paying back to the message.sender. So if we run through it, suppose I'm buying these 6 NFTs, but I give my message value as only 15 ether. Then I start here, price to pay is 15. Then this 15 ETH is greater than 0, and message dot value, which is equal to this 15 ether, greater than equal to price dot pay, amount dot offers the decrement. Then they are transferring this token from the owner to the attacker, and then they are paying the attacker to me itself the price. And then we move on to the next element. Same story, the price to pay is 15, that remains, and message dot value is same since this is calling this internal call. So message dot value remains the same, price dot pay, yeah, amount of offers decrementing, again sending and sending me the value. So in total the contract received 15 and sent out 90. So as such the attacker received, you can say 75. I mean the attacker has received 90 only, but 15 it has to pay back to that loan, and therefore the net profit will be 75 and the net loss from the contract will be 75. That is what I wanted to say, that net loss from the contract is 75. So contract will have still 15 ether, not 0 but 15 ether. And now the question remains, how we get this 15 ether to begin this attack, right? From where do we get this 15 ether? Now I asked you to read that Hackadoon article in which they talk about this added functionality of Uniswap v2, the functionality of flash swap from which you can use flash loans. So let us also read about it. This is flash swaps. So a flash swaps are an integral feature of Uniswap v2. In fact, under the hood, all swaps are actually flash swaps only. This means before that pair contracts send output tokens to the recipient before enforcing that enough input tokens have been received. So they first send the output and then later they take the input. I mean, usually you give the output first receiving the payment, but that is not the case here. And why? This is slightly atypical, as one might expect a pair to ensure its received payment before delivery. However, because Ethereum transactions are atomic, we can roll back the entire swap if it turns out that the contract hasn't received enough tokens to make itself whole by the end of the transaction. To see how this all works, let's start by examining the interface of the swap function. So this is the swap function: amount 0 out, amount 1 out, address 2, bytes call data. What is this amount 0 out? So for the sake of example, let's assume that we are dealing with DAI WETH pair, where DAI is the token 0 and WETH is the token 1. DAI token 0, WETH token 1. Amount 0 out and amount 1 out specify the amount of DAI and WETH that the message.sender wants the pair to send to the to address. So in case I put here 100 DAI and say 0 WETH, then I want this pair to send out to me 100 DAI. Fine. One of these amounts may be 0. As such, I said that I don't want any WETH here. I mean, for this example that I'm talking of. At this point, you may be wondering how the contract receives tokens. For a typical non-flash swap, it is actually the responsibility of message.sender to enforce that enough WETH or DAI has already been sent to the pair before swap is called. In the context of trading, this is all handled neatly by a router contract. But when executing a flash swaps, tokens do not need to be sent to the contract before calling swap. Instead, they must be sent from within a callback that triggers on the to address. What is that callback? We will see. To differentiate between a typical trading case and a flash swap case, pairs use the data parameter. Specifically, if data.length equals 0, the contract assumes that payment has already been received and simply transfers the token to the to address. But, and this is what we will use, if data.length is greater than 0, the contract transfers the tokens and then calls the following function on the to address. So this is the function which it will call on the to address: uniswap v2 call address sender uint amount 0 uint amount 1 bytes call data. This address sender is this the swap scholar is the sender, as they will say also. The logic behind this identification strategy is simple. The vast majority of valid flash swap use cases involve interaction with external protocols. The best way to pass information dictating how these interactions happen, function arguments, safety parameters, addresses, etc., is via the data parameter. It's expected that data will be ABI decoded from within Uniswap v2 call. In the rare case where no data is required, our case is that we don't require any data, callers should ensure that data.length is greater than 0 and thus you can make it equal to 1, that is encode a single junk byte as bytes and then ignore this argument in Uniswap v2 call. Pairs call Uniswap v2 call with sender argument set to message.sender of the swap. As I told, amount 0 and amount 1 are simply amount 0 out and amount 1 out in that swap function. So using this Uniswap v2 call, there are several conditions that should be checked in all Uniswap v2 call. However, in our implementation, we need not bother about it. They have this simple check. You can see it, not relevant for us, but as such you can read. The first two lines simply fetch the token addresses from the pair, and the third ensures that message or sender is an actual Uniswap v2 pair address. Yeah, that's fine. Now for the repayment, at the end of Uniswap v2 call, contracts must return enough tokens to the pair to make it whole. So for instance, I am assuming if I am taking 100 DAI tokens and then I must return 100 DAI plus a little bit of amount also. Why? Specifically, this means that the product of the pair reserves after the swap, discounting all tokens, amount sent by 0.3% LP must be greater than before. Basically, just that invariant thing which we discussed. So plus minus that invariant, try to maintain that. Let me just read through the example that I have coded so you can understand. So the concept is very simple. in my this test file, I'm just this is just a simple console.log, nothing is happening here, just checking the balance of the attacker. So attacker starts with these many ETH, and then I'm calling my contract takes these arguments, we will see the contract, and then in the end I'm logging that attacker ends with these much ETH. Fine, it's very simple. Now what is the contract? As I told, we have this attack function here. So in that I have explained this flash swap thing, so that is the comment. So in that attack function, I'm simply calling this swap. I want 15 ethers. I want 15 ethers. 0 of those tokens, they are not of my interest. This is the address, and this is that junk byte. Fine. So now this Uniswap pair will call this Uniswap v2 call. Fine. This address is not relevant to us, so that is why I have not named it. Amount 0, other things are also not relevant, and also I'm not doing any checks here. So weth.withdraw, we have as such here we had this 15 weth, not eth, 15 weth. So now I am withdrawing them to get, basically unwrapping my weth to get ether. So that is the amount 0. Fine. Then, and for this purpose we need to have receive function in our contract, right? Okay, now I'm just populating this token ID 012345. Then console.log, I'm logging the attacker's balance. I mean the attacker contract received this much V after unwrap from Uniswap. That is what I'm logging. Then I'm calling this buy many function and sending the 15 ETH, then token IDs, and this is exactly 15 ETH only. So this is the token IDs passed. Now attacker contracts end with this much V after the NFT. So we end up with 90 ethers. We still have, I mean the contract sent out 90 ethers. Contract received 15, sent out 90, so contracts lost 75 ether. Contract has 15 ether. The marketplace contract has, I just crossed it. So this still has 15 ether. We haven't drained it fully. And we have received this 90 ethers. Now according to the docs, this 0.997 should be accounted. So 15 E18 divided by 0.997. Other parameter of that invariant is remains the same, so we need not bother about it. Therefore, I should deposit at least this much amount. So in below, I mean it's quite tedious to put such a big number. What I have done, I put this, and here notice in below I have put this number, but which works. But if I do this, make this last digit from 5 to 4, then it won't work. So that is something you can try, and therefore this is correct that we need to deposit at least this much amount. So first I am wrapping my ether, then I am transferring this to this Uniswap pair address, balance of, I mean this amount only. So that part is done, and here I'm also calling this, since I am the one who got it, now I'm sending it to the buyer's address, that contract which I received. So to that I'm sending this NFT tokens. Also, since we got these NFT tokens, we need to have this implemented, and all that we went through I've written here also. So just returning this selector thing. So this is done, and once this gets completed, the whole 6 NFT tokens the buyer contract has received, then the buyer will send to the attacker this 45 ether. So when everything is received, so 45 ether the attacker will receive, and he already had 0.5, so 45.5, and also this contract is then sending the remaining 75, around 75 ETH. So this is what this contract does. Also, it is not exactly 75 because here I'm not sending exactly 15. I need to send something higher. So it is almost 75. So this in total should total near to 120.5, and that is something we can see also. So let us run this. So running it now, yarn run freerider. Attacker starts with 0.5 ETH. The contract has received this I mean 15 ether after unwrap from Uniswap, and then attacker contracts ends with 90 ethers. I mean, yeah, after buying the NFTs and the after transferring 75, since 15 has to be paid back, and etc. As I told, we roughly end up with 120.5 ether. So the exploit is done, and with this we have also covered this 10th problem. Congrats in making it this far. Now let me talk a bit about Hardhat. When we were coding about events, we created an Hardhat project. Let us see at the commands which Hardhat provides. We wrote this npx hardhat run etc. to run our scripts. So we use this command. Runs a user defined script after compiling the project. We also have npx hardhat accounts which will print the list of accounts. It will print 20 accounts. If I show you also npx hardhat accounts. So here those 20 accounts. Then clean, which clears the cache and deletes all artifacts. Basically, and when we compile, like if I see this compile command, it compiles the entire project building all artifacts. So clean, we just clean that. Console, you can have a hardhat console. Then here you can write your commands. Then flatten thing is there, flattens and print contracts and their dependencies. There are also some useful plugins in the hardhat which you can use to get more help. Then help will print this message. Node starts a JSON RPC server on top of Hardhat network. In case you know that, you can do that. Run, we have seen. This test command, we have been implicitly using it. You see, if I type here npx hardhat test, right? Then since we created a sample project, they had their own greeter file, etc., to which they are running their own test, right? And if we go to the damn vulnerable DeFi problems that we were doing, like here, we were writing yarn run, and if I open this file, where it is, yeah, package.json, we wrote various files like yarn run unstoppable. So in that also, just like how we had npx hardhat test, they are writing that only. That command, when we do yarn run unstoppable, actually it is writing this yarn hardhat test and the name of the test, I mean the file path. If I don't give any file path, then only test. Otherwise, you can mention the specific test, just like how we were mentioning the specific script. So that is about this test command. Yes, and all these what we have here are known as tasks. You can also create your own task, like here in Visual Studio Code. If I open this file hardhat.config.js, which will be present inside your project root, so here you can see this accounts task which they have mentioned. The description is also there that it prints the list of accounts, and then they have also, the code is just printing all the accounts, first getting all the signers and printing their address, right? So let us create a very, let's just copy paste this and just name it something else so that we can verify that yes, we are able to create our own task. So I'm not changing anything as such here. I just did this simple change just to verify that are we able to create a new task. So if I go back to my terminal and type this npx hardhat help, you can see that something else task is also available to us, and they have a guide explaining how to how to create task. You can visit this link to learn more. Now let us finish this course by deploying a smart contract to the network. We will be deploying to something known as Goerli network. So let me just show that to you. So let's create a folder named sample deploy. So I'm going back to that folder. I'm going into that folder. Now let's run this npx hardhat to initialize it. And just like before, we would want to create a basic sample project. So everything I am hitting as enter. So it's doing its stuff. So let us finish for that. Let us wait. Okay, now it's done. So let me just open this in the Visual Studio Code. So we have all our files here. Let me also show you this page. We will be following this tutorial. Basically, when you visit the Hardhat website, you have this tutorial page where they explain you various things. You can also refer to it. As such, most of the things I have explained, setting up the environment, creating a new Hardhat project, writing, compiling contracts, testing them, we saw. And regarding debugging, we use this console.log statement to print on the console the various arguments, etc. If something, suppose you are getting an unexpected error at some place, then you can try looking at your code and insert these console.log statements where you think an error can occur. For instance, suppose this line is giving you an error somehow. Maybe it was an unsigned integer and you were subtracting and making it negative. So you could just put a console.log statement just before this line and see the various arguments, and then you can, this will help you determine where is the bug. We have also used console.log statements ourselves in the past, so I don't think there will be an issue. This is the one way to debug your smart contracts, and I personally use this only. There are also other ways where you can go line by line in the bytecode and then determine, also look at the memory structure, the stack structure, etc., and then determine. But mostly this console.log part suffices. Next, we have this deploying to a live network, and this is what we will be following. So before going into all that, let us write our smart contract. So inside this contracts folder, I'm going to create a new contract named cat.sol. This smart contract, there won't be much code. I just want to give an idea on deployment part. So this is the contract which I have. Almost everything is similar, and regarding this 0.8.14, so let us also configure our hardhat to be able to use this compiler version. Now that is done. So license identifier, this version, and then I'm using an OpenZeppelin contract. I just want to illustrate here, since in the damnvulnerabledefi problems we were using OpenZeppelin contracts. So how do we use OpenZeppelin contract in our own contract when we are deploying in the network? So just like before, we have this import statement, but we need to install these files. So how do we do that? I am here in this link. This will also be in that description of this. I have shared a GitHub file which will have all these links, right? So I'm just going to copy this and paste it in a terminal here. So let me just paste that here, and then it is going to insert those contracts in my project structure. So it took some time, but now it's done. Moving back to our code. So now we should not have this error. So we are inheriting from this ownable contract, and main purpose we will see. Inside the constructor, I am passing a struct variable. I just want to illustrate how do we pass complex types in the constructor, or for that matter in the any function from outside. So we will see that what I mean. So I have this cat details struct, this cat details. It is having a name. Basically it stores the description about the cat. So the name of the cat, its age, and its favorite toy, which is this struct, my own data type. And the toy struct has a name and a price. Also, if you read that style guide, we follow this. First we have type declarations, then state variables, then events, then modifiers, and then functions. So these type declarations is what I have declared here. Then we should have a state variables, not these events. So it's a mistake on my side, so I'm gonna just put them here. Now I have these state variables declared, which is my cat and the array of these toys, right? Then we will come to this later. Now we have our functions, and in the functions also we try to follow this order: constructor, your receive, then fallback, and then your functions. And in the functions order, try to have these view and pure as last, right? So in this constructor I am taking a cat details variable, this one, and I'm taking an array of this struct type toy. Fine. To this my cat I have initialized to my state variable, and since I cannot do this here, if I wanted to do something like this, then I will get an error. And what error it will tell me is that this feature of copying a struct memory array to storage is not yet implemented. So since it is not yet implemented, I cannot do that. But of course there is a workaround. I can just iterate over these toys array and push one by one in my own state variable. So that is what I am doing here. So this part is done, this constructor part. Then I have a receive function where you can send the ether. Fine. So external payable purpose is to receive ethers of the in this contract, right? Then a set name function is there to change the name of the cat. Fine. So you get a new name, and only owner can call this function. So here is the use of this ownable part solely here. So we have an old name, this new name is assigned to the cat, and then I am emitting an event. This name updated event I am emitting. I have this index parameter named old name and a new name parameter. So one index type, other not. Just want to illustrate the use. I mean, when we will be going through Etherscan, so I just wanted to show you how Etherscan shows our topics, etc. Then also I have this received ether function. Inside this receive function, whenever some value is received, I'm emitting this event. I'm not putting any Natspec comment here, so but you should in all these public etc things. Okay, so this is the set name function. Then we have this enter toy function. You put a toy and it is pushed inside this toys array. Fine. Then I have a get name function of view visibility to just return the name of the cat, and a get balance function, again view visibility, which will return the balance of this contract. So very simple contract. Just wanted to illustrate how we will put these constructor arguments, as we will see. So that is the contract part. Next, let's write a script to deploy this contract. So I'm just naming it cat.js, and this is the code which I have for it. First we are requiring this ethers from Hardhat. We have seen this before, and then we are getting a signers, only one signer, deployer. So I'm logging on the console the address of the deployer and the balance which this address has. So yeah, that part, and I'm displaying it in the ether terms. So format ether, we have seen this before. Now I am deploying this, and here is the interesting part about how do we pass these constructor arguments. Now when passing these struct, since this is a struct type, our toys is also a struct type, we put them inside this array square brackets, right? each of these items. So in that square brackets, we first pass in the name, then the age, and then since this is again a struct, we again use that square brackets and then pass these favorite toy parameters, which are these name and price, right? So here I have my cat name Mixie, age 1, and then the favorite toy has the name thread, and its price is 0. Threads you can get for free. So I have used these square brackets here. Fine. And now I need to pass in the array of this toys struct, right? So array notation again following that square brackets. Now I have to pass in my struct items. So again I'm using the square bracket for the struct item. The first is the name of the toy and second is the price. So these two, first toy thread having price 0, second toy ball having price 2. So here is the deployment part, and then I'm just waiting for it to get deployed. And then I'm printing on the terminal in the console what is the address of your deployed contract. And we have seen how it is computed from your address, the deployer's address, and the nouns. Next, I'm just querying, since this toy is a public state variable, so it will have a getter function, and in that getter function I need to just pass my index and unsigned integer, and it will return me the corresponding toy. So I want the second toy, so I'm putting the index as 1 and I'm just getting it. So we'll see what it returns. Next, from my deployer account I'm sending some value to it. What I'm sending is actually 3 GUI. So from my account I'm sending 3 GUI to this contract. Fine. So to this cat address, and how much is the amount? 3 GUI. So this waiting thing is also something which we can ignore, not as such useful. So we have this send transaction here, and then this main dot then dot cache is the same as before. So let us run our script and see everything is working fine or not. Here I'm just going to type npx hardhat run scripts cat.js. Fine. So I'm running it and let's see what it gives us. It's taking time, so I'm going to pause the video. So this is what it has returned, compiled 5 Solidity files. So this is the address of the deployer, and it starts with 10,000 ethers. This is the address of the deployed contract, and then the second toy, index 1, it is returning this ball and the value. Also they have returned it in two ways. One is this, you can just put array 0, array 1, and you can also do array dot name to get the named parameter, the ball, and the dot price you can do. We have also seen this before. So everything is working fine here. So let us now deploy it to a test network. So being back to our this Hardhat tutorial page, they have mentioned that to indicate Hardhat to connect to a specific Ethereum network when running any task, you can use this dash network parameter just like this. You put the dash network etc. and you put your network name. In this case, running it without the network parameter will get the code to run against an embedded instance of Hardhat network, just like what we did now. So the deployment actually gets lost when Hardhat finishes running, but it's useful to test that our deployment code works. Fine. And now we will deploy two remote networks. So to deploy to a remote network such as mainnet or any testnet, basically in this Ethereum we have a main network where we actually have value, right? All these ether and smart contracts which you might interact with. But in case for testing purposes, we also have some test networks which we will see. You need to add a network entry to your hardhat.config.js file. We use Goerli for this example. So let us also do that now. But first, there are certain requirements. First, we need to have a MetaMask account. Here, if I show you, this is the MetaMask account which I am having. What you will need to do, first have this MetaMask account. Then switch to this Goerli test network. In case you are unable to see that, in your settings, kindly enable this show test networks. So once that is enabled, then you can switch to this Goerli test network. Then you will need to have private key, This is where you need to be very careful that your private key doesn't leak. So what you need to do first, in these three dots, account details, click on this export private key button. This will give you your private key. Also, this is a test network, test account. I don't store actual value in this. Once you have your private key, what you need to do, inside this, create a .env file. So like this, .env file, and make sure, this is the very important part, that in your git ignore you have this .env file. Basically what it does, the last thing that you will want is that your private key you yourself mistakenly put in, say suppose if you use GitHub, you just push it in your GitHub repository. If this file .env file is publicly available in your GitHub repository, then your private key is as such compromised. So this git ignore file help us to ignore certain what we mentioned here, to not push in the GitHub repository. So this .env file is mentioned here. So in that case, once I am pushing from terminal this GitHub repository, this local folder structure online, then this .env file will be ignored. Fine. So what I want you to do here, create a variable private underscore key, say equal to, and inside these double quotes put your private key. Fine. We also need to have an access to an Ethereum node or gateway. So for that purpose, they are recommending Alchemy. There are also other players, Alchemy, Infura, etc. So I'll be using Alchemy for this tutorial. So sign up inside this Alchemy. What I want you to do is then go to this create app section. This chain should be Ethereum, but the network should be Goerli. Just put any name and description for this video purposes, and then your app will be created. Here I have my own app here, and if you click here, this view key, this will give you the key which you will need to interact with your node. So once you have your Alchemy API key, I will want you to paste that here inside these double quotes in the new line. Next, in your Hardhat, this hardhat.config.js file, we will be configuring our network. But first we need to put in this line. This require this package .env. Basically, we want to be able to use our environment variables. I'll show you how we use them, but we first need to have them parsed. So this package will help us do that, but we need to specify where is our .env file. So .config, we first tell the directory, and we are concatenating this .env file because that is the name of our file. So just do that. In my case, my directory will be whatever you saw, right? YouTube / sample deploy, and then /.env. This will be my overall thing which I am passing in this config thing. So that is for this .env. We also need to install it, and for that just type in your terminal this npm install. You can use I also for that, and then this .env. So let it get installed. Alright, it is installed for me. Now going back to our Visual Studio Code, here is where I'll be configuring my network. So this is how we do it. We have a networks object, we write networks, then these curly braces, then we mention the name of our network, then its properties inside these curly braces, then we are mentioning its URL. We are using these backticks here. So you mention this is common for all these API keys. Then here is where your .env file we are fetching from. So we write process.env.this Alchemy API key, which is what you named, right? And then here also inside your accounts, you can give multiple accounts, multiple private keys, but we are using only one here. So again, in the backticks, we have this dollar symbol is basically we are inserting a JavaScript inside this backtick. So it is a way to have further, just JavaScript thing need not bother here. So we are mentioning here, process.env.private key or private key, fine, inside like this. So this is what I want you to have. Next, whenever you are doing some transaction in the Ethereum main network, you need some ether, right? So similarly here, we will need some ether in our Goerli test network. So they have given two faucets. You can visit these. Like if I go here, you can put your address and I'm not a robot, and then you can use this. Similarly, you can do for that other link. So once you have that all set up, let us now deploy it. So npx hardhat run scripts cat.js, now minus minus network and name of the network, right? So now I'm going to deploy it, run this command. I just did a mistake on my end. You kindly ignore that. So I'm just rerunning it now. So now it is finally done. My balance is also being shown, and this is our address. So let us put that address on Etherscan. So this is the page where I am at, goerli.etherscan.io, and I'm going to paste that address here, my contract's address, and this is where I can see about it, that yes, I have done this contract creation. And if I click here in this contract tab, I see this bytecode, right? And what they are saying, are you the contract creator? Then verify and publish your contract source code today. We will do this so that I can show you some added functionalities which Etherscan is providing to us. And there is an easy way to do it inside Hardhat itself. But first, you need to create an account on Etherscan. So kindly create an account in Etherscan. So visit this page, etherscan.io, and here is where you can, create your account. So, you can sign up, etc., and make your account. Once you have created your account, then you will need to go here where it is saying API's keys and just create an API key. And once you have your API key, I want you to create a variable in your .env file and put your API key there. Next, we require this package, Hardhat Etherscan, and they have given how you can install it. So copy this command and put it in your terminal. Here I am, and I'm going to just paste it and let it run. Okay, it's done. And if I go back, they're also telling how to use it. So inside your hardhat config file, you need to put that. So here I'm just inserting it. Okay. Oh wait, not here, in my config file, right? So here is where I'm inserting it. Fine. So this is done. Then to use it, you need to use this verify task. And how do you use it? Is what they have mentioned here. npx hardhat verify your network name and then your address, the deployed contract address, and then here you give the constructor arguments. But in our case, our constructor arguments are slightly complex. So when the constructor arguments has a complex argument list, you need to do something. Basically, you need to create some file where you are mentioning your arguments. So let me do that now. Here I'm going to create this file argument.js, and here I'm going to paste my arguments. Let me rename it to arguments, sounds better. Just a second. And here I have all my arguments. Now we are using a struct, right? So we use this curly braces for that. So curly braces for that, then the name, mixi, age, then the favorite toy. Again, it's a struct, so I'm using curly braces, and I have mentioned the different parts here. Now my toys array is what I have to give. Since that is an array, I have these square brackets. Now the different toys are different structs. So just using the curly braces here, then the name, price, name, price. Make sure these are the same as what you used when deploying your contract. So when deploying, what all arguments you had, use those same arguments inside this argument.js file. Next, we will need to run this command npx hardhat verify, then the constructor arguments which are present in that arguments.js file, and then the address of your deployed contract. For my case, it is this which I have put here, and then the network which is Gurley. So one more thing which I forgot to mention before I hit enter here. Inside your hardhat.config.js file, you also need to, of course, configure your etherscan API, right? So let's do that now. And inside Hardhat etherscan documentation, they have mentioned that create this etherscan object and then put your API key. So that is what I have done here, my etherscan object, and I have put my APS key here. Going back to our terminal, now let us hit enter. And let's wait for it to get completed. Okay, it's done. It took quite a good time to do. So moving back, let me now refresh this page, and you see I have this contract section verified, and here I can read the contract which we have pushed. I can also see that ownable contract which we inherited from, and this ownable itself is inheriting from this context. So we have that contract here also. All the settings etc. is also present. Then we can also read contract here. So if I click on this get balance, our contract has 3 GUI, right? Which is what we sent. So yeah, 3 GUI, these should be 9 zeros, you can count. Get name, Mixi. Owner, this is for that ownable, and this is the address of my MetaMask address, my account's address. Now this array, we inserted 2 elements, right? So let me query the second element. Now if I have name as ball, the price as 2, and if I query the 0th index, name thread, price 0, right? Just like remix, we can interact here. Now if I click on this write contract, we have these functions. Renounce ownership, this is for that ownable part. Then we have the set name. So if I give name here, say meow. So let's do that, right? Please connect to your web3 provider. So let me also do that here by clicking on this link, connect to web3 MetaMask, and next and connect. So it's done. So let me click on this, cannot read properties of undefined. Okay, so I just needed to refresh the page, and now it is showing me as connected here. So if I go and there is this MetaMask pop-up, so I can just click confirm here and let it do its thing. So I can also view my transaction and let it go through. So I'm just pausing here. Okay, it went through. And if I go back and let us go to this read contract now and see the name, and name is indeed meow. Let's play further. We have these renounce ownership, transfer ownership, need not bother, it's a ownable thing. You can try if you want. So let's give a tuple here. So here I am giving the toy as this having mouse and the price as 3, the name is mouse. So I just clicked on this right and I had this MetaMask pop-up. So let me confirm that and let's wait for it to go through. So I'm pausing the video here. Okay, it successfully went through. So now if I click on this read contract, let's get this third toy which we just inserted. So I'm going to quick query, and yes, I have my toy's description. Also these things, if I look at my contract, this code, we have the events, right? So when we were updating the name, we had an event, only owner can call this, and this receive part also we had this event. So let us also now look at these events, how they are. So now if I go to this events tab, I have this. You see, I have my this receive ether event. It is its signature, and I also, if I show you regarding this received ether event, don't forget to put this 256 when you want to get the cache hash. So 03FE, and if I look here, 03FE, and this is the value which we have. We put 3 GUI, right? So let's see here. If I put this value, then the decimal output which I am getting is actually this only, this 3 GUI. This is 3 into 10 to the power 9. So, and you see I can see my topics being put here, regarding this name updated, for this if we look at here, this first topic is again what we have seen. If I do that check hash of this signature, then you can see F19, and that is what this part is. And can you tell me what is this part? If you may remember, in case of string etc., we will have the check hash. So if I compute that, our name was Mixie, and if I compute its check hash, you see it's D22 etc., and that is what we have here. And this guy right here is a new name. So I think with this you have got good enough clarity. Also, if I click on this transaction, every transaction will emit some logs. If I click here, I can see my event here, and also that data thing is also present. So yeah, so we saw how to deploy our contract. And in case you want to deploy to say Polygon or Avalanche, just Google search deploy Hardhat Avalanche or deploy Hardhat Polygon. So that is what I did, and I can see Google results led me to this page, and they are telling you this guide explains how to deploy on Polygon. Similarly, this guide we have on how to deploy on Avalanche's C chain, which is an EVM compatible chain. So we looked at the deployment part. We also looked at testing, etc. One thing which I missed to say, we had these expect statements, right? And they were used with the help of this chai, right? But besides chai, we are also using waffle here. Waffle is mainly for this Ethereum thing. Waffle is like, chai plus plus. So in chai, it's adding additional functionalities like comparing big numbers, etc. With this, we have come to end of this course. But it won't be fulfilling for me unless you let me know whether this course was of any use to you. And a good way to let me know that is by liking this video. Now I will be signing off, and all the best with your journey.